attraction, right? From magnetism or gravity or whatever.
Don't say right, please. I have no clue what you're talking about.
Shadow Giant says.
Even though I
I've
disagree
been in
with
many
Shadow.
surveyor classes. I employ surveyors. I've taken tests on survey, and I've never, ever heard anyone mention anything to do with a plumb bob and the center of the earth in the same sentence, ever.
Well, that because it doesn't apply into engineering, right? But if you do get into this debate and you talk to people who are, yeah, but who's really surveying? Bob's not a surveyor. Blue's not a surveyor, right? These
then what are we talking about here?
World's famous buster.
Talking about crazy people.
Call it the triangle.
You guys,
I do, yeah.
Thank you, Mike.
Right, so you've managed to confuse a lot of people within that argument. Weird times, buddy. Because like you weren't trying to say that all horizontals are not parallel because you can draw a cross on a piece of paper.
I was temporarily agreeing.
That wasn't the argument.
For fuck's sake.
Because some people have took it as though that is.
I'm sorry. A separate discussion. Happy to talk about that one day. What I originally suggested, and Mike knows this, Mike Jones. We agreed we'd sort of discuss the fifth postulate first. You call it the triangle at the time.
I do, yeah.
I discussed the swimming pool. Thank you, Mike. Question.
Weird times, buddy.
You don't understand. Be quiet. Swimming pool. Thank you, Mike. Question. You don't understand. For fuck's sake. I'm sorry. Thank you, Mike. It's not my problem if you don't want to learn. Thank you, Mike. You're just on your own. Well, that I hold to be a self-evident. You call it the triangle axiom.
I do, yeah. Because it's got just about a triangle, yeah.
The question is, why did include that axiom? You call it the triangle axiom. That postulate.
I do, yeah.
Why did you include that at all? You call it the triangle axiom.
I do, because it sort of shows that triangles have 180 degrees, right? Or the sum of two right angles.
You know? So you're saying how does it show? Be quiet. Well, yeah, it does. I mean, you can prove that, but why did he include that? You call it the triangle axiom. If you can...
Oh, you can prove it?
Be quiet. If you can prove that triangles have... You call it the triangle. The sum of the angles is two right angles. Why would you need... For fuck's sake. Sorry, that's my question. You call it the triangle axiom. You don't understand. You call it the triangle axiom. You don't understand. I was temporarily agreeing. Be quiet. It's not my problem if you don't want to learn. You know? You're just on your own. For fuck's sake. I'm sorry. Horizontal lines can easily not be. Just as I suggested, you just sort of get a horizontal line. That I hold to be a self-evident truth. You put two crossing lines on them, and by definition, any two lines, straight lines on a horizontal plane, are themselves horizontal. You know? So that's the problem. You can't. Well, it's not really a problem. Yeah,
it's not a problem because there's only three straight lines. How fucking difficult can it be?
Point again is that you cannot prove it. A lot of people, you call it the triangle axiom. Millennia thought you could prove the fifth postulate. You call it the triangle axiom. The question is, do we need the enclosure axiom? Yeah, but not on the globe hypothesis. I received opinions we don't need it because postulate 1 will do the job for you. And look, Bev, I simply wanted to ask you why you think the postulate's there, and you have explained that. And you have explained that. But not on the globe hypothesis. That I hold to be a self-evident truth. I'm sorry. It's not my problem if you don't want to learn. Be quiet. You just on your own. I'll be perfectly honest. I'm sure there are better people back at the other place, the blue place, who can prove this. And we're happy to talk to you. No logic, no wisdom, no worries. And you have explained that. You're just on your own. You know. Logic, no answers to questions. And you have explained that. You're just on your own. Right? That I hold to be a self-evident.
It's a self-evident truth of reality that all triangles, in reality, have 180 or the sum of two right angles.
Be quiet. But not on the globe. Well, it's an assumption.
It's not an assumption, is it?
Sorry. For Euclid, it was an assumption because he knew he couldn't prove it. There was a huge debate which went on for centuries. You call it the triangle axiom.
What, that you couldn't prove that triangles have 180
They tried.
degrees?
They thought there was a question: is the fifth postulate? You call it the triangle axiom. Triangle axiom. Is it self-evident or not? Huge debate.
Weird times, buddy.
Thank you, Mike.
Weird times, buddy. You've brought an argument into a group of people that aren't ready for it.
Be quiet. You can't. You cannot. Euclidean geometry.
Horizontal everywhere we go. From that horizontal, we have elevation profile information. That's all we get. That's it. If you want to talk about an exponential rate or a linear rate, we're talking optics. That's a whole other conversation. I'm using these people as an example to show that if we're going to get into a debate, let's go back to where the debate originated from. It originated from the fact that this Earth is massive. Everything we measure and everything we use is Euclidean. But is there something more? Is there something we can use to determine if the Earth isn't horizontal everywhere? And that's the argument. And I use Bernard Riemann as an example to bring up. So if you go and listen to this guy, maybe we can have an honest debate. But that's where I'm trying to go with it, is actually get it to the honest level that it should be, which is the Earth appears to be horizontal everywhere you look with elevation profile information. That's what it appears to be. So there's a horizontal base there, and from that horizontal base, I've got valleys, I've got mountains. Without that horizontal base, I wouldn't have valleys or mountains. That's just objective reality. Bernard Riemann mentions this in a paraphrased way. He doesn't say it the way I'm saying it. But that's what I want to bring up. And it's no different than even, what's his name, Ronald Reagan, saying, you know, if you obey your senses, you end up thinking the Earth's flat. This is what Ronald Reagan says in front of hundreds of thousands of people, okay, during a speech. So that's where I want to get to that point, because once Bob gets to that point, MC2 gets to that point, well, Nathan Oakley's already there. Once you get to that point, everybody's at that point. Everybody's at that point. Everybody's at that point.
Who else want to shout out? Anyone else?
But there's no honest debate. There's no honest debate, dude.
Yeah, you forgot about Rob.
What's going on?
Hey, good afternoon, Rob.
I just need to say I need to apologize to SC Montreal.
That I hold to be a self-evident truth. Yeah, not on the globe.
Well, we're not live yet. Go on, get it done. Right, so you've managed to confuse a lot of people within that argument.
I was temporarily agreeing.
Because like you weren't trying to say that all horizontals
I was just listening to the after show from this morning, and Ken's man.
That wasn't the
I wish we could go over this
some people
today
took it as though
for
that
Free for All Friday. I'm really busy at work, but man, I need you guys to listen to the after show, like near the end of the after show. I had to stop and come and apologize to you, SC.
No worries.
They don't have a fuck clip.
We know he's full of shit. We know that. Now you know it as well.
I was temporarily.
I love you both.
But not on the globe.
So, 10th Man has kind of said some things that perked my ears up, if you will. What was your contention, SC?
My contention is he doesn't know.
For fuck's sake, I'm
sorry. He doesn't know fuck all about navigation, about how to use it. After the angle, he gets lost. Yeah.
Well, there obviously there's two ways for your latitude and several different ways for your latitude and longitude, right? But in the earlier days, using your latitude, what's the issue with?
Do you believe the water surface is a horizontal
just use latitudes to navigate east to west, horizontal longitude. So, what's your contention with that? It's just the way he describes it.
Contention with it.
The surface of either swimming pool is horizontal.
My contention is
no. What's Data's contention with it? Data said yes.
Let's assume.
Well,
the surface of either swimming pool establishes.
Well, the reality is that it all comes down to 60 by 60 by 24. Again, it's all.
It's not a problem because there's only 3 straight lines. How fucking difficult can it be?
Looking at them break down the calculations for navigation, what are they specifying? Are they specifying longitude from a meridian at Greenwich, and then back calculating?
We are live. Free for All Friday. Welcome everybody. Right. We've got Flat Earther in the chat. He's very argumentative, as we've said. We've got problems with angles.
Say my
Again,
name.
all the time.
Say my name, Bev.
Flat Earth.
It's
Flat Earth.
Flat Earth data. It's
right,
Flat
okay.
Earth data, buddy.
Yeah.
Say my name.
Okay.
I'm not afraid of.
There's
not afraid of the
there's
name.
loads of people here. Yeah. I know. I was just letting
Well, just
everybody
say
know. Yeah.
Just say you have
said
a problem
I
with
also
my
said
name.
you are very argumentative today.
Sure, you have a problem with my name, Bev. It's Flat Earth data. Now, can you say that?
It's really weird having one
There you go.
adult male
Thanks,
asking
Bev.
another adult male to say his name. That's
Say my
really
name.
weird. I'm just saying.
Are you Flat Earth data? Are you a flat earther?
So I'm not on either side. I'm here to document the
Either
story
side of
and
what?
tell the story. I'm not on either side of the argument. I'm just for
What
truth.
argument?
The debate that we're engaged in.
We're not engaged in any debate at the minute. We've just
Okay,
been
so
engaged in an
overall-
angular discussion about an angle. Now that's got nothing to do with the Earth, like we've said a lot of times. So what is the argument that you are not on either side of being called flat Earth data?
So I'm not on the side of where there is a pancake disk in floaty space, or there is a Gleason's map that sits in 3D space.
So they're two sides, are they?
So this is the home. This is the home that Flat Earth is associated with.
What is?
And then it's the pizza disk in space, right? So that is the
Is that the
that is
data that you're compiling that together then?
This is not the the main. This is the mainstream versions of Flat Earth and what they believe, right?
Okay, so you're not.
As far as
You're not a flat earther, like, because we had last night a guy called Flat Earth Math in as well, right?
Charles?
Now
Charles is a known liar, yeah.
Well, but he's like you, Flat Earth data, Flat Earth Math, right? Now you can do math and collect data, so there's not much difference. Now he said he's not a flat earther either, and now you're saying you're not a flat earther.
It's not that I'm not a flat earther, Bev. It's that I don't want association with the concept of the mainstream flat earther. So when you say
that's
flat
why
earther,
you call yourself Flat Earth data, because you don't want to be associated with the flat Earth. It's very cunning.
That's not at all the case. Why is that's not at all the case. The case is that the information is about flat Earth. That's why it's called flat Earth data. There is no information about the argument that's in one book.
But there's
one
no
localized
information
area.
about flat Earth here, is there? Like you've come in with an argument about an angle. That's what
there's all kinds of information here, Bev. There's all kinds of information about flat Earth at this channel for sure.
Well,
you have flat earthers. You have flat earthers. You have flat Earth Charles show up. You have flat earthers coming to the channel.
Yeah.
You come.
There's all
you have
sorts
other
of
flat
people
earthers
coming
show
to
up,
talk to
right?
us. Yeah, all sorts of people.
Yeah. There you go. But your show is against non-Euclidean. You're literally the antithesis of non-Euclidean.
No.
Your antithesis. Your antithesis
data.
is
Data.
Stop talking.
Data.
Parallel lines.
Data.
Do not.
Hold on.
Fucking hell, data. What do you think you're doing? This
Well,
is
I'm telling you.
this. Right, we talk about logic, geometry, and reality here, right?
Sure. And your logic
Right, so don't
says that parallel lines.
Don't misrepresent what we do. If you want to talk about you, it's Free for All Fridays. Very good. Just don't free for all misrepresent what we do here. If you do, I will interrupt you and put you right. Right? So what is it you want to talk about? Don't talk about what we do, because what we're doing is now talking to you.
Your show
is Free for All Fridays today.
Show.
So what would you like to talk about today, Data? You've come in here. What is it you would like to talk about? Please don't talk about the show that we're already on, because that would be useless.
We already spent the conversation. I've been here for almost an hour, Bev. You should have started an hour ago.
2 hours.
I've been there that long. 2 hours already? Well, time flies.
Yeah.
You should have started the show 2 hours ago, dude, because we spent all the energy on the conversation.
Okay, so if you're done then, can we carry on and have a show without you then, Data? or would there be something you would like to talk about?
You can do whatever you want. You're a grown man. What I'd like to talk about is the parallel postulate, and the crux of your show is to hold on to the truth that parallel lines will never converge or intersect, right? And the antithesis of that, or the opposite of that, is having
data.
It's intersect. Yeah.
No.
Right. That's the whole point.
No.
And
it's not the whole point.
It is the whole point. It's the whole crux of everything.
It's got nothing to do with parallel lines, has it?
It comes the whole argument between spherical geometry and Euclidean.
What's the argument? Like, we've been over this many times. Please state the argument.
That Euclidean geometry is not useful celestially. Euclidean geometry is useful terrestrially, according to Bernard Riemann, but when you want to map out the heavens and the stars, you need something greater than Euclidean. In this case,
I've never made that argument.
And it's the stars.
This is Bernard Riemann's claim, right?
Yeah,
and
claim, statement.
Shadow giants.
It was also very important to Einstein's general theory of relativity. Without Bernard's equations, Einstein couldn't advance his general theory of relativity, right?
Okay. And he couldn't have done it either unless he put the fourth perpendicular.
What is your claim, Data? What is your claim?
What's my claim? There's no claim other than understanding the argument.
What argument? The argument that somebody else said something about something.
A parallel postulate argument.
Which is, come on, explain to people. They're all tuning in. Okay. There's 23 people eagerly waiting to hear a well-formulated argument about the parallel postulate, as you call it. We call it the triangle axiom.
Yeah, well, it's literally called
the parallel postulate. It doesn't state anything about parallels, though.
It's literally called the parallel postulate.
It's not literally called the parallel postulate argument.
Type it in.
It's called axiom 12.
Type it in. It's called the parallel postulate argument. Go type it in. This is where you can find
that data.
Because there are people that weren't happy.
People call it the parallel.
They weren't happy with
this. To do with it.
They weren't happy when who's they? The astronomers, mathematicians.
Right? Can I just read it out for everybody, Data? Because this is what you're saying. This is you're saying. This is an argument, Data. Your claim.
Yeah, just remember, you're in Bev's house.
Your claim is there's an argument based around a parallel postulate, which I'm going to read out now. And just shout out, stop me when you hear parallel, right? Now, it says, if a straight line meet two straight lines so as to make two interior angles on the same side of it taken together, less than two right angles, these straight lines, being continually produced, shall at length meet on that side on which are the angles which are less than two right angles. So it's about two straight lines meeting on either side of one straight line. Right? Where is the parallel argument in that?
So the argument is when you have two parallel. Okay, so I'll just read the parallel postulate argument for you. Thousands of years ago, Greek mathematician named Euclid laid out the foundations of plane geometry in 5 postulates, which are statements assumed to be true without proof. In today's lesson, we're going to cover the 5th postulate, called the parallel postulate, which states that if a straight line intersects two straight lines forming an interior angle on the same side that adds up to less or 180 degrees than of those two lines, if extended indefinitely, will meet on the side on which the angles add up to less than 180 degrees. Mm-hmm. So the triangle is formed on the side where they can make 180, because it has to be less than on either side of the line, and then where they meet would be the remainder of the two right angles, right? Correct. Okay. So the argument stands that this could not be true for the simple fact is they didn't want the idea that you have to have 180 or less
A triangle.
So what they did is,
because it seems to me like it's about a triangle being formed with 180 degrees on either side of the line, right? It tells you which side the triangle will be formed, because triangles always have 180 degrees.
Yes, I agree with you. So the argument itself is coming from the idea that how do we get a triangle of 180 or greater to have intersecting lines?
Well, in that postulation, right, it would have to be on both sides, right?
Well, that's the point. You'd have to have two angles create a greater than 180, but then still intersect. This is the birth of Riemannian geometry or spherical geometry in sense.
Because you'd have two meeting on either side, wouldn't you?
They do that, but then you have errors, which is called spherical excess, right? Which is the byproduct of
No. There would be a triangle on one side, or are you saying that the triangles would be formed on both sides of that line?
No.
I'm saying if you have a triangle formed on the side with less than 180, I mean, that's good, because then you can make a triangle. But if you have a triangle formed with more than 180, then you could surely have a triangle formed on both sides, couldn't you? One with less and one with more.
In spherical,
you get two triangles formed with two straight lines crossing a straight line. That sounds
spherical. Well, that's the whole point.
Like
that's
impossible.
That's why you guys have your contention. Is
doesn't
because
sound like much of an argument. I mean, are you sure that's the argument?
Hang on, sorry, Bev. He tried to say spherical geometry, but we're not talking about spherical.
No, he is. He's trying to say that that one particular axiom within Euclidean geometry, if you change it, he thinks there's an argument that something based around changing triangles with 180 degrees has something to do with parallel lines. I mean, it's nearly as bad as that one that Stark-Odder did the other day, where he associated a triangle with verticals being parallel.
Again,
similar,
it's not me.
But I mean, it's not. You're talking about on the same plane having a triangle, aren't you? Or are you changing the plane? Have you got some idea of doing something?
It's not me that is coming up with the contention regarding the triangle.
It was you that came in with the argument. You called it the parallel postulate argument. So
that's correct. That's what it's called.
Please state it. Please state the argument. If I'm mistaken, I must be completely mistaken. So please explain the argument about exactly how that particular.
The argument is can an angle greater than 180 have intersecting lines? In Euclidean geometry, the answer is no. In hyperbolic or spherical geometry, the answer is yes. That's the argument.
They're not straight lines anymore.
Correct, and I agree with you as well. But we're not discussing that at that point. We're discussing
if a straight line meets two straight lines. If they're not straight lines, like what the? Are you sure you know the argument?
That is the spherical geometry argument. Yes, you're having curved lines converge and intersect at 290s. So you have
right angles between two curved lines. Are you sure you know geometry?
That is the argument now, isn't it? It's
if a curved line meet two curved lines, is that what we're doing? The spherical
geometry. Sorry, Dada, you're mixing geometries, and that's the problem.
If you have two lines that are at
when you say lines, do you mean a mathematical line, as in straight?
Just draw your sphere.
You're just going to have random. Sphere. Like you're going to call a line like and not define it as any more than between 2 points.
If I took an orb and drew two circles around the orb.
Oh, you're getting an orb first. We're starting off with an orb.
So you're going to have to calculate this, right? Because it's not implausible or unrealistic.
Geometry.
If I took a 12,
we're talking about fundamental geometry.
diameter. If I took a 12-inch diameter ball If I took a 12-inch diameter ball, if I took a 12-inch
I hope
diameter
the audience
ball,
is listening.
if I took a 12-inch diameter ball and then took a marker and drew one circle around it, one great circle around it, and then drew another great circle around it. Those two circles.
Wow, 2 circles round a ball. Yeah.
Those 2 circles wouldn't converge, right? I wouldn't converge. I just drew 2 circles over the sphere. They wouldn't converge. Those 2 circles would be parallel to each other, right?
No,
right?
2 circles would be parallel. What are you talking about?
If I took a ball and I drew one great circle on one side of the ball and another great circle on the other side.
You are model afflicted. Come on.
No, what I'm trying to do is get you guys to be honest about the argument, right?
Ball. We're talking about parallel lines and 2 straight lines meeting another straight line, and you've gone to a ball.
Yeah, because I want you to visualize drawing.
It's Euclidean. That's
you
a
have
sphere.
a point on the ball.
That's Euclidean.
Sure, it's a 2D object. Sure.
No, it's a 2D object. Data.
The surface of a sphere is 2D. Yeah.
You're spiraling, bro.
Surface of a sphere is 2D, sure, yeah.
No, a sphere, in reality, a ball, right? That's 3D.
Well, that's a 3D object, yeah. But I'm drawing 2D circle on a 3D ball, and when you take these 2 lines. So when you take a ball and you take a black marker and you
2D circle on a 3D ball.
Yeah. No. If I take a marker and I draw on the ball, I'm drawing a 2D circle.
Drawing on the ball.
Sure, I'm drawing a 2D circle. The point is that you have a point of intersection on a ball. If you were to have any lines intersect at that point, you would have a base on that ball that would have, according to spherical geometry, you'd have 2 90-degree.
Geometry wouldn't be on the ball on a Euclidean sphere, would they? You don't.
Well, if you're looking at just taking a ball and drawing, let's say, lines of latitude on it or lines of longitude on it, then you're going to have an intersection point.
Lines of longitude on a ball.
Okay, so the point is, gentlemen, is if I had a ball and I had
longitude,
if I had a graph on it,
innit?
If I had a graph on it, yes, sir, longitudes with the time with the sun, sure.
On a ball,
the point is,
the
point is, if I have a measured distance, whether it's centimeters, inches, miles, whatever, between those 2 points, I'm going to have an intersection. The math at this point is doable
from a position on that ball and find your latitude of the ball.
The math at this point
could you find the latitude of one of the points on the ball by measuring an angle? What would you measure the angle to?
Well, you'd have to have a meridian. You'd have to have a 0, and then you would have to measure. Well, you'd have to assume you're on a ball at this point, right?
No, you've got a ball. You're drawing lines on it. Like, you actually have the lines. You've drawn the longitude lines. I'm asking you, can you measure angles on that to put the latitude lines on it as well? On a ball.
You have a grid system, which would have a polar north point.
Grid. Squares. On a ball?
Well, they wouldn't be square.
It's curved. Oh, yeah, the squares wouldn't be square. Of course they wouldn't.
They wouldn't be square. Yeah. So that they're not squared.
So you're the not square grid.
Well, it would be a grid, but it wouldn't be perfect squares.
Square. Yeah.
It wouldn't be perfect squares.
You'd have to
compensate. Well, it's not.
Can we just Google that? Can we Google it? A not square grid? I'm pretty sure.
Well, you can have grids, but they don't mean they're always square. No.
Are you sure?
Yeah, I'm pretty certain. Yeah, you can have grids with all kinds of coordinates on it.
Square though.
Well, you can use in Riemannian manifold geometry. You can have squares and grids bend. Yeah.
Are they not squares?
They're not Euclidean space squares. Nope.
Okay, so
or
not
platonic
shapes.
Nope.
Because the square is
they're
Euclidean shape.
Well, definitely, they're not. It's not.
A square is definitely a Euclidean shape. Yeah, absolutely.
Well, the point is that you can have the coordinate system. So where am I standing at with this argument
what
between?
Point is what?
where I'm standing at with this argument is the fact that if
you don't
we're
even
ever
know
going to
what
come,
the argument is. You've got an argument that isn't even an argument. It's what we call a paralogism.
Your argument is that two parallel
Not my
lines
argument.
will never intersect. Your argument is
I don't have an argument. Like
your
you're the one
show
that's come with the
stands on
parallel
the
argument that you
foundation-
don't even know what an argument is.
Your show stands on the idea that two parallel lines will never intersect.
No. On Monday we do model afflicted, right? I don't know what that would be. I don't think that. Tuesday is logic, right? Now that doesn't stand on parallel lines being anything, and Wednesday is hump day. Doesn't really stand on parallel lines either, because humps are obviously...
You just had a Flat Earth Friday yesterday, right? Or Flat Earth Math come by yesterday, you were saying, right?
Yeah, it was Euclid Day, yeah. Now,
so Euclid,
there are parallel lines in Euclid, but it doesn't stand on them.
Sure.
They're just a part of geometry, right? Parallel lines. Everybody knows that parallel lines are. You can't have a square without parallel lines. So everybody knows what parallel lines are. Now, I've never heard of anybody, well, I've heard a few people, but you're another one that's just said a not square square, which is
hyperbolic,
definitely,
spherical,
absolutely not logical.
It exists in hyperbolic and it exists in spherical.
It breaks the law of non-contradiction because you've got a square that isn't a square.
I understand that. Do you understand why hyperbolic exists and why spherical geometry exists?
I understand contradictions, and I don't particularly
it's about breaking those axioms.
I don't really like talking about them.
It's about breaking those axioms or postulates. That's what it's about. That's all it's about. So
it's about what?
If you have breaking those axioms or postulates,
breaking
in other words,
a self-evident truth.
Well, it would be self-evident unless you applied it to something that you couldn't prove it or back it against. Which
remove
in this case,
the logic.
Yeah.
You
couldn't prove it, but luckily enough, Euclidean geometry is a book.
Well, how do you test the spherical orb in space? You can't. So you have to have some sort of equation or mathematical abstraction.
I'm not the one that's brought it here. Like you're the one. We just go with Euclidean geometry, right?
Yeah, that's the argument. But the point is you don't address.
What's the argument?
You don't address
data. You keep saying that's the argument.
Okay.
Please state.
So again, if you're ready, just quiet. Listen. If I have an understanding of how two straight lines that create a 180 degree will never converge or intersect unless they're less than 180.
Sorry.
Right?
No, wait a minute. Listen. You just said if you have an understanding that two straight lines create a 180.
No.
Please, that's what you just said. Please explain it.
Yeah, maybe you need a rewind button.
Yeah, if you have two straight lines that create 180 degrees.
You just said it again. What does that mean? Two straight lines that create a 180. What? Where? How?
Sorry, it's three straight lines. It's three straight lines. If you take two straight lines and you lay a third line across, it's going to create 290 degree perpendiculars between those two straight lines. Those two straight lines are parallel. Will never intersect unless they're less than 180. The difference with the spherical is that you can have intersecting lines when it's greater than 180, right? And this is the thing that
two straight lines, right? That would form triangles on both
I'm almost done.
sides.
So the argument is that my position is that you both are applicable in functionality. Both are usable in everyday use, right? Bernard Riemann says
Are you sure?
one. Yes, Bernard Riemann says one is used for terrestrial and one is used for celestial. This is out of his mouth. So when I'm saying
I'm
going
to
to
put the thing on, right?
I keep getting interrupted, man. I never get to fucking finish what I'm saying.
I know, it's upsetting, isn't it? Don't worry about it.
It's not upsetting, but you're asking me to come to a conclusion and you keep interjecting. The conclusion is, Bev, is that this show wants to highlight Euclid's principles. Sure, I agree with them, but you're hiding away from the actual argument, which is the intention
going to
behind the geometry.
non-Euclidean.
It doesn't matter what it is. It's the acknowledgement. It's the acknowledgement of the use of non-Euclidean. They use non-Euclidean, dude. It's not like they don't use it.
Where do we use it? Where do we use it?
They use it in abstract calculations. You can use spherical trigonometry. You can use spherical trigonometry. You can use.
You gotta listen to yourself talk sometimes.
And you also have to listen. They can use spherical trigonometry to calculate the position on Earth with the pattern of the moon, okay? So they can use spherical trigonometry here on Earth, right, to locate their position on Earth, okay? So they can do this stuff. Yes, they can.
Trigonometry requires straight lines.
Yeah, it doesn't matter, dude. When you're talking about...
of course it does. No angles.
Trigonometry lesson too, like the other guy the other day.
Yeah,
you're looking at errors in instruments. They both have errors.
Is there like a globe Earth Discord somewhere?
Can I just talk to Saragaki for a second?
Yeah, I was asking
Europe up to a mile to 20 miles off, man. So don't tell me that because they can't use spherical trigonometry that it's more accurate. The point is that they can use it.
I said anything of the sort.
Yes, but you guys laugh. It's not. It's sad that you laugh. The reality is that they can use it.
Yeah, I would.
Come on, man, please. Please, just Saragaki. When I want to do trigonometry, do I need to know the distance between the 3 points?
Well, you can find the distance of the last line, but you would definitely need a right angle triangle. Yes.
All right. Hey, thank you.
Yeah, again, you're not listening, Rob, or you just want to deny it. And that's the disingenuousness of this show, is that you just think it's non-Euclidean, therefore it's not applicable or usable. That's not true. If you actually go look at how they, in early navigation, of why they wanted to use spherical trigonometry, there was a desire for it. Why was there a desire for it, Rob?
Okay, can you have a look at this here, Data? We go through it, because, I mean, it is pretty simple. Straight lines and shit. See me camera?
I get it.
Can you see me camera?
I get it.
Can you see me camera?
Yes, I get it.
Right. Now,
sure, yeah.
We've got these two straight lines crossing this one straight line. Now, if this bit less than 180, you get a triangle formed on this side. Yeah? Yes? You agree?
I didn't. You cut out there. What did you say?
I said, if the angles here are less than 180, then the triangle will be formed on this side, yeah?
You'll have intersecting lines, yeah? Anything less than 180.
Now let's get rid of it, and let's say if triangles can be formed with more than 180 on this side. So you get a triangle forming on this side here, right? With more than 180. What would happen on this side that has less? Would the triangle be formed here as well, or would it only be formed on the side with more than 180 degrees? Let's logically work it out, right? Because we say that this doesn't work. We're going to get rid of this triangle on this side.
Your reference frame goes from straight lines to curved lines.
No, it doesn't. It's straight lines.
You can't apply straight lines to curved lines and expect the same solution.
Well, that's not the argument, then, is it?
Well, this is the argument.
It's not. This is 2D. This is what 2D is.
How do I measure a curved surface using flat lines, right?
This is 2D planar geometry, right?
Sure.
Triangles with 180 degrees. This side.
In early navigation, once they determined the meridian, they could get a Greenwich hour angle. From that Greenwich hour angle, or lower limb, whatever you want, they're using the moon at this point. So they wanted to use the moon to triangulate their position on Earth. This is the motivation of them. So they had the sun, they had all the stars, the Aries, Mars, all that stuff to navigate. But they still wanted more.
On this side?
So I'm just telling you the history, okay? So yeah, they used Euclidean for everything.
Still get a triangle on this side, pretty sure.
So I'm just saying that for the moon, they use spherical. They use spherical trigonometry for the moon, and how they do that is they need two main features. One is the meridian.
Data. Whoa! You're going into overdrive. Whoa! Slow down. We've got a visual aid here of a triangle and straight lines.
Yeah, but you're
so
using straight lines.
Can see. Yeah.
You're using straight lines.
Yes.
The whole point of non-Euclidean
that's what a straight line is.
That's correct, but non-Euclidean isn't straight lines.
Between 2 points. It is.
The
shortest distance between 2 points.
Like non-Euclidean isn't straight lines, so you're not comparing apples to apples. Now, are you?
Who says non-Euclidean isn't straight lines?
You're trying to use an apple for something that required an orange.
So what is a non-Euclidean straight line then?
Take those straight lines and make them curved.
Okay. So you want me to curve straight lines?
Well, if you're going to use spherical,
I'm not going to use spherical. You're the one that's brought it in here.
Well, this is what I'm saying. If my Euclidean mathematics and measurements are lacking something, I need something greater. Well, what's greater or useful? Well, instead of using straight lines,
let's use... What's greater than a triangle with 180 degrees? A triangle that's formed on the side where it's got more than 180. But this triangle would still be formed on this side, wouldn't it? Or do you want us to bend this line here like this?
The whole point is to have, for it to work in their models, they have to beg the question. They have to say, okay, well, the triangles aren't working, but we still need that 90 to get a degree ratio from. So we're going to keep the 90, but we're going to bend the lines to the intersection.
Yeah,
right?
Which side do you reckon the triangle will be formed if we have this line going this way?
So this is why you end up with spherical. This is why you end up with
spherical. Over here on this side here. Obviously.
That's why you end up with spherical excess in the calculations, right? It's because they're assuming the arc length of they're assuming the arc.
On which side of this straight line would the triangle be formed, eh? Which one do you reckon?
You're still using straight lines.
Oh, here it is. This one. Look at that.
You're still using straight lines.
Genius.
They went out. They went away from using straight lines.
How could we use another geometry to come up with a different example of this? I mean, go on.
Because if you have a postulate,
some sort of an argument you said
lines. You have a postulate that requires straight lines. You change the postulate to curved lines.
What?
That's what you do. You change the postulate to curved lines.
Surely somebody would have spotted that. Surely.
You keep the fundamental default, which is the 90.
The mathematicians would have gone, no way. It's not a straight line, it's a curved line.
That's exactly right. They're curved lines, right? So it's a curved triangle,
These are straight lines.
Well, in hyperbolic geometry or in spherical geometry, you're dealing with curved lines, right?
Well, I don't know. You don't mean drawing on the surface of a ball, do you?
Look, the fact is you can use curved lines. You can use non-Euclidean geometry. You can do calculations with it. That's bottom line. This is why
in reality.
Can you see that data?
We're talking about that right now. I understand your point of position. But to get to the actual base of the argument, why you need something is because something is lacking. What was lacking?
What's lacking in that? Is something wrong?
What was lacking in Euclidean? What was lacking in Euclidean geometry that forced him to create spherical geometry or
you tell us
straight lines?
Some sort of an argument you said that they had. I don't know. Go on, explain the argument to us. Because this
on a ball, you can't have parallel lines converging.
Yeah, you can draw on that. That's a ball. Euclidean. 3D.
On a ball, with a piece you can't have parallel lines converging, right? You can't have parallel lines converging on a ball, especially if they're at a 180-degree angle.
Parallel lines.
So the whole point is
that they parallel lines on a ball.
Need.
Is there such thing?
You can draw two great circles.
That's a circle. You could draw a circle. You wouldn't call that parallel, would you?
Well, if you had a ball and you drew, let's say we had it measured equal parts of the ball, and you do two circles on it. Those circles.
Do you think you could draw parallel lines on a ball?
That's the difference. I can draw parallel curved lines on a ball.
In reality, you could take horizontal slices, and because all horizontals are parallel, you could have
infinitesimally, sure. You can break it down to calculus and go small scale, sure, of course. You can take anything.
No, dude.
You can take it.
Dude, I said horizontals. All horizontals are parallel, not calculus. Horizontals, straight
so
lines.
Horizontal at an infinitesimal level, sure. But if you increase
just
increase the size,
just a horizontal, dude.
You can have horizontal on a ball. It just has to be infinitesimally small.
Yeah, slices, boosh, doosh, all the way through. Loads of them. You could have any.
Sure. Yeah, of course. So this is the argument, right? So if the Earth is sections of, if I move every 3 or 4 miles, and I'm doing planar surveying, and I'm doing every 5 kilometer sections at a time.
You're doing planar surveying. How many times have you ever done any of that?
I missed that. Anyway, you're moving in sections.
How many
from
times
5
have you ever done planar surveying?
Just read about it, Bev. Just read about the process.
So when you say
I don't have,
say that you've done it,
the only thing I've ever done is use the law.
Really.
The only thing I've ever done is use the law of sines, and using my quadrant. And now I got a sextant, so I'm using that just to map out where I'm living. So then I get to experiment with artificial horizon and angles and calculate. And then what I'm going to do is I'm going to fact check all of my stuff against sea level. What's that? Look, the information.
Hang on. Let me,
Rob, it's not all lies,
speak.
buddy.
Yeah,
it's not all lies, dude. The whole world we live in is not a lie. Yeah, go ahead.
Let me speak. When you buy a sextant, is that all you do is just use the sextant, or do you need something to like companions to it?
Well, it depends what you're using
Answer
it for.
the question.
Do I need something greater upon my sextant? Well, you need a book. You need a nautical book.
Yep,
that would help.
You need a book. Yeah. On land. You need a nautical book to find your spot on land.
As far as the angles,
all right, cool. Thanks, bro.
As far as the angles and ratios go, I don't need a book. I can use the sextant without the book. And all the book is useful for in navigation is just the sun's declination, depending on this month you're in, whether it's Capricorn or Cancer. You get a declination measurement above that GP position, which is required at a 90-degree angle to get that.
90-degree angle like that I've got there. You see that 90-degree angle on the ball?
Well, I'm just saying.
That's a 90-degree. Does it look like a 90-degree?
In these almanacs,
does it look like all 90-degree? Does it look like all right angles are equal there on that ball?
In these almanacs, Bev,
can you see?
The sun,
I don't have an almanac for language, but can you see that? Because I mean, that's an actual thing. Are you looking?
Yeah. What about it?
Well, see that? That's vertical and that's horizontal. But I mean, on a ball, what's it look like? You think?
Bev, if we were on a massive ball Earth,
does that they look like they're all right angles are equal there?
No, of course not.
No,
of course
all
not.
Right angles are equal, aren't they?
In a triangle, yes, because it's a 90-degree.
Like in reality. All right angles are equal. But if you do it on a ball, it doesn't look like they are, does it? I mean, that's
in terrestrial reality. Yes, it's because we can test those claims, right? The only thing we can do is use abstract mathematics, which are formulations and calculations, which have tons of errors.
No, we can actually do it in reality. We can look at it. We can get a ball, and we can get some lasers like that with lines that are straight, and then we can shine those lasers on a ball and see what happens. And we can see that this is a ball.
Yeah.
Right? Its shape makes the lines not straight. I mean, it's obvious. Look at it.
Yeah, it's the difference between curved lines and straight lines, Bev. That's the whole difference between Euclidean and non-Euclidean.
What, the straight lines?
Or straight lines. Curved lines or straight lines. I'm just the point of me.
So the straight lines in reality are straight, and then the straight lines in non-Euclidean. Or do you mean just like straight lines that when you shine them on the surface of a ball? Wait, what do you mean?
They're clearly curved lines on a spherical Earth, right? Clearly, they're
right. Can we just get this straight then? Right now, do you mean drawing lines on a ball in reality? Is that what you think is non-Euclidean?
No.
Okay. So to you, what is non-Euclidean?
When you take two lines that are parallel and they intersect at a point equal to or greater than 180.
When you say take them, where are we taking them?
Intersect them. Whatever distance they need to be
we
taken
are getting
to
two straight lines, yeah?
Yeah.
And what are we doing?
Well, you have to observe whether or not those two straight lines, when creating a 180 degree, do they intersect?
What, at both sides?
When you use straight lines, they don't intersect. But when you do use curved lines, they can intersect.
Where do they intersect?
At the point of intersection, wherever that is.
Yeah, and how do you know? Are you saying parallel lines in non-Euclidean space intersect at some point? You just don't know where.
Well, depends on the point. Depends on the size of the object, right? I mean, I don't know how long that curved line has to go to reach the other curved line. It depends on the size of the object.
What do you mean, the size of the object? You don't have to be drawn on an object.
If you're measuring the length of something, and it's just a curved arc.
Right, yeah, you're doing 2D geometry, aren't you? You're doing 2D. It has to be on the surface of something. Right, you can't but in reality, when I think of parallel lines, I think of horizontals that are parallel. Right, now they're not on the surface of anything. Like a water level is a tool for establishing a horizontal plane of even altitude. It's not elevation because it's not on the surface. You lift it up. Right? So when you make a horizontal, in reality, it's always above the surface. It's not on the surface of anything. So when I think of parallels, that's why I think like that. But you're thinking of on the surface, aren't you?
Well, if we're looking at small scale, that's what I'd be referencing as small scale for the example of how these lines would intersect, because visually you could draw it on a piece of paper, but it's more accentuated when you actually have a physical object that you're showing the example for. And what I hear is that there's nothing wrong with what you display in your show as far as being, the postulates and everyday average life.
Good. I'm glad Flat Earth Data likes and we've got the approval of the triangles having 180 degrees and things.
The issue is that you think you can get away with dispelling non-Euclidean as it's something that's not used or implied or purposeful.
What is it?
That's a lie.
That's a lie. What? You want non-Euclidean, do you?
No, it's the point of being honest in debate. And what I find is that
you
cower from some things to keep. Yeah, you cower from certain things to keep a narrative here. It's the same with Nathan Oakley. If I approach Nathan Oakley and I say some things, it's the same thing.
Shout out Nathan Oakley.
I don't get along with QE. I don't get along with QE.
Shout out QE.
Nathan Oakley's always
QE over there on the Nathan Oakley. He's also got his own show. Please subscribe to Nathan Oakley and QE. Flat Earth Data probably it likes to do a lot of name dropping, but we were talking about an issue. Right. Data, right? The issue
we're talking about the parallel postulate.
No, you just said we have a problem with non-Euclidean. Now, I know Euclidean geometry. In reality, right? The triangles having 180 degrees.
Sure.
Now, I don't know anywhere where triangles don't have 180 degrees. And that's as far as I was concerned with. And I don't know anywhere where straight lines aren't straight either. The straight lines are straight. It's the shortest distance between 2 points. And like you say,
I agree with
this non-Euclidean has straight lines that aren't straight. But I mean, I don't know where that would happen. I don't know where triangles don't have 180 degrees either. So that's up to you.
So if I took an orange, which is a natural reality, and I wanted to map
You're not going to do
orange.
geometry on an orange, are you? Please don't do. Well,
I'm just saying, if I have an orange, I can put a form of geometry on that orange, right?
Yeah. The point is, you're going to chop the top off.
The point is that you can keep claiming the terrestrial world that we live in is Euclidean, which I agree with.
Are you not going to dismiss the orange argument? Please keep on with it. Don't stop by my point. No, we wanted to see geometry
that we don't use in reality.
We do use it in reality, though. That's the thing. We do use it in reality. That's the thing. Now, is it reality itself? That's a different argument, but we do use it in reality. And when you look at the...
When you say we, who are you putting yourself in the group with?
Okay, so there are other people.
Like, are you saying non-Euclidean geometry is used
so there are
in
other
reality?
Is that,
I just want to make sure that's your claim.
Yes, there are other people that use non-Euclidean in reality. Yep.
Okay, thank you.
For sure. Yep.
Okay, now, do you want to go ahead and explain?
So if we are living on a massive, massive Earth that all around us, terrestrially, it's straight lines and angles. What would be the next step if you did not believe those axioms or postulates to be 100% true? What would you do next?
Data, please. We do logic here, right? So if you start off with an if, right, we're normally expecting a then. Don't if what, because that's a paralogism, right? It's not an argument. If
I'm
what?
saying, Bev, if the Earth is the way it is observably, and I agree that observation-wise, there is a horizontal default. From that horizontal default, we have elevation profile information, whether it's a valley, whether it's a mountain. This is explanatory or self-explanatory in all the maps that we get. The maps match our objective reality, which is distance and elevation information. What it doesn't match is the idea that...
Can you give us the then, and then we can judge what it is you're saying? Otherwise, it's not an argument. Please, formulate your claim.
If I can get it out, maybe you can correct me where I'm going wrong.
Well, we're all listening, all eager.
Bev, the Earth appears to be horizontal with vertical profile information. Vertical and what's the opposite of valleys, hills and valleys, right? Now, we have tools that devised that work in practical everyday life. We use it for building. We use it for everything else. Now, if you wanted to now apply Euclidean celestially, you can do so. You agree, right? But the issue is, you said earlier in this conversation, is that the stars are really far away. You can't use Euclidean to get the distance to stars. You can't measure an angle to it, right?
Whose issue? It's not my issue. Do you have an issue?
Well, earlier in this debate,
because you just did it. If now.
Earlier in the debate, when I was talking with you, you made a joke about hippopotamus, right? When it was supposed to be I can't even say his name now that I've Hippocrates or he's the guy who initially labeled the stars.
Why do you think I called him hippopotamus?
Right? Look, I can't say his name now that you said that.
That's why I said it. Thank you very much.
Hippocrates. I can't even fucking say it now. Anyway, Bev, the point is that the Earth is observably Euclidean. My point is, I'm bringing up other people in academia saying, well, yeah, the Earth is Euclidean, but it has to be something more. And here's why I think it's more. And then you have these other theories and abstractions in math and
what I do? I call that globe Earth society shit, right? Because you're bringing up an argument from nothing that isn't even an argument. And then you're not even pushing it as your argument. It's very clever, I think. Bev. It's genius.
At what point do our instruments fail us that we need to come up with or devise other instruments or other calculations to help us with theory?
So if we have a theory, but you never made a claim.
If we have a theory, the Earth is flat everywhere.
If you have a theory,
well then let's
do you have a theory?
So they map it out. Well, look,
do you have a theory?
Data maps, everything there, right?
Data. Do you have a theory
online? Like again, it's just making sure that when you guys do debate, you guys aren't afraid of actually disclosing the full.
You haven't got a clue what you're talking about, have you? You don't know what an argument is, Data. You've not formulated one. You've not formulated a claim or anything. You're all over the place.
I don't have a claim, Bev.
No, you don't.
I'm not
you don't
claiming
have an
anything.
Argument. You haven't got anything. It's a bit
so the argument is that your show doesn't disclose the use of non-Euclidean. You just hold on to the fact that non-Euclidean is useless because it's not reality. That's not true.
We just talk about shit that we can deal with in reality, dude. We don't deal with fantasy. We don't talk about Narnia either. We don't talk about movies. We don't talk about
guys.
what?
Yeah. If you're going to disclose and educate people, then you should educate them from both points of position.
But what both points? What are you talking about?
Not just triangles, and then earlier you're telling me that to get an angle, I don't need a 90
degree.
Triangles
only have 180 degrees, right? They don't have any more, and they don't have any less. They only have 180 degrees.
That's
you
right.
You don't disagree with that, do you?
No, of course not. I don't disagree with the world presents itself as Euclidean. The world.
So what should we do? What should we say? You might be able to have triangles that have got 8 sides. Is that being okay? Is that being fair to the people that think triangles might have 9 sides? Do we have to have that point of view as well?
5-sided triangle, sure. The point is that
we're not being fair to let people know about that there are people out there that are fucking crazy, that have all sorts of ideas about triangles with more or less than 180 degrees, even though there's mathematical proofs that triangles only have 180 degrees. People that are still willing to argue about it.
And I would also call it kind of a little bit dishonest if you claim to be following the show and say that that's never being talked about or disclosed, as you say.
I never hear you guys
People come in here all the time and talk about it. We address it a lot. You wouldn't even believe how many people come in and say that stupid shit.
Nobody talks about Bernard Riemann with you guys. Nobody talks about Riemannian geometry. Nobody talks about the need for something more than Euclidean and the origins of it.
That's a claim you're making out of ignorance, obviously, because if you were paying attention, you would know that that's bullshit.
It's not bullshit. The thing is that it's there, it's real, it's applicable, and people use it. So if it's there, it's real.
No, that wasn't what I called bullshit. You say nobody talks to us about this. That is bullshit. They talk about this all the time.
I've never heard one person bring up Bernard Riemann.
Yeah, that doesn't make a difference what you've heard or not heard. I've heard. Everybody who has been here when it's been talked about has heard. I'm just saying they have talked to us about it, and when you claim they haven't, you're just making it up out of you haven't heard it.
So they never talked to you about Bernard Riemann? They've never talked to you about Bernard Riemann, not once, dude.
Who are they?
You're the people that show up to this debate show.
You mean in the episodes that you've watched?
So I've been around for a while.
And you've watched every single episode, every single night, ever since these live shows started, have you?
So if you guys are still...
So is that a no or a yes? Or were you going to admit that you just made that shit up because you have no clue?
Yes, I do. I know for a fact because I know the rhetoric.
Because you've watched every single show, every minute, every second of every show.
You avoid it. I literally had to have Rumpus back me here because what I was saying to you guys was true.
Okay, everybody, he has not watched every single show, so he's just pulling shit out his ass. Thank you.
So you guys don't discuss it. You guys just want to brush off non-Euclidean like it doesn't work or it's not part of the conversation. It's definitely part of the conversation. It strengthens part of the Euclidean argument. If you presented the truth about Bernard and the study of celestial navigation when it comes to even navigating on a boat, the fact that they wanted and were desperately trying to use something other than Euclidean. This is what I'm trying to bring up to this show. It's important because to teach the truth, you need to know both sides. You can't just be one-sided. And so flat earth data is not about being one-sided. It's about having the argument in place. So if anybody reads about it, they understand both positions.
So what's the other position then? Go on. If I say Euclidean geometry, Euclidean geometry has triangles with 180 degrees. As such, all circles have the ratio with pi 3.14, you know, that number, and verticals and horizontals are perpendicular always.
Great.
What is?
That's where I live terrestrially. That's where I live terrestrially.
What is the counter argument to that? Seeing as you're the guy that likes to talk about the other arguments.
The Earth isn't flat. Euclidean fails. That's why we need non-Euclidean.
That's not flat.
I'm just saying that's what it is.
No, I was saying about triangles and pi and all of that. I didn't say anything about flat, right? The Earth is not flat.
So there's a horizontal base.
horizontals and verticals are perpendicular, and pi has that ratio, and triangles have 180 degrees, right? Now, what is the counter argument to that statement, right? You're the one that says you're always going to be ready for all of the opposing arguments, right? So if somebody comes to you with a statement, it's not really an argument, a statement. Triangles have 180 degrees, all horizontals and verticals are perpendicular, all horizontals are parallel, and as such, circles have the ratio pi 3.14, right? Give me the prepared counter argument to that, please. Go.
They're not even there. That would be easier done is if somebody like Bob would admit that locally this is true, that these axioms are postulates.
The argument can't rely on somebody else doing something. No, give us the actual argument, the counter argument to it. Well, your flat Earth data, that's what flat Earth data is about, is knowing both sides of the argument. That's the argument from reality.
The counter argument from the globe's position would be that the Euclidean is not...
From the globe's position? What would be the counter argument from the flat Earth position?
Euclidean is not efficient enough to measure celestial situations. So they need something else.
You couldn't, because you can't find a distance to any light in the sky. So yeah, I mean, that's obvious. That's not much of a counter argument. You didn't make that one up.
That's what they need. I didn't make any of these arguments up, Bev. None of these are my arguments.
Who gave you that as a counter argument then?
Nobody gives me shit.
Because nobody, surely you've not done that
in nobody giving me no arguments, dude.
Okay, right. So when I say, yeah, but I said the claim was triangles have 180 degrees and pi, right? You said you can't use that to lights in the sky. That's not a counter argument. I mean, come on.
If you use what I said, Eratosthenes is basic Euclidean to determine the center of Earth, and it's just an inversion of sun angles, because you have two things: either the sun is local causing the angle of the shadow, or it's the curve of the Earth causing the shadow.
This has got something to do with triangles having 180 degrees and verticals and horizontals being perpendicular.
That's the parallel postulate argument, yes, which basically...
it's not. It's not a parallel postulate argument. It's a statement.
Go Google it.
From
Anybody
reality.
Listening, go search the 1300s up. Go type in Bernard Riemann, the birth of spherical geometry or hyperbolic geometry. I'm sure there's some tutorials or lessons you'll go back to.
I just said triangles have 180 degrees and vertical and horizontals are perpendicular.
Sure. I don't disagree with that.
But why did you say that's the parallel postulate argument?
Because if you have a triangle, or two straight lines that are perpendicular or parallel that equal 180, they will never intersect. Because these are straight lines. But in the non-Euclidean, they want to claim that the straight lines will intersect at 290s.
Oh, okay.
But then the only way that's possible is if those lines are curved. Right? So
your argument to when somebody says triangles have 180 degrees, you say non-Euclidean. That's an argument from the 1800s. Go and research it. Google it.
No, that's not what I said. I said if you are a man on this earth and everything terrestrially is Euclidean, what device or tool or method do we now devise or create to determine if there's something greater than our terrestrial Euclidean environment?
We use triangles with 180 degrees to do trigonometry.
Sure.
Yeah.
Sure. Yeah.
In reality.
Practical. That's correct. Terrestrial. That's correct. Okay. Is celestial, they don't use, well, they still use, but they have other coordinate systems. I've never done
any celestial geometry.
They still use Euclidean, Kepler, all those guys, Newton, all use Euclidean. It's all.
You can't measure a distance to the lights in the sky. You can measure an angle. Right?
I understand that, Bev. It's well known. That's why it comes down to the Eratosthenes inversion of sun angles.
It's either the sun. What?
That's correct. It's either the sun is...
What, for triangles having 180 degrees?
No.
And pi being 3.14?
The height of objects in the sky using... The height of objects in the sky using Euclidean. The sun angles
measuring an angle
to the sun in the sky. Correct.
That angle is Euclidean, right? That's a Euclidean angle.
Sure, it's a right angle triangle. Yeah.
No, it's an angle.
It's a right angle. You need a right angle to get.
It's an angle. You can measure.
Yeah, and you need something against it to get the angle degree. Without something to measure against, that angle is useless. You have
you've gone broke
no
again.
number.
No, you can just measure an angle.
Okay, so the angle has a parameter. You're getting a section of that parameter. What's the parameter when you measure this angle? What is it? Is it a circle parameter or is it a right angle triangle parameter?
It's just an angle.
So a sextant uses a circle. Trigonometry uses the right angle triangle. Right? So what parameter are you talking about?
A circle. It uses an angle.
Well, it's an arc. It's an arc, isn't it?
Finding device.
Sure, but it uses 1/20th of a 360-degree circle.
Do you know how it works? Do you know how? Have you ever used a sextant?
I have a sextant in my possession. How it works, it measures an angle. That's what it's designed to do. Whatever object I have in the ceiling, I bring down to the horizontal point, I'll get an angle position for it.
Okay. Now you've got a mirror that doubles the angle.
Sure, yeah.
Right, okay. So that measurement of an angle, can you have... What sort of angles does it go? It goes measures from
0 to 120.
Okay, so you could measure an angle of 2 or 3 degrees, couldn't you?
Sure, you can get pretty precise on a sextant. It's a very beautiful instrument.
Okay, so it measures angles anywhere from 0 to 120 degrees.
Well, that's what the arc bar says anyway. Mine says 130 actually.
Wow, nice.
But
so you can measure an angle, right? So well done.
Yeah, but this is using an arc, right? It's using a circle to measure an angle, correct?
An angle is just the inclination of one straight line to another, right?
Mm-hmm, but it's using the sextant uses an arc to get that, right?
It's an angle measuring device, yes.
But
what you do is you bring two objects together, don't you? Using the mirror.
You create a vertex, yeah.
Yeah, you use the mirror in order to bring two objects together in your field of view. And then you read the angle.
Sure, yeah.
Okay. Right, so that's it. It's easy, isn't it, to measure an angle?
Wait. Let me add on. And then you apply that angle and your time of day and a bunch of other shit to a book.
No, so you can calculate. Okay, so with just your watch and Greenwich time, if you have a watch set at UTC, you can determine your longitude just with time in the sun. Your latitude, you need a little bit more information, like declination of the sun. But you can also determine your latitude from Polaris. But in this case, when you're on the boat in the ocean during the day, you're going to need the declination of the sun, which you can locate your position with a sextant as long as you have that declination of the sun. The issue, Rob, I don't know if you know this, is that declination of the sun is a right angle triangle. From the point that you measure it to its GP zenith position creates a right angle triangle. That's what it's called. It's the declination.
You have a triangle, do you?
Well, to get that nautical number that you add, plus or is it plus? I can't remember now. North is positive.
A nautical number.
Is that like a line that forms the last line in the triangle that you're trying to?
So in the book, the nautical book
right now.
In the nautical book, depending on the day that you are and the time you are, will have the declination of the sun. Through that declination of the sun.
The last line in the triangle you're trying to conjure out your ass right now.
That's the GP position. So the GP position of that sun will be a zenith position.
The GP position.
The GP general position of that sun.
The general position.
The zenith position of the sun, if you will, wherever it is over the equator.
The position of the sun.
So the subpolar point. Is that better enough for you? The subpolar point of the sun. The subpolar point of the sun. The position where the sun hangs over the Earth. The position where the sun hangs over the Earth.
The sun has a pole, does it?
the position where the sun hangs directly over the Earth, the zenith position, the GP position of the sun,
like
the GP position of the sun
in a straight line.
The GP,
is it hanging in a straight line?
The GP of the sun creates a right angle triangle to the observer using the sextant. So when you get that angle,
of the sun, that's nice.
Yeah. Does that not make sense to you, Bev?
I'm just going. You carry on. I'm just making sure everybody's up to date on all of the terms.
Right. So you do need the declination to use a sextant to find your location, but you can find your longitude with just time and I think you do actually have to add in longitude. I have to go back and read it again. In longitude, I just wrote this down actually.
Just reading the script.
No, I just been you don't use it, you lose it, right?
Here we go. Have a look at that. So I'd never really. I wondered why I was thought, because I always thought elevation and declination was like the opposite. It was looking down. But I mean, is there an opposite to elevation?
Well, elevate and decline, right?
Okay, so
that's what it's described as. It's described as the declination
angle,
and that would.
But because I've heard a lot of people talking about angles, elevation angles. Would it be anything like that? But it seems like declination is the opposite. Is it?
Well, you're measuring your.
Right?
Well, it makes sense, right? If it's going to decline, it'll be a declination, but it's just
the opposite of an elevation. Then would seem to be.
Sure, but it's still an angle above something, right?
Oh, an angle above something is the declination. So I thought that was an elevation angle on myself. Could have sworn.
It would be the declination. It would be the declination above or below the equator. I believe that's what it is. That's how you get your declination angle.
Oh, right. Like it says there, in astronomy, declination is one of the two angles that locate a point on the celestial sphere. So is that a declination is only due to the celestial sphere? That's why I'd never really heard about it, because I don't deal with
using a nautical
celestial spheres or anything.
Yeah, when you're dealing with nautical,
how far away is that celestial sphere? I mean, how big's the radius to the celestial sphere? Do you know?
Well, again, go back to Eratosthenes' example in the inversion of basic Euclidean sun angles. You would get the same circumference if we were to measure the 500 mile. If we were to measure the 500 mile distance between 2 points, the circle.
The sphere?
The circle.
Yeah, which circle, though?
The 2D circle. So if I used a right angle triangle...
circle? The celestial sphere?
No, just a 2D circle that we use Euclidean for.
Yeah, but I was asking you about the declination, because it says that locate a point on the celestial sphere. And then you started talking about circles, and I asked you what circle?
The declination angle is above or below the equator. Whatever GP position is at the time of the reading of the sun, well, that's where the 0 point is, and then everything from
celestial sphere has an equator, does it?
So the equator has a 0 mark, a reference frame. This is what they're using to get measurement of declination of the sun.
Now, wait a minute. Are we talking about the equator for the celestial sphere, or the equator?
Talking about a reference. Talking about a reference point where they,
like where it's hot, nice and warm.
We're talking about a reference point of where the GP of the sun is, based on the season that you're in, whether it's above the equator or below the equator.
On the celestial sphere, because you're talking about the declination, or the GP on the globe sphere.
I'm not begging the question on either one or what it is. I'm just talking
You're the
about
one that brought it up. I was just curious because you brought declination up. Like I say,
yes,
I've heard. Have you heard the argument about the elevation angle?
What argument about the elevation angle?
People make claims about an elevation angle proving something. Now, can you just...
elevation angle proving something? You need more information than an elevation angle. You need more than that.
I know. I say you can do fuck all with an angle, and you can measure an angle anywhere. Right? But you say, you're one of the people that say you need a 90 in order to measure an angle. I don't agree with that statement either. I say you can just measure an angle.
Well, how do you get an angle? How do you get the angle? You have some parameter.
Like I say, some people claim things about angles, right? I'm not one of them, and we can just have a discussion about it if you want.
To create an angle, you don't need a 90. To deduce what the angle is, you do.
Well, can you just run us through the difference between a declination angle that you talk about to a celestial sphere and an elevation angle that I think people who do
this is navigation language.
Yeah,
this is navigation language. This is the language that they use.
Well,
so I was addressing
elevation
Rob.
angles is definitely
I was addressing
navigation.
Rob. I was addressing Rob that you can use a sextant and to find your location on Earth.
But that's an elevation angle, surely.
So the declination is the point above or below the equator, according to their documents, which gives you a reading of an angle, depending on the season. So whether you're in the north and it's the summer, it'll be above the equator, or you're in the north and it's the winter and it's below the equator, you're going to get a declination measurement based off of the equator. That's what they say. That's their language. Now you're asking me what's the difference between declination and inclination?
No, elevation. An elevation angle as measured with a sextant, and the declination angle that you say that's measured within navigation. What's the difference?
So in the summer, the sun is higher above the horizon than in the winter. There is a declination change between those two seasons. That's the declination information that you can use in accordance with your sextant to calculate your relative position on the Earth.
Okay, so we measure an angle and then we get the declination angle that we can use to find where we are. Is that right?
Well, there's a little bit more to it. I mean, you obviously
where do
can
we
find,
get the declination angle from? Where do we get that from?
You get it from a book they've already written it down in a book.
So we measure the elevation angle.
We measure the elevation angle of the sun, and then we subtract or add. I think we're in the north, so we add. I can't remember now. We add the declination to.
Add an angle to the angle.
That's correct. Yeah, and then you'll get your latitude.
So extra angles. Is that where the non-Euclidean bit is? We've got these are your extra angles. We'll just bung in.
There's no Euclidean use in this. Or sorry, there's no non-Euclidean use in this. It's all Euclidean.
Well, adding extra angles seems to be, if you measure an angle and then add more angles when you check a book, that doesn't seem to be Euclidean. You know, like adding more angles.
If you look at the GP position of the sun and how it's deduced for declination,
they need the sun. You're just measuring an angle to it, right?
Correct, but that GP actually has a physical location on Earth. That sunspot actually has a subsolar point to Earth, right?
Wow. Okay, so you can get a distance then.
I didn't say you can get a distance. There's obviously a ratio you can divide.
If you know where the sun is, you can get a distance to it.
Well, if you're looking at one observer, he's going to have one distance. If you're looking at a couple of different observers, they're going to have a couple of other differences in distance, right?
Right.
So
right.
no,
well, I mean,
Euclidean.
That solved a lot,
Euclidean,
right?
You just proved why Euclidean fails.
Well, no, I'd say Euclidean geometry says you can do fuck all with an angle, but you say, right, what you can do is you can measure an angle to the light in the sky, the big light in the sky, and then look at a book and look for your angle, maybe time, right, the time of day, and check up the time with an angle, longitude. And it'll go, boom, that's where the sun is, and you'll go, brilliant. Now you know you've measured an angle then, right? You can know a distance. You must know the distance to one of the lines of an angle. That's fantastic. I never knew you could do that. That's definitely not Euclidean. right? Absolutely
how did they
not.
How did they devise 752 or 756 meters? How did they devise a 22 centimeter object at 756 meters will create a 1 minute arc?
We don't know.
They devised that through optics,
that again.
right?
I think you might have messed that up again. Give us a.
So the object is 22 centimeters in size.
An object
in diameter. Yeah, it's 22 centimeters in diameter.
Like a football. Maybe a small
football. 750. It's 756 meters. That football produces a 1 minute of arc.
1 minute.
Right.
Wow.
Yeah. So that particular distance and that size of the object will actually give you 1 minute of arc. The angular size.
There are
right?
some people who say they can get a second of accuracy. Yeah. They say they've got tools that can get a second over that sort of distance. Amazing, isn't it?
Look, there's all kinds of reasons why they don't want to conform or be limited. My point of expressing my position here is showing the need. Yeah, showing the need to go above and beyond Euclidean and why.
Above and beyond Euclidean.
Of course, yeah, because it's a limitation. A lot of these people who are trying to discover our cosmology and where we live in, spending millions and millions of dollars, whether it's ships, whether it's rockets, whether it's flying planes, spending millions and hundreds of millions of dollars to figure out where we live. Mm-hmm. You had a push in the 1800s, and I said this many times, you had a major push from a lot of philanthropists, if you will, or millionaires, paying people thousands, hundreds of thousands of dollars to create math, to create models, because they were not happy with Euclidean geometry. They were not happy with the world being a stationary flat plane. They were not happy with it. This is the way I look at it, the way they were actually angry about it. So they were actually, back then, they were anti-flat earthers already.
Who are we talking about now? Shadow Giant says what? Who are you talking about, Data?
Well, people who wrote about Lucifer, earlier scientists that wrote about Lucifer being the light bearer. Earlier scientists claiming that the world itself is an orb spinning in space, right?
Who are you talking about?
Earlier Christian scientists
talking about people at Gem Panda's server on Discord.
S. Valid Newton.
Gem Pandas.
I don't know that.
No.
I know Gem Pandas. Yeah, but what about it?
Well, Mr. Sensible.
What about Mr. Sensible?
Toon. I'm just wondering who said these ridiculous things that you're claiming. Because anybody could come in here and say people have said all sorts of stupid shit, right? Because people have said all sorts of stupid shit. It's not an argument to say people have said stupid shit.
Bev, people don't want to be limited. And the argument stemming back from the 1300s shows you that they were trying to rewrite the parallel postulate. It all comes from there.
That's not an argument.
Oh, just type in parallel postulate argument.
It's the mismeaning of an axiom.
Parallel
and that axiom states that triangles have 180 degrees.
Correct. I understand that.
Can I just address Data's little Google thing first? Mm-hmm. So, just Googling the term parallel postulate doesn't make it a true.
Just type in the argument afterwards.
Yeah, I don't care about the argument. Yeah, they wanted the argument because they wanted it to be a ball spinning in space.
You understand that. That's the whole point. But here's the thing. But the application
the argument is the point.
The Earth cannot be flat. Here's how.
It's not flat.
The Earth isn't flat. Here's how.
That's not an argument.
Sure,
we already know
it's not.
If you're claiming, sure it is. They're claiming that Bernard Riemann even says it's fucking flat in his own writings. So it's
not
the
flat,
point.
Though. I mean, that's moronic. What's your definition of flat? What's your definition of flat, Data?
Flat is a description. The Earth is not perfectly flat. No. Flat in reference to orientation. Flat in reference to orientation.
Flat
the Earth
isn't an orientation.
It's a description. I get it.
Flat is not an orientation.
That's correct. However, all points of position across the Earth is horizontal. All those positions of horizontal across the Earth would...
this bullshit. All points are not horizontal.
All points of position on Earth will display a horizontal plane Earth. Yes, absolutely, guaranteed. 100%. You can't negate that. And I have proof for that too. I just used a larger water level at each point of position. It's horizontal. Now, is it equal altitudes of position?
All horizontals are parallel. Yes,
that's correct. Right, all those horizontals that I get it.
It's not horizontal. The entire Earth is not horizontal. Like it is not flat.
Okay, here I'm going to clear it for you.
Horizontals are all horizontal. I've said this many times, Data.
Each individual...
I'm really struggling as to why you think there's an argument here.
The argument, Bev, is talking about the parallel postulate.
What an argument is. It's not an argument to talk about a misunderstanding of a triangle.
You have one position. You have one position. I have another position. They don't agree. It's a disagreement.
What's your position?
My position is to be a truthful seeker, to be a truth seeker, and to provide accurate information. Is to not to run away or be afraid of spherical geometry. And
I'll state again, right? Application that there is in reality, Data. There is a proof in reality that triangles only have 180 degrees. Right?
And there's also a proof in spherical geometry. There's also proof in spherical geometry that a triangle greater than 180 can have intersecting lines. That's that simple.
Yeah, I get you. Stop and give us the dictionary definition read aloud of spherical geometry, please. No obfuscation, please. Yep, bring it up right now and read it out, please.
Well, it'll mention a triangle being greater than 180.
The definition of spherical geometry will not read that.
You have not given us the definition of spherical geometry. I'd rather not hear you until you give us that. You need the Jeopardy music? I can go do.
Well, I'm making sure that I bring it up. It's brilliant.org. Spherical geometry is the study of geometric objects located on the surface of a sphere. Spherical geometry works similar to Euclidean geometry in that there still exist points, lines, and angles. For instance, a line between 2 points on a sphere is actually called a great circle of that sphere, which is also the projection of a line in three-dimensional space into a sphere. However, it differs from typical Euclidean geometry in several subtle ways. There are no parallel lines in spherical geometry. In fact, all great circles intersect in two antipodal points. Angles and triangles, each side of which is an arc of a great circle, add up to more than 180 degrees. Line segments, arcs of great circles, have bounded lengths, and regions on a surface of the sphere have bounded areas. Spherical geometry is useful for accurate calculations of angle measures, areas, and distances on Earth. The study of astronomy, cosmology, and navigation, and applications in stereographic projection throughout complex analysis, linear algebra, and arithmetic geometry. Projections throughout complex analysis, linear algebra, and arithmetic geometry. Whether or not they know it, nearly everybody relies on spherical geometry sometime, just to consider the best way to chart a plane's course. So that's one example of spherical geometry. And this is brilliant.org. Did you hear me?
Yeah.
So what I'm saying is it appears that a lot of people in the arena would rather brush it off as something that it doesn't apply. But in reality, what I like to do is actually dive into it and figure out the story of why it was created and what's it used for. And then once you find that out, how can I apply that information to test the claims? What I find out is there's no way for me to plan a route with an aircraft as a commercial jet because I don't have access. And when you do find out, you're just given coordinates to enter into a machine. So you don't even, there's no plain fucking route that you map out.
Coordinates? Do you fly?
Oh, I did just small planes, but years ago I stopped pilot school years ago. Just a small light wing. I did a Cessna, and then I did a ultralight plane, but basic navigation. We're talking like 200 miles, real easy shit. And I've only got maybe 12 hours in the last 20 years. So fuck all with really real down to nuts and bolts, right? So, but I wanted to go back, but I also don't want to die in a plane crash. So
did you use spherical angles then when you did your flight plans?
So the best part about using a plotter and beginning course in ground school, it's all Euclidean. Everything about the map that you use is distance and elevation information. There is no calculation whatsoever for spin or curvature. Zero, nada, nothing.
What about triangles with more than 180 degrees then?
You never use any of that in practicality, none of it, zero. The only time that you end up using anything in sphericity that I'm experienced with would be the Haversine symbol or the spherical trigonometry for calculating the moon and your position relative to the moon on spherical trigonometry. Those are the only things that I've come across that you can use spherical for in daily life.
Moon.
That's it. Yeah, so what they wanted to do is they wanted to find their position on Earth based on the position of the moon, but the problem is Euclidean wouldn't help calculate the orbit of the moon properly. They needed spherical. Apparently, I haven't tested this claim out myself.
You couldn't work out with Euclidean geometry an orbit.
They needed a meridian first for time, and that was once they established Greenwich time, because I believe it changed 3 or 4 times throughout time. The main time meridian.
Is there any such thing as an orbit in Euclidean geometry?
Well, that's the description of the path of the heavenly bodies. They call it an orbit, right?
In Euclidean geometry, that would.
No, in celestial navigation, when using the Haversine or using spherical trigonometry with Euclidean, right?
Okay. So when would that have come into play then?
I actually haven't gotten down to the nuts and bolts of
the history
I started with the history.
Non-Euclidean.
No, I started with the history, but I haven't applied. I've gotten up to the look right now with my sextant. It's all about actually trying to figure out my location without using the declination of the sun.
You're going after McToons's 10K.
No, I don't need the money. I don't need that, and it's bullshit. It's a waste of my time. There's no money to earn from that guy.
What do you mean?
If I thought it was
what do you mean? No, you've got to go for it. Don't be one of these ones hiding back. If you're one of the Sextant experts that are talking about it, you should be going and spanking McToons all over the place.
I'm an adolescent when it comes to the Sextant because I've only been on the boat a handful of times, and when I've been on the boat, I never really.
There's got to be a good flat Earth team of Sextanters. I don't know what
you're going to come back. But the problem is, Bev, it's all going to come back to the foundation.
Oh, Chris is in. Chris knows about angles and stuff as well.
It just comes back down to the foundation. It's like asking me the declination. How do they get the declination in the book, right? What premises did they use in the book? All of that declination information use straight lines and angles. All of that declination information that I'm familiar with in the nautical books.
The inclination of one straight line to another. I mean,
exactly. That's what these nautical books were designed with. The straight line. We're designed with straight lines and angles.
It's like radiuses, isn't it? Radii.
Sure. Mm-hmm. But applying the knowledge to reality is what everybody should do, and not be afraid of this non-spherical, non-Euclidean bullshit. Because if you understand why they...
Did you say?
Yeah, non-Euclidean.
Was that a mistake? Like, was that non-spherical, non-Euclidean?
I meant to say non-Euclidean and Euclidean. Yeah.
No, I don't think anybody's afraid of non-Euclidean. I just personally...
It just seems like it.
Well, no, I just don't see the use in it. Like, I can't think of anywhere where I would ever use it. And as far as I know, like, a straight line's a straight line. It doesn't stop being a straight line. So horizontals are straight lines.
Yeah, and that's these almanacs, these maps. They all rely on straight lines and angles, and time, and that time, that 24-hour a day circle in 60 seconds by 60 minutes, that plays a huge factor in all of these calculations. Without that 60, which the sextant is based on that 1/60th, right? So it all comes down to time. Without the time.
You mean?
Yeah, so the sextant is 1/60th of a, or I might have that incorrect here. What am I saying? It's
read your notes.
100.
Come on.
No, I'm not reading notes. I'm just looking at my sextant. I can't remember now. 1/60th. It measures 1/60th of a circle.
It's a sixth sextant. Sixth.
Yeah, and
but you've got the mirror that doubles the angle, so that's like a third, isn't it? With 120.
I got a Davies.
120 is a third of 360. But a sextant, sex is sixth. So
yeah, is it 1/6?
It would be 60 degrees, but like I say, the mirror doubles it, gets to 120.
Right.
Yeah.
Anyway, it's a beautiful instrument.
How much did you pay for it? What model have you got?
This one here is about $350. Wow. It's a Davies. Yeah, it's not the Prime Daddy, dude. I could have spent way more money on the Prime Daddy, the fucking real deal. This one here pissed me off. I bought it from India. It pissed me off. I mean, calibrating it. It's the 1712, the Tamiya Sextant, but it's the Davies or whatever. It's the Davies model or something. I don't know. It's called the Tamiya 1712.
Wow.
So it's a replica, obviously, of that one. I had a smaller one before, but these instruments are awesome, man. The ratios, like everything coming down to ratios. What I'm trying to figure out next is one degree of one arc minute is
I've got a protractor here, big one. Great big one.
Sure, it does the same thing.
Costs about £5.
Yeah, it does the same thing. You can get an angle from it.
Yep.
You can. I don't know. Well, I don't know how that would work. Actually, you would have to have a separate arm and index arm for that to index your point.
You just get a more accurate angle, right?
With this, well, yeah, ideally, if you're dealing with a micrometer, right?
Uh-huh.
Anyway, Bev, you shouldn't be so scared of non-Euclidean, and
it's not scary at all, mate.
It's like when you get into this debate.
I tell you how scared I am of it. I know I'm never going to see a triangle with either more or less than 180 degrees, right? It's like knowing that the ghost that you fear will never come.
But Bev,
you know how much fear there is of that.
But you see it in spherical geometry. You see it in Riemannian manifold calculations.
I can see a sphere.
You see
right? But I know that that's a Euclidean three-dimensional shape. I mean, that doesn't bother me at all. It's sort of worrying that people think it's 2D. That's a little bit worrying.
The surface would be 2D, right? The surface of a sphere is 2-dimensional, right?
A sphere is a 3-dimensional object, right? In reality,
the object itself is 3D, yeah.
Yep. But the surface of it is 3D as well, because that's what you're looking at. I mean,
not the surface of a sphere.
Yeah, you're looking at the surface of a 3D Euclidean shape.
Data, is the surface of Earth 2D?
Well, you'd have depth, so no.
And thank you. So Earth is not a sphere.
It's a point of horizontal with elevation profile information. That's what it is. The orientation is horizontal with equal points of parallel horizontals, creating sea level.
That's how you have parallels.
Yep. That's why you have sea level as a default setting, because they're points of parallel positions. Yeah, it's a default. We have to have a default. These tools are based on a default setting now. What's a mean?
A mean.
Oh, mean sea level. But mean sea level is an average based on a typical wave height, right? So when you have sea level or mean sea level,
it's mean. Do you know what mean is? I mean, mathematical.
Well, it's an average, right? If I have 10 different numbers and I take 10 and I divide it by 10, after I add up all the numbers, I'm going to get an average, a mean average.
A mean, yeah. So that's what it is. Mean sea level is a mean. That's a position to start from a zero.
I know, but when you say mean sea level, though, it's that. Yeah, I know, but mean sea level is technically not flat.
It's a point.
I know, but it's technically not flat.
It can't be flat. It's a point on a vertical datum set at 0 because it's a mean. It's an average.
Yeah. Bev, you should just break out Bernard Riemann and start destroying the. When you have this argument again, at least you can educate the ballers. Even in mainstream academia, they admit that the Earth is Euclidean. Okay.
What?
No dip, no drop, no
3D.
Curvature. It's Euclidean.
3D, solid. We can explain it as in Euclidean geometry, book 11. Yeah? 3D. We can measure straight line distances. Yeah.
But then what I'm saying is that if you, because it's all about getting the other side to be honest, right? And including the flat earthers.
Don't have to make, nobody has to make anybody else be honest. It's up to the individual whether they want to be honest or not. Right? I'm hoping people can see, and when they're listening, they can judge who is honest and who isn't by the conversation that happens.
How does a debate evolve? Because if you allow somebody like,
where are you going to?
If you allow somebody like MC Toon to continue on, which
shouting out MC Toon, shout out MC Toon. He has a YouTube channel. Have we got it? Have you got a link?
I don't care to promote these fuckers. I don't want to promote these fuckers. What are you doing?
Why? No, you're the one that's doing it. You're shouting out MC Toon.
I'm using an example. of this guy, McToonery. McToonery. So he wants to continue on in a debate, but not acknowledge why there's a debate. He just wants to debate. I'm saying acknowledge why there is a debate.
He wants to debate. Who does he want to debate?
Yeah, it's hard to debate people who don't know the history.
Is he putting a shout out for a debate?
Who cares?
I don't know. You're bringing it over. You're saying that's your argument.
Listen, MC Tool is just that. But why does everybody let him get away with fucking the bullshit?
Do you want to debate with MC Toon?
Do I? I've already debated the guy. It's all good.
Okay. You hold a bit of a grudge or something?
The guy lied to me about visible and invisible light, whether or not you can use the Rayleigh criterion on it. So I don't need to debate the guy any further. I know that he's lying straight out.
Light.
Yeah, infrared. Every wavelength of light has a diffraction and refraction limit.
Okay.
So we're just talking about that.
I don't want to get into your argument with Toon.
Sure.
But were you making a point somewhere about, or are you just shouting out?
The point is that if they all understood that academia needed something more, why did they need something more? Why did they need to advance?
Again.
Well, that's what they don't want to answer.
I have a question.
Because you can't have non-Euclidean without Euclidean first, right? So why was non-Euclidean first invent or reciprocated after?
Hey, Dad, can you make some room for Chris Berry to speak? Look, give him a chance.
Yeah, sorry, I've been listening for like an hour. It's just like no time to jump in.
Yeah, thank you, Chris Berry. Thank you.
What did you all see? You're talking about the elevation angles and all that stuff. Did y'all see MC Toon's newest challenge, the globe?
Tell us.
Also, he put out a globe challenge.
We're shilling tunes again.
Yeah, he provided 3 angles to 3 stars, or 1 angle to 3, 3 different stars, 1 angle each, and the times of those angles. And he asked for someone to provide his longitude, latitude. And he said within 4 minutes he had a response correct response of someone giving his position within 25 statute miles.
Wow, give him a cookie.
A few angles and some timestamps in the stars.
Wow. Who's that famous guy? I bet he'll be making videos and doing all sorts of stuff, right?
What famous guy? It's not. It's multiple people submitted, and apparently multiple correct answers or different solutions to the same answer or something.
Sweet.
So,
maybe they should go get their 3 Bitcoin then.
Yeah.
3 Bitcoin.
Yeah. It's Globe, right?
Yeah, it was only $100 though.
Yeah, I know, but Dave Weiss has got a 3 Bitcoin challenge. If you think it's a proof of a globe, then what? You can 3 angles and 3 times. Angle times.
It's a proof to them. I'm not saying it's a proof. I'm saying it's to them it's a proof, or it's an evidence, whatever they want to call it.
Yeah. Well, what's the do you know the method? Because I understand an angle, and you can do fuck all with an angle, but what's the time? Like, I mean, the angle time method.
Well,
I've never even. That sounds great.
Well, it's not a time method. You need to know the time so that you know the position of the star, right? So literally every minute, the star moves, right? Or whatever's in the sky moves. Again, they say because we spin. Some of us say because everything else moves. Okay, so whatever you believe is whatever. But so you need to know the time that you took the angle. It could change literally minute to minute, definitely hour to hour, of course, depending on your location and the star. Now, if you look at if you're pointing to the North Star, it's not going to move. It's going to be, in theory, whatever your latitude is your angle, right? So if you're 45 degree north, and if you point your theodolite, or not theodolite, your what are we calling them? Sextant to the North Star, you're going to get 45 degrees. So he did one to North Star, one to, was it Procyrus or something like that, and then one to Arcturus. And from there, I'm not saying I know how to do it. I'm just saying, like, that's the information provided, and apparently people submitted and got his relative, again, location. It's not like 100% precise, but it's within. He said someone got it within 6 kilometers, which to me is really, really close.
Right. It's good. So angle times.
All right then. So thanks, Chris Berry, for that whole bunch of information about nothing.
Well, it's not about nothing. You guys say it doesn't work, and you've got the other side saying it does, and they're actually doing it.
We say what doesn't work.
Using sextants to get angles to use for celestial navigation.
No, you can definitely measure an angle.
You can definitely get an angle. So you're misrepresenting what we say. You're misrepresenting what we say.
No, Rob, this is my point why I come here, and Barry just brought it up. Exactly my point. You just said, and yeah, you get an angle from a book. Listen, all of those angles.
No, I never said you get an angle from a book.
Yes, you do, dude. You said you get it from a book.
You measure an angle.
You can
misrepresenting, is there?
You can locate your longitude and latitude with a sextant.
You can measure an angle with the sextant. Yes?
Yes.
And you can also look at the time as well now. We've added that in. So you can note the time that you measure the angle at.
So I can find my longitude with the prime meridian of UTC Greenwich time. Then with the information of the declination of the sun's position and how I measure it over a period, I have to measure it in 3 locations. So let's say I measure it at 82 degrees, and then I measured at 84 degrees, and then back at 82 as it's moving away from me. I take those 3 points, which I can deduce. I'd have to go back and write this down.
Put this out in a video, right? Because
we all know out there of actual navigators doing it already.
Yeah, but we all know, right? We know here, particularly, this is the sort of stuff that needs to be drawn out. It needs to be gone over. It needs to be shown. Now, I suggest you make a video to let everybody know how this method is done, because it doesn't,
I heard Mitchell from Australia
definitely doesn't work like this through a chat.
Well, I do agree with that.
Chris.
I was going to ask.
I wanted to make one comment real quick.
Oh, way up, jeez.
Real quick, man. I just wanted to make one comment, and I've got to lay back for a minute. But I heard that Mitchell from Australia got won the $100 from MC Tunes.
Yeah, I don't think that was right. I think that was a troll, Brian. You might have fallen.
I gave him his coordinates. I gave him his coordinates for the Flat Earth Challenge, and gave him a method and everything. And he said I couldn't put it on any maps with longitude, so he disqualified me.
Everybody was saying.
I just want to prove that you got to come off no money, right?
Everybody was saying that no flat earthers had gone after McToon's challenge, but I said you did, didn't you? You went over there, Brian.
I just wanted to show him that fucking here's your fucking coordinates. I did it 3 different ways.
Did you give him?
I give him fucking. I did it 3 different ways, but I give him the fucking exact coordinates, and then the coordinates that my model. The coordinates my model fucking got, and they were all within a few miles.
Near that McGregor, Wisconsin, or whatever.
McGregor, no, it was what he gave me was some fucking coordinates off of a fucking a Sextant tutorial. It's so funny because I fucking I learned all the Sextant shit, and I kind of crammed it. I had an idea, but I kind of crammed for it, and learned how to do all this shit, dude. And I recommend, just a side note, anybody, if you're not planning on fucking ever using this shit, it's a whole lot of waste of fucking brain space or fucking brain room. If you're not going to use it, it's really hardly worth the time it's going to take to fucking figure all these formulas and all these methods and shit. There's a lot to it, but it was a spot out in the middle of the fucking ocean.
This was the $10,000 challenge or the $100 challenge?
The $10,000 challenge. It's on there. It was the day before he released the. It's on his channel the day before.
I thought for the 10,000 challenge you had to do your own measurements.
Yeah, he did.
I did. I gave him the fucking equation and everything. Worked it out for all 3 angles. Came out to and everything, but I fucking mapped it on. But he said I couldn't map it on something with longitude.
Why?
Or in latitude. I'm like, so I guess what I did was worth nothing. So what do you? I gave him a method of how Google Earth purely works. And so the measurements. That's what maps. And I gave him a reason. I gave him a formula, but he wouldn't. He said that. I said, "What was that supposed to make a fucking map without using longitude or latitude or whatever?" I mean, I just came up with the formula to show why we're seeing them angles and getting them distances. So I basically flattened their ball mathematically, and
right. Well, latitude, longitude's 2D, right? Or it's XY coordinates, so I don't know why he's saying you wouldn't be able to use that. Like he doesn't even the Gleason's map, which I get is not a perhaps complete or correct model. Doesn't that has latitude, longitude lines, and that's a flat map. Yeah, basically you're right. He's enforcing the fact that we don't really have a working model. And he's saying you can't use any of the globe model stuff. You can't use lat-lon or the sphere. You can't use the spherical star stuff, etc. Making it basically impossible.
Yeah, I just wanted to prove, because nobody was really interested. I mean, a few people were interested, but and everybody, he kept running on like he's the money he's going to be giving out, So I just wanted to. I just did the other time, made a statement that look, he was never any fucking money. It wants a flat fucking method of of the angles and all that. Here, I'll go ahead and give it to you just to shut him up and show that he ain't coming off fucking nothing, dude.
Well, if you can convert, again, I don't know his rules. So he changed the rules. I don't know when he submitted, but there's like a second version of the $10,000 challenge where he said you can use the globe model stuff, but you have to show how you converted it to a flat model or a flat.
No, that's just it. That's just it, dude. That's what I thought, but that wasn't it. He said that you couldn't. I thought he said we could use fucking. I thought the whole thing was. I mean, I wasn't gonna do the challenge if I couldn't use fucking a map, you know. But no. When he redid the challenge, I talked to him on Jose's, and I was under the impression that I was able to use Google Earth or what the fuck ever, you know, or whatever charts. But and the whole argument is what the fucking ground is. Excuse my language. What we're living on, and so what I'm telling him is these angles, they're all empirical. They ain't proven nothing one way or another. And I just gave him a method of how it would work. And so basically, I give him the formula of A being the angle. You take an angle, okay? So and then you triangulate the distance of that angle on a flat plane. So and I based it all off of 69 degrees. I mean 69 miles 1 degree, right? That's empirical. So that's the place of little to no refraction is directly underneath the star. So I just used Polaris, and I said, okay, I go 69 miles, and it changes 1 degree. So I do the trig to get the baseline distance. I mean the height, the opposite side height, the star height, and 69 miles at 1 degree on a flat plane gives you a star height of 3958.7. What a coincidence! Their exact radius, you know. So what they did is, since when you go past the degrees, when you start getting up to like 45 degrees, you know, it starts deviating, and I said that's because of refraction, you know, and basically, you know, the for the first 20 degrees, you know, it's pretty much spot on, but when you start getting 20, 30, 40 degrees, you're thousands of miles, and nobody's going to be able to prove it one way or another. To be honest, nobody's going to pull chains and find a
that's why we said right, that's why we said at the beginning you can do fuck all with an angle, right? You're doing a challenge for somebody that he knows it can't be done.
I did it though, man. The whole point is so on a flat plane, that's what I get. So he's trying to say I used the radius, but it's not my fault that the fucking that a flat calculation over 69 miles 1 degree triangulates to fucking 69 miles, right? So I gave him the equation of A minus 90 over 90 times D, which is the triangulated distance, times point A, which is 1% of the angle, which is the ratio. So it's all empirical. There's nothing arbitrary. There's no made up fucking numbers. It's just a ratio of refraction converted to distance, and so you triangulate based on the opposite side being 3959. So that's the average height to the stars, and it works out fucking all the way until you get right to the horizon and shit. And they don't use horizon stars anyway. And
you say height to the stars,
waffle.
Brian, did you say height to the stars? 39.
Yeah, model. It's just a model, man. The height to Polaris is what I based it on. Based it on Polaris changed 1 degree, moving 69 miles.
And you gave it a height in miles, 3959.
Yeah, that's what it go to a triangle calculator and put in 69 miles for your bottom angle, your baseline, and then for your bottom side, and then for your angle A, your theta, whatever, put in 1 degree, or put in 89. You're putting 89 degrees. I'm sorry, you got to put in 89 degrees, but that's moving 1 degree. That's why it's 90 minus A, because if you just said A being angle, it'd be opposite. So that's how they do latitudes and shit. So all their equations are 90 minus A too. So it's 90 minus A being the angle you measure.
Waffle.
Yeah, sorry, I'll back off.
Oh, he's doing that. We're talking about something interesting and you're fucking interrupting with that sound.
It's math, so it must be Bev.
I must be hearing things. Let me ask the question again. You gave it a height.
Yeah, I modeled it, man, to show that it's fucking it's you know it's not impossible to model their shit on a flat plane. So I just give them a model. I entertained it.
I see. If you take an 89-degree angle over a distance of 70 miles, what would the height be?
I can't believe what I'm hearing, guys. Honestly, I can't believe what I'm hearing.
I'm under the North Pole and I move 70 miles.
It sounds like
free for all Friday.
Yeah, I know.
Mayhem has ensued.
Let him talk. Wild interruptions.
Angles.
Yeah.
Because,
I was answering FC Montreal.
I mean, it's okay letting people talk, but I mean, saying ridiculous things about being able to measure angles to lights in the sky and come up with an elevation, height.
Hold on. Let me cut you off there. I'm not claiming that I know how high the stars are.
That's what you are. You're saying there's a height to a height.
No, you didn't let me finish.
Based on his model.
That's what,
it's just a model. I was just sticking up for I was sticking up for flat earthers. Y'all ain't flat earthers. Okay, look. Yeah. I was sticking up for flat
model
earthers.
Affliction is on Monday.
Their math doesn't prove reality. If math proves reality, then I just proved a flat earth on his channel. But it's just a model. I don't think I know how high Polaris is. It's just a model and to show the angles working, to show him it could work on a flat earth too. And I also showed him that how they got their radius in real life. They took and triangulated a 1 degree difference over 69 miles. That's how they got it. Their radius. They didn't use sticks and stones to get a fucking radius. They fucking took a flat baseline and empirical evidence. We can measure it in real life.
It's even easier. You can deduce it all from sun, just from the movement of the sun. You can deduce the size of the Earth just from the movement of the sun and timing the sun. That's it. You don't even have to use angles. You can.
You're kidding, right? You're kidding, right, Data?
No, I'm not. 60 by 60 by 24 is the base for it all.
Bro, you're sounding like a baller right now. Sorry.
I don't take offense to that. I'm not a baller. I'm not a flat earther.
Telling me you can figure out the size of the Earth?
You can deduce by the apparent size and the radius of Earth from the time of the sun. Yep.
Come on, Data,
man. To know how big the sun is.
Now, what you have to do is you have to.
Let me finish what I was saying real quick, Data, real quick, because I ain't gonna be able to be here long. So he was saying that 15
minutes ago.
I know. Well, I'm extending it, but no, he was saying that like he was talking about the radius and all that, and I was like, I wanted him to cite me where the radius for the sextant. It's all. I mean, at the very end, when you could claim the radius when you're trying to plot the distance, but all the math, it's a circle, it's not even spherical really, man. All the calculations to get the GP of the stars is based on the fact that the stars are doing the same motion, circular motion. So it's all a sideways circle. It's triangulation, but it's on a circle laying on the ground, not a sphere. So people think of the triangulation like elevations to shit. I mean, you got to get the elevation angle, and then you put it in you go to the almanac, to the ephemeris, and it doesn't give you but one star. It gives you Aries, because it'd be a fucking 20 volume fucking or a 2,000 volume book if they gave you all of them. So they just give you the SHA to or they give you the GHA, which is the Greenwich fucking to Aries, just that star, and then you just you do the triangulation to map your star in accordance to where Aries is. So each other star has a chart, and they all have their own SHA, their the sidereal angle, pretty much according to where Aries is and according to the time. So you triangulate it. It's a circle laying on the ground. It's it works fine on a flat plane. I don't know what they're talking about as far as this sphere shit.
Sounds like you put a lot of practice into this, Brian. Right?
Yeah.
Have you got a sextant?
No.
I mean, some people here do actually have sextants. You know, I bet they've not put as much work into it as you have.
It's a big pain in the ass, man. But I just wanted to show that, you know,
Chris is gone. Yeah.
It's not a pain in the ass. It's fun. It's absolutely fun. It's better than watching 98 Day Fiance. It's better than watching fucking.
So have you done it then, Data?
So I'm at the process of right now breaking it down.
You want to team up with Brian?
In my book, I
go
wrote
after
about
McToon's stuff together. I mean, what a fucking
wolf.
chance, eh? Here's a chance for you to team up with Brian and go back after McToon's 10K. You could definitely write a book on that.
Yeah, Brian, have you gotten down to the equation of time yet in the celestial navigation? Applying the sidereal versus mean sun time.
Yeah, ABC. There's a couple different ways to do that too, man. But basically, it comes down to this. It comes down to the sun, and you do have to get your longitude. You mentioned earlier. You do need
longitude. Longitude.
There's a way around
it. Longitude is easy though. That's the easy one. That's the easiest one. You can do that.
He didn't give no longitude though. There's a way around it, but he didn't give no longitude on his challenge, you know. But anyway, there's a workaround. But check it out. So it comes down to this.
Check it out, Data.
It comes down to the celestial equator. Or you could do it off Polaris. You could take Aries as one point, Polaris as another point, and your star as the third point. Or you can, that's so you get your azimuth that way, and then you use the celestial equator, Aries, and your star for the declination. Okay, it's all based on circles, not spheres. It's all Euclidean, man. It's all
Euclidean. Yeah, it's all Euclidean. It's how they built everything: straight lines and angles and circles. Yeah. Well, I'm at the point now where I'm looking at how to calculate. I just want to be able to find my GP, my position on Earth with just my
team up with Brian. You get it.
That's the whole fucking trick.
Got it done.
So it's easy with the sun. Just do the sun; it gives it to you. But you got to calculate.
It's easy with the sun. It's easy with the sun, but you still have to rely on an almanac, right? You need a nautical almanac.
Now Brian did it without it. It's easy.
Well, that's where I'm at. So that's why I don't want any help, because I want to go learn the system and then figure out, because earlier navigation.
But Brian's already half done it. You'd be learning from it. You're trying to get all of the. I mean, you
even better. Even better.
He's page in your book. I mean, come on.
Keep going. Keep doing it. Because at the end of the day, just like the earlier navigators, we had to figure this shit on our own. So I don't want to be told it. I don't want to be fed it. I don't want to be told it, nor do I want to be
to do it in team, right?
No offense to Brian. I think Brian
half the work.
I think Brian feels.
In fact, I think Brian would take 90% of it. You could get Brian to do most of it for you.
He'll give me the 90-degree, really. So Brian is on his own thing because it's for his own self education, because he's correct. You literally, if you go down this path, it has to be something that you plan on using. I plan on using it for actual boat navigation. I'm looking at getting into sailing here in the next a year or two when the world starts getting fucking even kookier, because I'll be on the ocean fishing for my own fucking food. That's where I plan to be in a few years. So I want to plan for that.
You need a sextant, and yeah, for sure.
Well, you can use a quadrant. You need some math skills. My thing is like I said, once you learn it, you use it, you lose it, right? And like this argument, it's exciting, it's new, lots of interesting.
The non-argument argument, right?
The non-argument argument that you keep bringing up, Bev, is fantastic. And I'm sure Brian feels exuberated and exhilarated when he comes across new things to learn. This is the mind of the iconoclast, if you will. Somebody who doesn't want to be spoon-fed, or he's a paid agent and he's here to
Brian's not a paid agent. Don't you dare say that.
Hey, check it out. I just basically got tired of hearing them talking about angles to Polaris. Sean Hawkins mainly. I'm like, angles to Polaris, like, how can that work on a flat earth? How can that work on a flat earth? I heard it so many times. I'm like, shut the fuck up. Here's an equation. There's how it would fucking work. Call it fucking a celestial dome. Call it fucking a apparent atmospheric. Call it refraction. Call it whatever the fuck you want. Here's how it would work. You know?
Yeah, they forced him into doing it.
Shut him up, right?
Yeah, they forced him into doing it. He wouldn't have done it if they hadn't kept saying it.
Here's the thing. That's the part
Sean
of the debate.
Hawkins kept wanting me to get on a mountain bike and do a mountain bike challenge. Not got a fucking clue. He said he wouldn't talk to me. Kept calling me a coward for not doing it.
You got Professor Dave admitting that the Earth.
Nice. Shout out again, Professor Dave. Explains. He's not a real professor.
He's not a real professor.
No, it's just a YouTube. Yeah, it's just a name.
Big Professor Dave has in the last debate with Dirth there with
that wasn't a debate. It was meant to be just a discussion. Yeah, because there are no debates, right?
The point is that Dave himself acknowledges that the Earth is extremely, extremely large. And I think Weiss replied back, well, if it's extremely large, why are you counting boats going over the horizon? Silence from Dave. Absolute silence for at least 10 seconds. So that's the admission right there that the Earth is massive. But then you have people like Michelle Thaler, Bill Nye, and the argument. Wow, these people are
name dropping here, aren't you?
Yeah. These are academia, right? Teaching children for proofs of a ball Earth, and then they rely on the immediate.
Are they on the telly?
They rely on the
school. Are they teachers?
Well, Bill Nye had an educational show on television. He presented an Earth curvature
He had a TV show.
It was an educational TV show, yeah, for kids.
Okay.
Yeah. And Michelle Thaler is an educator.
That's where you get your information from, is it?
No. So the argument is that these people have created a narrative regarding observations of a sphere. Those observations of
would you say that, or would you say people talking about people that had kids shows are more to blame?
Educators, in the mainstream society,
people have kids. People do shows on TV saying all sorts of stuff. The only people that keep bringing that up are the people that bring it up, right? If they didn't, if nobody brought them up, then it would be a non-talking point, right? Surely.
If you're talking about how people can be engaged in this debate and conversation, and what arguments you're going to go, and what brain power you need to devise or to dissect, this argument, cosmology, physics, math, is a diverse subject. The flat Earth is a diverse subject. So if you have a narrative of people,
it's not an argument.
If you have a narrative, if you have people with a narrative that are anti-flat earthers, and what they do is they're saying that the Earth is recognizably a sphere locally, which goes against Euclidean, because Euclidean locally says it's not a sphere. It says it's horizontal.
Who says that though, right? Because I've been in this arena for a bit, and I've never heard anybody say that other than like people like you. I mean, so who are the people that are saying that, if not you?
So the narrative of the globe model says that you can notice that there's a sphere by standing on the shoreline, by looking at a boat going over, or looking at a shadow. There is a narrative. So that narrative has
the narrative you're pushing now. Right?
No, the narrative has beliefs behind it. Those beliefs are that
you're talking about right now. Then that narrative.
Those beliefs are backed up by being taught what to perceive. So they're taught to perceive the Earth's a ball. They've been taught to perceive.
Hey, real quick, real quick. Hey, Chris, if Chris Berry's listening, man, I'm done. I just wanted to get that out, man. But man, I wanted to hear what he had to say, man. I like Chris, man. Chris, if you're listening, man, come back, man. I'll barge in for you, man. Come back and join us, man, if you're listening.
Did we hear somebody yesterday say locally it was Euclidean? I could have swore he said it just like that too.
Yeah. Yeah. Yeah, there's an argument that isn't even an argument that people keep talking about other people making, that they're not making themselves, but other people are. But that gives them chance to talk about an argument that isn't an argument that somebody else brings up, which is really weird to me, considering flat Earth data isn't even a flat earther.
It's a low-euclidean. What do y'all say? It's local, or it's euclocal.
Euclocal, there you go.
Dude, I'm listening half the time and I hear y'all come up with some shit and have me laughing out of my chair, man. Talking about the perpendicle or some shit, or some of the words y'all come up with, man. I've listened to some episodes that have me dying, man. When y'all get on a roll.
Have you heard of dialectism?
No. You broke up. Say that again.
Sorry, I gotta take a call. Somebody else will take it.
I think he said dialectism. I think. I'm not for sure.
You say dialectism?
Dialectism.
Dialectism. I'm trying to think of the last one y'all come up with. I think it was on the episode where he was talking about you playing out there at the college, where making an event out of that. But I'll come up with one, man. I can't remember what it was, man, but it was funny as shit. Y'all put two words together. I think it was you, Buster.
Oh, yeah. I've done it a few times, but I mean, they do it too. Blue said that there's Googleistic lines of variable potential or something like that. Man, shit gets made up all the time.
Oh yeah, wait, no, the Cavendishmometer or some shit, or the what was it?
Seismometer.
Yeah, the seismometer dish. That's funny shit.
You guys remember the first order measurement versus the third order measurement?
Yeah.
Well, that is a thing, right?
Yeah, that is.
It is a thing, and the globe likes to use third order in measuring their sphere.
Yeah, then you got so much room. You got room to do anything.
Did we cover the dialectism?
No, go ahead. I wanted to hear it. That's funny. Oh.
That's a good one. That's the ballers. They've been using that a lot.
What's the definition?
Well, the exact definition is two truths. Do you think that you can have two truths?
Absolutely not, but they damn sure do. It's weird, in my opinion.
Yep. Oh, since I have you here, Brian, did I ever ask you what proof is to you?
Man, proof to me is, man, it's pretty general, but, I guess, proof is something, I guess it'd be personal, man. But proof, as far as personal proof, would have to be like evidence, overwhelming evidence. But mathematical proofs is really the only true definition of proof, of proving pretty much the freaking equations. Just like things we can demonstrate. Like the postulates, man. I like that. I like that idea.
How about in reality?
Proof to me just means, just on a nutshell, I'd just say, overwhelming evidence would be proof.
Well, some equate evidence and proof. So, what kind? If I was to say, okay, evidence, but what kind of evidence?
Yeah, to call it proof, I think you'd need I think proof would be like a step up from evidence. I guess if I'm talking like that, I guess proof would be the next level up from evidence. So proof would be certainty, And like I said, so if I'm going to be technical, the only certainties we could really have are personal and mathematical if I'm going to be technical. But if I'm just generally speaking, I think you could prove something to me personally if you gave me overwhelming evidence.
Yeah, I hear that a lot. Evidence, but what would you accept as an evidence? Or more generally, do you have any proofs yourself? Do you hold any proofs yourself, Brian?
No, I think I just proved that math doesn't necessarily prove reality. And, when I come up with that model, because like I wanted to say earlier, man, I wasn't trying to butt in, but I was just trying to defend myself because I don't think that I know the height. Just so everybody knows, I do not think, not even for a second, that I know the height to Polaris, or that I know the height to the sun and all this. It's just a model,
Yeah, I get it. Maybe I misunderstood you. You made a model. I get it. Yeah, no worries.
Yeah, that's cool.
But back to the personal, like if you hold any personal proofs yourself, or if that's a tough one, what is evidence?
Proof? No, I'm just kidding. Evidence, man.
It's a hard thing, Brian.
Yeah, it is. It really is, man. Hey, and I ain't trying to change the subject, but I heard you the other night on Awakenings. It was after this show, and you were challenging them to find, like, is anybody even used the sextant? Who could do it? And that's a good question, man. Because I've heard so much contradictory shit going over the tutorials and shit. And I'm like, there's nothing really that sounding. The people doing it, it's like the one guy that I think legitimately used the sextant out of everything I've seen was an old man, and he's like pretty much saying that if you get within 25 miles, that's about what he's like, we can calculate it within, about 25 miles. And I'm listening to Globers, and they're saying, they can calculate shit down to like the 100 feet or something, down to the foot or I'm like, man, this guy with experience who actually used the thing before is saying within 25 miles. But the thing is over these long distances, they can get you going in general directions. And then you have to redo it when you get up close. So that's when he was talking about with third order, like when you're first order, like when you get, if you use a sextant over a long distance, you're gonna have to redo it when you get up close. And that's why that sextant doesn't prove shit. Them distances are, they're wherever they put that star over their map, as long as it's close. It's only got to be close. It ain't got to be perfect, It's only got to be close. So anyway, that had me thinking when you're challenging people, and that they're all talking about the sextant. You're like, who could get home? Who could navigate home if I gave you the coordinates and shit, And that's when I joined and commented that I figured that Chris might be able to do it if as far as coming up with the coordinates, but as far as you putting him in the middle of the woods or the middle of the ocean and actually getting home, that's a whole nother topic. That was an interesting conversation y'all had, man. And I think you silence most of them when you challenge them with that shit. But not Chris, but Kosho.
Yeah, absolutely. Yeah, that's another. We say you can't do fuck all with an angle. Excuse my language, but yeah, that's another topic. But for somebody that didn't want to deflect, you kind of deflected. I'm kidding.
I'm excited, man. I don't talk to y'all very often, man. I'm getting all excited. You're right. I just kept going on and on because I get so much I wanted to say.
No, I want to hear what you got to say. Then I want to ask data because I don't believe I asked data.
Proof to me. So, are you looking for any type of context to this answer? Because to me, proof is it's personal for each individual, man. So I'm gonna have to say it's a really good question, man. It's got me thinking, bro. To be honest, so I need to think about this for another minute. Data wants to jump in.
If I wanted to prove my identity to you, I would have several means of proof of identity. Those would be evidences. Those proofs would be evidence of my identity, right? So I would have either my blood as a proof, my fingerprint as a proof, my eye my eye is proof. Those would be proofs that would be evidence of my identity. Would you agree with that?
Well, it's not about me, but let me try to break down what you're saying. You're saying
if I wanted to prove my identity,
tangible, something like
I wanted to prove my identity. If I say I am who I say I am, I would have to provide proofs. Well, what proofs do I have that would be acceptable as forms of evidence? The forms of evidence that would prove my identity, which would be my fingerprint, my blood work, or my biometrics when it comes to my eye. Would you agree that those would be proofs or evidences of my identity?
Well, yeah, I would agree, but it's not about me. It's about what would you accept. It's not about me.
So what am I accepting as proof? I can test a fingerprint. I can test an eye. I can test blood. Are we having something testable for a proof, thereby giving us evidence? What am I analyzing here? What is the scenario?
You're asking a question, bro. I'm asking you the question. It's not about, and there's no right answer.
In what context? What are we discussing? What proof are we looking for? What context is it?
There's no context. It's what is proof to you? What would constitute a proof to you?
So in an example of my identity, I would prove my identity by showing the evidence that I have. The evidence I have would be my fingerprint, my blood work, and my eye, my biometrics, or maybe even my face in this case, if it was part of the proofs or part of the evidences needed to identify me. I would use my face, facial recognition.
So somebody, to identify a person, you're saying?
You would need proofs. Those proofs would be evidence of the identity, right? And the evidence would be, like I said, fingerprint, eye, blood work. That would be the evidence that you present for proof.
Okay. All right. Fair enough. But let's say now I was to tell you, let's say you were going to make a challenge, like Dearth, for example, right?
Sure.
And his challenge is prove to me that the Earth is a sphere, right? What would you accept as a proof in that instance?
Well, when you're saying prove the Earth's a sphere, it's sort of ambiguous because proving it's a sphere would require proving the types of dimensions or types of measurements, right? So ideally, you're trying to prove it has a shape at a certain rate. That shape would have physical effects or measurable effects or measurable. What's the word I'm looking for? You would look for something measurable, right? That would indicate what you're trying to prove, which in this case would be you're trying to prove that there is some sort of drop or dip based on a set parameter or dimensions.
Prove what?
You're trying to prove that there is, if there's a claim, the claim is the ball has a certain set of parameters or dimensions. You would try to find proofs of those dimensions. That's the first thing you would do, which would be something testable, observable, and repeatable. Right?
Okay, is that what you try and prove then?
Well, I'm looking at the tools. Next would be looking at the tools that would allow me to test that claim. Well, because I'm a tiny little turd on the ground, I'm not left with many tools to test this claim because the tools that I have are limited. So as a person without access to GPS, without actual information, actual data, I'm limited on what proofs I can present as evidence. What I will be presenting is evidence that other people have provided me. That's the only evidence that I can present.
You would provide proofs as evidence?
Well, your evidences are your proofs, right?
I'm not too sure. I mean, a proof is a proof, right?
Yeah, through evidence.
And then
you have evidence.
Evidence.
Well, and evidence helps with your proof. Right?
Well, hopefully you end up with the proof, right?
Through
However
evidence.
you get there.
You need to present evidence to create a proof.
Okay, is
So
that what you need?
For you?
So evidence for me in what context? If I was trying to prove the ball Earth, well, I'd have to acknowledge that I'm a tiny little person, and I'd have to acknowledge that I'm limited on tools. So what tools am I allowed
to access? I say, would you try and prove the ball Earth? Is that what you go for?
If I'm presented a challenge, and that challenge is already rigged from the beginning, knowing that I am limited on what tools I can use to test that challenge, then the person who is setting up that challenge already knows that it's not possible to test it.
Dude, you're getting off. It's not a challenge. We're just asking you, what is proof to you?
Evidences.
Okay.
That's what I'd use forms of evidence.
But we're going around in circles now. What is an evidence?
Okay, in the context of the shape of the Earth, you're asking me, I would have to look at what's being asked. And in this case, you're asking me to measure the dip drop of the curvature of the Earth to prove that it's a ball.
Drop.
Sure, the dip, the drop, whatever you want to call it. So I know from already being in this argument that I'm limited to the tools that I have access personally, because all the instruments that I have are Euclidean, which means they're localized to the environment we're in. Now, can I use those?
How local?
Based on optics, limitation to your optics.
There's even with like a water level that requires no sight line. Even things like that, they're not optical, right?
That's another tool that is limited.
How's that limited?
Locally.
Well, how long's a local water level local? Euclidean local.
It's limited locally.
Yeah, you can't use it. How big is a local?
Can you use it in a continuous 5 mile stretch? No, you can use it in a localized.
Is 5 miles not locally then for you? Is that not local?
You're using it in increments. In other words, the tool is infinitesimally small to the size of the Earth, and when you're taking infinitesimally small measurements, if you're taking infinitesimally small measurements of a sphere Earth, you won't detect any curvature. Right? That's just a fact. So if you're making small infinitesimal measurements along a large mass of Earth,
why is it small infinitesimal measurements?
Well, if you're on a curved Earth and it was abruptly
if you're on a curved Earth, isn't that what you're trying to prove? Are you trying to prove that now?
I'm not into proving anything. I'm just about the correct conversation and about being truthful about both sides. The philosophy about both sides.
Trying to be truthful about both sides. Both sides of what?
Philosophy on the shape of the Earth.
Right. There's both. There's only two, is there then, right?
There's only two philosophies that I can tell, either Pythagorean or Anaximenes. That's it.
Wow.
Those are only two models. Either you live on a stationary Earth with everything revolving around it, or you are not on a stationary Earth. You're revolving around the sun. It's the only two models that I've seen in the argument. Actually, the flat earthers were Greeks back in the day anyway. They thought that the sun went around the sphere Earth. So flat, but spherical at the same time. So it's like a conundrum, right?
Do you reckon there's a room for people that don't care about the Earth at all?
100%, yeah, and they just want truth. Yeah, they don't care about the outside reality. 100%, yeah.
Okay. So do you think the people that don't care about the Earth or the shape of it or anything like that, they just want to deal with what is in reality? Do you think they should have to deal with a dichotomy, a false dichotomy? Obviously, because there are other people, right? There's not just two models.
If they're in a debate, then they will be subjected to fallacies for sure.
In a debate for what?
Well, it's philosophy. We have ad hoc examples. We have no means to test a lot of the philosophy that we have. Personally, you and me.
Philosophies.
Sure, whether or not the Earth is spinning or whether or not it's stationary.
That's not a philosophy, right?
It's all philosophy, absolutely. What you observe with your eyes and the phenomenon, and how you deduce that phenomenon, it's a philosophy that will come out of it.
I doubt it.
Of course it is.
What's your observed phenomenon?
For what? What are we talking about?
What is your observed phenomenon?
Could be anything. Let's pick a category. Let's pick something. What are we observing?
Yeah. Pick something.
Well, you're bringing it up, so we'll pick it.
You say that, okay, here's my phenomenon. I see the lights in the sky move across the sky.
Right.
That's my phenomenon. Okay. So
right. And what is your hypothesis? Okay. What is it? Now you observe something. Now you have to have.
No. Hang on.
Yeah.
I observe that some people like to say that's not actually what's happening. What's happening is the earth that I'm standing on is somehow moving, and it just looks like the sky is moving. See, now that is preposterous.
Yeah, sure, that's your hypothesis. So you observe something, and you've got two ways to think about it. Either I'm stationary and that's moving, or that is stationary and I'm moving. So that's a philosophy now. It can't be stationary. I have to be moving. Now, how do you go and prove that? You can't. You can only have a philosophy.
Two different choices isn't a philosophy.
Two different choices to think about this would be those two types of philosophies. Not that you're unlimited.
Dichotomy.
You're not. Well, sure. It's one or the other, right? So if you're saying it's a false dichotomy because it's one or the other, well, it's philosophy. That's what it is. It's either Anaximenes or Pythagoras. That's what you got. You've got two coordinate systems here. Now, if you can show me a third coordinate.
Wait a minute.
But
there's no got two.
No, there's no third coordinate system in this debate. I mean, you want to talk about what do they call it? Concave Earth? Is that the third alternate coordinate system?
Or I don't know if you just added another one. I mean, like I was saying, like you're the one that's telling us. Like you can't dictate to us what the options that people can have as choices of these things.
My wife's a concave earther, man.
Okay. That's her philosophy on life, right? She can have that philosophy. Now, what evidence does she have? I'm sure she has lots of evidences.
Philosophy.
They're all philosophy, man. Even what you're doing, talking about the world we live in and practicality, it's a philosophy. You have a philosophy on life.
No, we're just asking questions, right?
Sure, that's your philosophy. You like asking questions. Yeah. You like asking about the nature around the world. You're inquisitive. Your philosophy, you're an inquisitive philosopher.
Your philosophy, we're just asking about reality. Gee.
Sure, and you have to be philosophical about it because you cannot leave Earth to test any of your claims or any Earth theories. Zero. That's why Einstein had to create his theory of relativity, is because to leave a reference frame.
With this, dude, you can't let it go, can you?
Leave
model.
You leave a reference frame. You need to create a new reference frame. Well, if there is no way to test.
No. Wait a minute. You can't create reference frames, right? That's not what you do.
Of course you can. What are you talking about?
Oh, okay.
You can have straight lines or curved lines. They're two different reference frames. You can have something travel at variable speeds or something.
Two different lines, right? A straight line is not a curved line.
Two different reference frames.
It's not a reference frame. Like a straight line is a straight line and a curved line is a curved line. There's no reference frame. Switch.
But a reference frame that operates in curved lines that considered to be straight, that's a different reference frame than something that operates in straight lines and it is actually straight. So,
I mean, yeah. Wow.
Yeah, well, there's reference frames there. That's why you got general relativity and special relativity.
Do you often think like that?
Two different sets of geometry. Those sets of geometry have
two different sets of geometry. Where?
Between general relativity and special relativity. There's two different geometries involved. That's just what it is. The whole point of Einstein creating these abstract models, if you will, of space or where we live, is because there was no way to test the Earth moving through things. This is their argument. This is what they say.
Shadow giants again. Or is that just people in Discord servers? Or people that you hear on the TV or radio? Like, where are these people that are saying this?
Einstein talked about two coordinate system being equal. Yeah, it talked about the coordinate system, whether it would be the Ptolemaic coordinate system or the Copernicus. They're both equal. This comes out of Einstein's mouth. It's just the position of the sun versus the Earth, right? We already know this, right?
What, the light in the sky? A big E.
Sure. It's a philosophy of what the lights are doing. That's what it comes down to. Because there's never going to be a reference
big ball philosophy.
There's never going to be a reference frame in our lifetime where there's a camera pulled away.
Do you know anybody with these philosophies, or are they just shadow giants that we talk about, that you choose to talk about?
With philosophy, they believe the Earth's a ball. 99% of the Western world believes the Earth's a ball based on philosophy. Yeah.
Okay.
No, it's not based on philosophy. It's based on consensus.
I would say it's based on paralogism.
Philosophy that started 3,000 years ago. Yeah.
I would say 80% of the people that you think are the 90% haven't even got a clue that they even think it's a ball. They don't think they live on anything. They don't think.
Generally, you're correct. Yes, they don't give it a thought. You're right. And generally, when they are proposed, and this is part of my discovery, and this is what I urge anybody to do for testing the claims, if you will, is ask people in passing, whenever you feel comfortable, how far away is the horizon, and you'll get 30 miles, 20 miles, 40 miles, 50 miles. So you'll realize that a lot of people, the argument that we're involved in here is contrived to a certain degree.
Genesis wants you to tell him more about the two different geometries, special relativity and general relativity.
Well, it's needed in this.
You might be helping Blue out with a bit of a video or something.
I'm not trying to help out anybody, Bev, except for just being direct and honest and not afraid to disclose the argument for what it is, which we are tiny little fucks on a massive something, and we don't have a clue what that massive something is. Whether it's a ball, whether it's an extended plane, we have no fucking clue. What we do, though, is have practical reality that you don't need a ball. You don't need a ball to live in. You don't need a ball to operate in. That is objective reality. You don't need it. You don't need a ball to navigate either.
You need to keep mentioning it, though.
Because I find that this channel still is kind of chicken about certain subject content.
We just don't bother talking about Big E. It's not like a big thing around here, but obviously the people that come over here have a want to talk about it. We just provide a platform for people to talk about it. And people are coming and people are going, but I mean, the viewers aren't really that good for you, Data. It's getting boring, right?
Sure. Yeah. The whole point is Einstein himself is not a genius when you have to source out your own model and get mathematician help for spherical geometry for Riemannian. Einstein couldn't do his general relativity on his own. A lot of people don't know that. So when I bring up this stuff and I bring up Einstein, why don't you go research how he had to hire somebody to help him
with about the Earth.
Did you just blow by what Bev just said to you?
Mentioning Big E.
He's well obsessed with
this. Flew right by what Bev just said to you, and continued on still talking about Einstein as if we asked you what you said.
Did you hear what I said at all? Did you even absorb anything I said? Do you now know new information about Einstein?
At first, I didn't even know who you were until I looked on the panel, and then I realized, oh my God, it's this guy.
Sure.
Okay, well, he did just say that the people are getting tired, Data, and it's boring now.
Yeah.
So continue talking about the stuff we just said it was boring. We're listening.
Right,
Okay.
I've got on screen, and I have had it for quite a while, Data, and obviously you're on about Einstein and all of that sort of stuff, and there's Nathan Oakley has put a thing out, right? It says, congratulations on your debate with Dave Weiss, a conclusive victory, some say. I don't know for who. Want a real flat Earth debate? This is Nathan Oakley's asking for this. Data? Well, we don't give a shit about it. And I don't think there's anything to do with the flat Earth debate. I don't think it's possible. But, Nathan Oakley, let's set it up. Debate Flat Earth Daily on a show dedicated to the subject, and its participants are the subject matter experts in this regard. This is where you should be, Data. Shout out Nathan Oakley, the subject matter experts in flat Earth debate. That's where you should be, Data. That's where you should be compiling all your data, right? It says, typically the show, Flat Earth Debate, has an open door policy, but it would be great to have you specifically on the show to see how you get on debating an actual expert on the reification of your globe model and the Earth being a flat plane. Nathan Oakley.
Well, you get on there, Bev. It sounds like you're more excited than I am.
Please let me know this would be of interest to you, or if you would prefer just debate with the low-hanging fruit of flat Earth. He's just had a debate with Dave. I hope he's not. I will understand. He's not saying that Dave Weiss is low-hanging fruit, is he? Low-hanging fruit of flat Earth.
Sounds like what it implied.
Uh-oh. I look forward to hearing from you soon. You can call me Dr. Nathan if you like, or we can drop a pretend accreditations we've had assigned to ourselves. I'm good either way. That's a funny one, right? Because he's not a real professor like Nathan Oakley is. It's yours sincerely, Nathan Oakley, self-assigned Doctor of Flat Earth. But he's the expert of the Flat Earth. And then you've got Professor Dave, who's obviously the expert of the Globe Earth. And that's what you're talking about, right? Data?
No.
You're not talking about this flat Earth, globe Earth thing.
Well, I'm coming into some debate channels like yours.
This isn't a debate channel.
Sure. Discussion channel, if you will, on the nature of the Earth.
No.
Or the nature of geometry.
Yeah, just logic, geometry, and reality. Don't worry about. There's no need for you guys to talk about Big E. But
so the point
Friday night free for all.
You have a working parameter your show works within, and there are no do's and don'ts when it comes to conversing on your channel, apparently. And so when I bring up,
it's free for all Friday.
When I bring content you don't normally discuss on your channel, then I'm met with insults, name calling, and so forth. Sure. Mm-hmm. And the point of me saying things. The point of me saying things on your channel is to make sure that people understand that when you're going to get into geometry, you might be under the impression that a lot of people discussing Euclidean or non-Euclidean want to ignore the fact that non-Euclidean is useful and is purposeful and does work. And I find that your one-sided approach is not being fair to the overall debate or accuracy when it comes to truth or telling the truth.
What we do, Data, right? Because we start at the very basics, and we're starting with obviously with a straight line and basic logic, and we're even going to go back to do the trivium, right? We're on that basic level that we can't do non-Euclidean because not everybody understands Euclidean. And in order for us to know what not something is, we have to start at the basics and understand what the something is first before we can know what the non-that is, right? So we are starting at the basics of Euclidean geometry. We will, definitely not move on to not Euclidean geometry until we are certain that everybody understands what Euclidean geometry is first. Now, that makes sense, doesn't it? I mean, it's not logical to start at the not something first, because you could be there for quite a while, right?
You won't, Bev, because people already aren't interested in the Euclidean learning. What they're interested in is the contention or the argument, and why there's a separation between Euclidean and non-Euclidean.
What argument?
That is the birth of the ball. Is how do we?
That's solid geometry, Euclidean, sure. Book 11, a sphere.
Sure. The point is that they not going to come in for the lesson on geometry when you're going to deny the other geometry, when they rely on the other geometry.
What other geometry? The not Euclidean geometry, and Euclidean geometry seems to be the geometry that the sphere is in.
That appears to be the case, Bev, yeah.
Okay, so the not spherical geometry, or the not Euclidean geometry that is on the sphere that is Euclidean geometry, seems a bit of a not argument to me. Doesn't seem like much of an argument, because even you can't state what the actual argument is that you think we should be having.
Your argument is that at the really is a level, Euclidean is what is used, which nobody is debating that.
It's not an argument.
Exactly. What the argument is Euclidean good enough to measure outside of the terrestrial world we're living in? And the answer is no, according to...
You can't get there, can you? Somewhere you can't get to, is it okay to use something that you measure somewhere that you can't get to? I mean...
So the point is
sounds
that
like a genius argument. That if it how often do you debate those sort of topics?
I come in very rarely.
Argument?
I maybe went into Gems like a couple of days ago, but I haven't shown up in a while. I show up maybe every couple of months, every month or so, for a couple of days, and I fuck off and do my thing. But
so, what's the best argument against that argument that you've ever heard?
Well, they don't understand the best position that I've found.
The argument, I bet,
is the history of why there is Euclidean and non-Euclidean. Why the birth of non-Euclidean happened. Why? What was the purpose of it? There was a struggle with Euclidean geometry. They don't understand the struggle with Euclidean geometry. They just already think it's Euclidean, but it's not. It's a hijacking of Euclidean. They're curving lines intersecting. That's not Euclidean, right? But they think that that's Euclidean.
What, curving lines intersecting? I can draw two circles, right?
Sure.
They would be Euclidean.
But on a 3D image, you'll have 90 degree with intersecting line.
On a 3D image?
On a 3D surface, yeah. On a 3D ball.
On a Euclidean sphere. Solid.
Sure.
Yeah.
Sure, yeah. You're still going to have intersecting lines, right? So the point is that they don't know the argument. They think that...
What's the argument?
They needed something more than Euclidean geometry. Why they needed that is because the Euclidean geometry was limited to celestial calculations, if you will.
This is again, that sounds like a question. Again, it doesn't sound like an argument. Can you please state the argument that people don't know? Then we will know what the argument is.
The argument is Euclidean good enough to map out celestial bodies? And some say, yes, it is good enough to map out celestial bodies. And some say, no, it's not good enough to map out celestial bodies.
Okay, so that sounds like a question with two replies.
So it's an argument. In other words, someone saying...
No, just asking a question with two different replies. That's not an argument.
Well, the argument is somebody believes Euclidean is good, and somebody saying Euclidean isn't good or good enough, right?
Okay, so what's the argument for it then?
Euclidean geometry has a limitation, or it doesn't have a limitation.
That's according not much to of an argument. Like, which is the argument for Euclidean geometry? Because you like to have both sides of the argument, right? So the case is Euclidean geometry good enough for celestial geometry?
Sure, sure, celestial measuring, if you will.
Can we make a map? Right? Is Euclidean geometry good enough for making a map of the lights in the sky?
So apparently it's good enough, because that's how we created our almanacs, is through straight lines and angles.
Okay, so that's the argument for Euclidean geometry then, yeah? That's what you would say. Right, now what's the argument against Euclidean geometry?
That it isn't good enough for celestial, that it's only capable of doing terrestrial measurements. Okay, it's not capable of
what's the definition of an angle in not Euclidean geometry? Non-Euclidean geometry.
That a triangle, or that a 180 degree anything greater than 180 degree or greater can have intersecting parallel lines. And in Euclidean, it's a triangle, or you can only have intersecting lines if the triangle is less than 180.
That's the definition of an angle in non-Euclidean geometry.
Sure.
Like a reversal of the
intersecting line
triangle axiom within
the intersecting lines with a greater than 180 degree is a spherical triangle.
Right. Well, but an angle in Euclidean geometry is just the inclination of one straight line to another.
Sure.
Right. Which so what's the definition of an angle in non-Euclidean geometry?
What's the definition of an angle of non-Euclidean?
In non-Euclidean geometry, yeah. Do you have a definition? Because if there's an argument going on, you would hope that the people on both sides of the argument would have the fundamentals of the argument. So on the not Euclidean geometry side, where they're mapping these lights in the sky, on their side of the argument, what do they say when you say, well, do you have a definition for an angle within your not Euclidean geometry? Because Euclidean geometry side has a definition of an angle, and that's definitely a Euclidean geometry angle. Does the not Euclidean geometry have a definition of an angle?
The spherical, which I read earlier to Rob, the spherical triangle has 3 different indications that are different from Euclidean. I'll read them off for you again. I read it from Big Think here. Just give me a second.
Oh, Googled it. Nice.
Well, I read it earlier.
So the definitions are different in not Euclidean geometry to the Euclidean, right?
There's 3 main differences with spherical trigonometry than Euclidean.
No. You just said spherical trigonometry. That's not geometry. That's just trigonometry. Everybody knows about spherical trigonometry. Spherical geometry you're talking about.
Sure, which requires spherical trigonometry, right?
No.
Well,
no, spherical trigonometry is the trigonometry done on the surface of a Euclidean sphere. That's not spherical geometry. No, sorry. We're looking for the definitions of an angle within a non-Euclidean geometry.
Spherical trigonometry is
spherical geometry, dude. Stop swapping it.
Spherical trigonometry is.
Wow, we've just swapped it again. Spherical geometry.
Yes, spherical trigonometry is a part.
It's almost like he's not listening to you. Almost like that.
Wow.
Spherical trigonometry is part of geometry.
No, spherical trigonometry is trigonometry performed on the surface of a Euclidean shaped sphere.
Two-dimensional surface, sure, yeah.
No. A solid geometry, Euclidean sphere. 3D, solid geometry. Length, breadth, thickness.
So now, spherical geometry is on a 2D surface, right?
Brilliant. So there's the difference, right? Not a 3-dimensional Euclidean sphere, a 2-dimensional. Everybody knows what 2-dimensional is, don't we? Length times breadth. It's a plane.
Mm-hmm.
Yes.
It's a plane with arching lines, right? They have an arc line.
Really?
Spherical.
Yeah. An arcing plane, like a ball plane.
Well, the plane isn't horizontal on this grand scale. Maybe infinitesimally in small sections it will be straight, but the overall arcing pathway of the spherical triangle shows you that it's a curved pathway.
Plane. It's a curved 2D surface.
It's a spherical surface which is curved, correct?
2D curve. Because I mean, I can't even comprehend that. 2D to me is a plane.
Yeah, I understand, but on a physical ball, you will
3D.
have
Euclidean 3D ball.
Yep. You'll have 2-dimensional lines drawn on that 3D ball.
Nah.
That's why you got great circles, right? That's what they are. It's plane circles intersecting at area point. Points of the center of the ball, or wherever you decide to. Well, in that case, yeah, great circles are usually going through the center. But anyway, the argument stands is that
because Euclidean geometry states, right, that in 3D geometry, book 11, that a straight line is at right angles or perpendicular to a plane when it makes right angles to every straight line within the plane. Right? Now, if you say 2D is a plane that curves, then it doesn't have any straight lines in it. So what your spherical geometry on a 2D, which I would say was a plane, means that Euclidean 3 space and solid geometry, where the sphere is actually based, isn't real. It doesn't work. You've falsified the very geometry that gives you the sphere in the first place. That you then want to say that sphere is a 2-dimensional. You want to bring it back. It's one of the biggest stolen concept fallacies ever. And I'm guessing this is just the first bringing of light to this particular fallacy that people have been living with within the Euclidean, non-Euclidean thing. It's all based on a stolen concept. And it's a mindfuck for a lot of people.
It's based on optics and the convergence of light. That's where they're getting the
optics at all.
Well,
it's based on you saying putting non in front of Euclidean geometry, which is a well-founded and proven fact of reality. That you just put a non in front of it and you can pretend that there's an argument there, but there is no argument. The only argument is you fooling people by putting non in front of it and pretending it's real because you've put non in front of it.
No, it's a difference between straight lines and curved lines.
No, because a curved line is like a circle, right? You can make a curved line, but you need to make that by a straight line, a radius.
In a spherical triangle, you're going to have 3 sections of arced circles meeting a point, right? That's the difference when you say non-Euclidean.
They actually meet at 2 points, don't they? You might remember.
It's 3 points. It's a spherical triangle. It's the 3 points.
Yeah, but they intersect twice, don't they?
They intersect 3 points.
Your circles.
The spherical triangle.
Yeah, a circle on your sphere. Your what you call great circles. They intersect twice antipodally.
Total, sure, yeah, that's fine, yeah. But that's not what I'm not looking at the great circle here. I'm looking at a spherical triangle.
Yeah, you're talking about spherical triangles, but because you've got 3 circles that meet antipodally twice, then you don't have 3 points, do you?
Just 2.
You've got 6.
6. How do you get 6 out of those 4? Where do you get 6 from? 1, 2, 3, 4. You got 2 points. How many great circles do you have on there?
I don't know why. You keep saying great circles. They are just circles, right?
It's just a circle. Great circle is an explanation of presupposing a ball that the circle is cutting through the center of. Yeah.
Well, no, a circle goes around the sphere, right?
Cutting through the middle.
The great part is the trick that people think they're straight lines. That's what makes them great.
Yeah, but they're being presented that information first without understanding the backstory of how they got there. It's like they just showed up there. Well,
shadow giants again, or what? Who's they?
Well, it's mainstream, right? Mainstream science, right?
What mainstream science? What think that circles are straight lines?
Or mainstream science great circle don't go down to the center. The great circle don't go down. It has nothing to do with the center of the Earth. In their model, it's a circle that cuts the ball perfectly in half, and they call it a straight line. Yeah. But I think I have some proof.
Geometry is not science.
It's the 5th science according to Masons. Geometry is considered the 5th science in Masonry.
Here's what I think, man. They come up with this spherical geometry. What they should,
5th science.
I think it's all. It's just an easy way of doing it, man. What they should have did for the shit to be legit is they should have had longitude going one way with a north and south pole, and then instead of having parallel lines that aren't parallel, they should have had lines converging in like at the meridian going east to west, and then they could have a legitimate model and use spherical geometry and shit. But they had to put in the latitude lines and have converging, non-converging fucking lines to fucking confuse people, man, in my opinion, man. But I think I have proof against that.
If you have a polar point position, then, and you're going to map a point of position as a 0, then you're going to use a circle, and you will have all those lines converge to the point of that 0 polar point. And all those lines stretching out from that polar point will be your longitude lines, and then the competing circles apart from neutral or center will be your
circles. Is there a competition?
Well, in size, right? As they go out from each other, they get larger and larger from the north polar point. There's a map you should try to find, Brian. I don't know if I can't recall the name of it, but it's a map that it's got basically both 2 circles with 2 polar point positions mathematically put. You've got the polar point, you got the south polar point. Those 2 circles are side by side with so if you took what's his name, the guy that died, Antonio, that's his name,
Antonio Schubert.
Yeah, so if you took 2 circles and had a polar point and you separated the Earth, you could map out the Earth with 2 polar points using 2 circles and have it devised the same as a sphere. What's that?
Yeah, I know what you're talking about.
So I've seen that done before, and I think that's a way, because I'm looking at the ontological starts, right? The starts of how they did it all, and it all comes down to ratios. And those ratios are devised by using straight lines. Without the straight lines, we'd never be able to devise these ratios. So I'm trying to, learn in this navigation thing without being told, like Rob says, in the almanac, you get the source of declination. I wouldn't be able to determine my location properly without that information. So how do I go above and beyond to figure that out, right? If I'm not going to rely on what they're telling me I need to do to find that information. That's where I'm at with it. That's why I want to know the ground zero, the polar point position, and then go from there, and without relying on anybody's extra input. And I find that your show, Bev, doesn't want to add in or clarify why they're coming to your show, other than they just think you're a flat earther.
That's the only show where I learn something at least something, every time I watch the show. I can't say that for every show. I mean, I've learned things off different shows.
Thanks, Brian.
I learn at least one thing, or if not more, every time I come here.
Thanks, Bri. That's what the idea is. So what is it, Data, you're saying that we don't cover? That you think we should cover? I mean, it's not like a normal free-for-all, but, I mean, we do Model Affliction Mondays and then Logic Tuesdays, Hump Wednesdays, Euclid Thursdays, and then free-for-all Fridays. So tell us what it is that you think we're missing, other than the game in which we're going to be doing soon as well. So go on. What is it that you think we're missing, Data?
The origins of the ball and how it's afflicted people into thinking.
Sphere comes from solid geometry, book 11.
I know. That's
you where guys the sphere is in geometry. We deal with that mainly.
Your show is fine. I'm just saying that every time I come in here and I present stuff, I'm met with contention. I'm met with insults and put downs when I address the information I'm addressing, which I've done before. You seem to think that I'm getting the information from other people. No, what I'm saying is through the years of me listening to.
I know we now know that you make shit up for yourself. You come in with arguments that you think that people should be having because you like hearing people having arguments about stuff. But you just think an argument is the opposite side of something. You don't really know what the actual arguments that you think people should be having are. You just want people to get confused between things.
Logicals, the beliefs of why you believe, if they understood that the world around them presented itself, and this is documented in the math, in the writings, that the earth presents itself one way, what did they need to show proof or evidences that the world is not that one way? It can't be just right on philosophy, right? Where it appears that a lot of people just rely on philosophy or consensus, like the other buddy said.
Well, what we're after, Data, right? We've been doing this is a big thing at the minute. We're after proof, right? To the basic proof, right? But proof positive. You know the difference? There's no such thing as a negative proof, is there?
It doesn't make sense, no.
That couldn't possibly happen.
Well, if it's negative, you don't, right? Wouldn't that be like an oxymoron, a negative proof?
Exactly. Yes. So thank you very much. Right. So proof is always positive. Now, when we're asking for a proof, that's why we're asking people for proof, because there's a lot of people who've said there are no proofs. They've got rid of them. Even self-evident truths. They've got rid of them. Like, say, for instance, two straight lines cannot enclose a space. That's a self-evident truth. But people have to say, whoa, can't say that. I mean, you can't prove it's not. So there might be some way in the future or something. Somebody might find a way to make two straight lines enclose a space. So we can't say that. So we'll have to get rid of it. Which I think's ridiculous, but some people say that, right? Some people would say that's an argument. To just say, well, you can't prove it. So therefore, you can't have it as a self-evident truth, right? Some people say self-evident truths sound a bit funny. So this sounds a bit weird. Sounds different than the other ones. Let's say we don't need it. Right? And they've done that with everything. To the fact that now people are saying there are no proofs. Which I think is a little bit ridiculous.
That's because they've been put in a corner to be ambiguous and non-committal, and that just reemphasizes the weakness of their philosophy is when their philosophy has no proofs, then why do you have a philosophy about it? Mm-hmm. And so that would be a great question to ask. So if there is no proofs, why do you have a philosophy about it? Why do you believe it to be true if there's no proofs? It's the same as asking me to prove my identity. Well, if I have no proofs of my identity, no evidences of my identity, well, why would you believe that I say who I say I am? Right?
It doesn't matter who you say you are, right? That's the
well,
point.
If I can prove it, I'll present evidence.
But that's one of those things that there is no need for you to prove, right? That's a proof that doesn't need to be done. Nobody's asking you to prove your, unless you're a bot, right? And people are questioning whether you're just a bot that repeats shit. That, other than that, there's no need for you to prove who you are, right? You just talking and answering proves enough that you're a person. So therefore, you can have that. So that's not needed to be proved.
It doesn't prove my identity of who I am. I can be a person just like you can be, but are you Bev and I'm who I am? And if that's the case, how do I prove that? Well,
it doesn't matter. That's one of the things. It's irrelevant. It doesn't need to be proved that you need to know who you are, right?
In the realm of proof, you need to present evidence to have proof, right? And your proof would be your line of evidence. So in the case of Euclidean geometry, your evidence gives you your proof.
No.
Right?
In the case, this is where it's slightly different. In the case of Euclidean geometry, every one of the propositions is the proof, and they build upon each other. That Euclidean geometry is the very paradigm of what proof is. That's how to structure proofs in order to have a very certain outcome with the truth value that exists all the way through it, right? So that's a good example of a proof. So you could give a proof within reality if you could structure it in a way that you could use Euclidean geometry to structure a proof in reality, then you could definitely have Euclidean proof to back whatever it is you're talking about in reality, right? Now, you will have people that say, well, Euclidean geometry doesn't exist in reality. It's just geometry, I mean, it's just a part of mathematics, and mathematics is only abstract. So you can't even have proofs in geometry anymore. These people that have given up proofs, they've given up the proofs within geometry and mathematics by saying that mathematics is only abstract.
Yeah, but that's applicable on theoretics, but applied, that's not true. Applied is reliant on ratios, exact measurements. So what in half truths they're correct, in abstracts and in theoretic.
Half truths.
Sure, if it's theoretical, it's a philosophy, right? It's a
what's theoretical?
Well, if I have if I look at an optics of an eyeball and I want to measure if I wanted to measure the subtended angle of a light hitting an eyeball to see whether or not the degradation of the optics and whether or not that person can resolve that subtended angle, I would have to have a base equation and use math. And in this case, I would start with a theoretical approach to optics with already.
Is this for proof?
Well, I'm just getting an example. So
within the optics of an eye.
Yeah, I'm just saying. So you would use theoretics first. If you're going to cut a piece of lens, right, for this person's eyeball, you'd have to have a set of parameters. Those parameters are based on theoretical numbers. They only become applied numbers they only become applied numbers is when you actually when you apply that information, you eventually go from theoretics to applied mathematics. So in other words, you eventually cutting that piece of glass to fit that subtended angle of light to make that person be able to see that resolvable detail.
Do you make contact lenses?
It starts out theoretical and then ends up applied. So in a sense, when they say there's no proofs or actual evidences, well, that would be false on applied sciences. That would be true.
Right. So there are actual proofs in reality. There's a long way to get around it, right? You're saying the people that say there are no proofs are wrong, in your opinion.
Yes. Once again, it's based on context. What proofs are they referring to? What I can prove my identity through presenting evidence of who I am. But if you're going to present evidence that's theoretical, well, then what proof is that? What evidence is that? That's theoretical evidence. So if I give you math numbers that are based on something that I can't verify, with the human eye, I can verify that subtended angle of light and the resolvable detail with it through my micrometers and so forth that I'm using. The point is that they are using the theoretical side, which is there's no proofs in theoretics. That's why it's theoretical, right? So they're just using another semantical argument.
Yeah, but there is a proof in mathematics and geometry that states that a triangle only has 180 degrees. Now, that's a proof, right?
That is a known proof, yep.
Right, okay. So then what about the people, do you say, about the people that say there are no proofs when it's pretty obvious there are proofs? Right? There is a proof that triangles have 180 degrees. Now, because the people who say there are no proofs, they say triangles have more than 180 degrees. Now, you can understand why certain people say there are no proofs, because if they want triangles to have more than 180 degrees, yet there is a proof that triangles only have 180 degrees, that's got to be a contradiction, right?
See, the thing is, Bev, again, it's being clear and concise. You're talking about triangles and spherical triangles. There's two different categories. The category with triangles is true that the 180 cannot be greater than 180. The spherical triangle axiom is also true for the fact that you can have a greater than 180, but we're looking at two different categories and what truth or proofs or evidences are in each category.
Yeah, it's a misrepresentation of what you think a triangle is, right? It's a really bad definition because the angles are measured internally in planes. That's why you got confused about spherical trigonometry. Right, because the angles are measured, Euclidean angles, on the planes, between the planes of the circles that you make, right?
You're having arcs join with vertices.
No. The entire great circle turns into a plane, and the angle is the angle measured between the planes, internally or externally, doesn't really matter, because you make a plane out of the entire circle, right? And the angles are measured internally, like that circle I showed you, a ball with a bit cut out of it. That's where the planes the angles are measured internally.
Locally, at that point of position, it would appear to be a 90, but the arc is the
90.
Difference.
What would appear to be a 90?
The joining of the vertices.
Vertices of what?
The two straight lines that are joining.
Straight lines?
Or the two arced lines that are joining, because in the context,
are these like straight lines that you just said? Are they arcs or are they straight?
No. In trigonometry, in regular Euclidean trigonometry, they are straight lines. In spherical trigonometry, they are arced lines.
No. In spherical trigonometry, you make a plane out of the great circle, right? You planize that, and then the other great circle has its own plane, and the angle is measured between the planes. A Euclidean angle.
Drawing a great circle, okay? I am literally drawing a spherical triangle because the surface that I'm drawing on it's arced, it's curved. So while I'm drawing 3 vertices, I am drawing a spherical triangle on a curved surface. This is not unheard of. It's not bizarre. It's not weird. And there is proofs for it. Now, the problem with the proofs...
Where's the proofs? Where's the problems with the proof? Where is your proof for spherical geometry?
Well,
please show it.
The only way that the only reason that applies is because they have latitude lines. They have concentric circles for latitude lines. That's the only reason that the fucking 390s make it's because their coordinate system, man. It's not because of the circle.
So I'll give you proof. Delta R multiplied by A plus B plus C minus pi is equal to R squared E. This is a mathematical proof for spherical triangles. Now, the issue with the 2 pi radians over 360 or whatever the 5 pi, I think there's here, what does it say? The sum of the angles outside of spherical triangles, 3 pi and 5 pi radians. So they have mathematical proofs for spherical geometry if you start with a spherical surface that has a
Can you see that one there? You see that one? Everybody can see that?
If you have a spherical surface with a radius, you can have a mathematical proof. You have issues, though. You have spherical excess, which is an error in dealing with spherical, or it's a spherical defect.
You have an error in a proof. It's not a proof then, sorry. Failed.
I get it, Bev. I understand your point of position. The point is that it exists, it's real, it's applied, it's used.
It's not a real proof if it's got errors.
It's the real proof, Bev. Go look at any math. Go look at any tutorial. They have a mathematical proof for spherical triangles. It's all good. Now, does that mean that we apply it to our reality of the Earth we live on? Some people think that we do at local levels, and at local levels we don't.
So how
we do it in
how many angles does a spherical triangle have?
We do it in a third order calculation. We first start with Euclidean, and then we end up adding in second or third order.
What's the proof for a spherical triangle, please?
Radian squared multiplied by A plus B plus C minus pi is equal to radius squared E. That is the mathematical proof. E would be the spherical excess.
Right.
So
what would R be?
The radius.
Oh, of a 2-dimensional sphere. Surface, sorry.
A 3-dimensional radius, a 3-dimensional surface with.
You can't have it. No, that's Euclidean if it's got 3D.
A spherical triangle is a figure-formed surface of a sphere.
But if it's got R, that's a 3D, and therefore not 2D. Right, a 2D surface doesn't have R, does it? It can't have it.
You're correct. You're still going to have that
would
radius.
Be a 2D. Actually, would be a circle, wouldn't it?
The way they calculate it is they use
2D.
They use the R as a straight line. Meanwhile, your R is a straight line. Your radius is a straight line. However,
there's no straight lines in spherical geometry.
Or it's a combination when you're looking at calculating the sphericity of a triangle. You start with your radius of a straight line, then you have angle A, B, and C, vertices that have arcs. Those three.
It is a 2D surface though, so it's cheating to use R in it.
Well, this is the issue now, where you end up with spherical excess, and you end up with.
It's an issue because you have to use R on a 2D. Surface of a sphere when a 2D circle's a 2D shape, but you want to have a 2D sphere, but then you want to have R, which makes it into a 3D one, but you still want to keep the 2D part of it, right? Because you don't want to put it back in Euclidean.
This is what they're showing as a proof, right? Mathematical. This particular is Math World. This is Wolfram Math World spherical triangle. They show you as a proof. They give you the calculation, the formula for it. The sum of the angles of spherical triangle is between pi and 3 pi radians, 180 degrees and 540. Yeah, 3 pi radians. Yeah, believe it or not, 180 and 540 degrees.
Yeah, that's the first
540 degrees. Sorry, 540.
There's mathematical proofs, spherical trigonometry. Just go look it up. They'll have
540 degrees. Give us the.
They'll have the same. They'll have the same Euclidean phraseology. They're just or the formula. They're just applying it to sphericity or spherical.
How many angles for these?
Still
need
3.
Yeah, so 540 total.
Yeah.
How many for each angle?
Well, you'd go 540 divided by 3.
Really?
Wouldn't you?
What's that?
It's the same 180 divided by 3, right? So you ended up with.
If your proof
Brian, what is it, data, please?
One thing real quick. If your proof has evidence in it, can it really be a proof data?
If your proof has evidence in it.
Data, please. What are the angles of this triangle?
Your evidence is how you build your proof, right? So the evidence would be in the formula that you use. The proof would be the result of that formula.
Right.
That equation has infinity.
Let's have a look at this proof of this triangle of 540 degrees, please. What's it like? Data.
What's what like?
This triangle. 540 degrees. What's it look like?
Well, it looks like a spherical triangle. It's not going to have straight lines. It's going to have arced lines. That's the only way to get
the angles. How many? 3.
Well, there are 3 angles, yeah.
Right. So what? Each one is it an equilateral? Did you say?
I didn't say it was equilateral. No.
No. Well, what are the angles for this triangle, please?
Well, if it's encompassing 540 for the entirety, is just base it on the entirety, then wouldn't I just divide the 3 vertices to get each of the angles? That's no different than a unilateral triangle with 60 by 60 by 60.
Yeah, go on. So what is that? Have you done it yet? Have you calculated what each of the angles of this triangle that you're going to make is?
Well, it'd be 180. It'd be 180 per vertice.
Okay, right. So we start off with a straight line.
Yeah.
And then at the end of that straight line, we have an angle. Yeah.
Yeah, 180 is a straight line.
Okay, and then so we go along again. We put the other side of the triangle, and then we do another angle.
Yeah, it's all straight lines. I get it.
Okay.
It's not simple when you do it that way.
Doesn't sound like a. I mean, why did you say that? It's not logical to say that, is it? But you've read it out of Google.
No, it's just the.
Where did you read it from then?
It's not Google. It's MathWorld. Wolfram.com.
Wow. So Wolfram made you say that there was a triangle with 3 180 degrees.
No,
are you sure that's right? No, I think you must have made that shit up. They wouldn't have made you say that, would they?
That's what you would reduce if you had a maximum of 540 degrees and you had 3 points. Well, you would just divide the 540 by 3 points and you get a 180 degree point. Well, that's what it works out to be.
A stupid person would, right?
I don't know. I'm not stupid, Bev, so I don't know.
Well, yeah, but like a triangle with 3 180 degrees is fucking ridiculous, right?
The only way to get it is
I bet you can't believe you actually said that.
The only way to get it visually is to show arc lines. That's it.
Right, so what would it actually look like on the surface of a sphere if you were to draw 3 180 degrees? What would it look like? This shape that you've made?
It would look like a spherical triangle.
It would look like a circle, wouldn't it?
No, if I had 180 on a
If you had three 180 degrees. If you had to make a triangle with three 180 degree angles, which is actually a straight line. So you'd have a straight line and then a 180 degree, which is a straight line. So you'd have a straight line connected to a straight line with a 180 degree angle. And then you'd have another straight line, and then you'd have a 180 degree angle, which is a straight line. And then you would have the third side, which is another straight line. So that's straight line, straight line, straight line. It's one big, long, straight line. Now, what do you call one big, long, straight line on a fucking sphere?
It wouldn't be a straight line on a sphere. It would arc.
But it would be one great big fucking circle that returned back on itself. So you, genius, have made a triangle with 540 degrees, but when you actually draw it out, it's just a fucking circle. And circles only normally have 360 degrees, but you've managed to get 540.
There's other infinities in that proof. There's problems, man. When you have infinities like that, you got problems.
Data's got problems because he's just reading shit and he's not even thinking about it.
Yeah, that's what I meant. Yeah, you got to take some of these equations and map them out in your head and look at them, Data. And just if they have an infinity in the math right now, right there, you know something's wrong. How can it be proof if there's infinity?
Proof if there's infinity. What are you referring to now?
Any kind of fucking infinity, bro. Any kind. Like fucking looping around on yourself. Okay? Supposedly three angles and infinitely going around in a fucking circle if you kept doing a triangle.
540 degree triangle that looks like a circle.
And pi is an infinity. Pi is I mean, pi never fucking ends, right? It's an infinite fucking it's as close as they could get, right? But there's infinite decimals, man. There's and other things.
Could you add another 180 degree and have like a square that's a circle?
And a sheet of paper
the same, or would it still be a triangle with another 180 degrees in it?
On a piece of paper, I would have a open box. On a sphere Earth, I would have an enclosed triangle
with 540 degrees. That was a straight line with 180s, three straight lines. So it's a circle, right? Can you not see that?
No. I'm looking at it now. I don't see a circle. No, I see a triangle, a spherical triangle
with 540 degrees.
Well, if you have one straight line, it's 180, the base of a protractor, and then you moved up to create another vertices, then it create up another vertices. You're still creating a triangle. The only difference is that each point of the vertices are arced. That's it. So that's what I would see. That's what I would look at.
Now, would you be measuring the angle?
What do you mean? Where would I be measuring the angle? Where would you be
measuring the angle? Yeah, if it's on your spherical triangle, when you go on a straight line, right? Because the triangle has a straight line, right? Although it's an arc, right? So you go in a straight line, and then you have 180 degrees. Where do you measure that 180 degrees?
Well, you would need a reference point. I mean, you're talking about reality,
a straight line, right?
Your reality versus geometry on a sheet of paper, right? If you're talking
about a straight line, right? Mm-hmm. Whether it be on a ball or whatever, but then you've got an angle of 180 degrees. Now, where do you measure that angle?
You wouldn't get, in reality, you wouldn't get a 180 degree angle. You're not going to be able to measure a 180 degree angle.
In reality, we agree. In reality,
why did you say that then?
So that's not the point. The point is
that you said that there was a triangle with 540 degrees that has three 180 degree angles.
Looking at a spherical object, this is what the proof would be for a spherical triangle.
No, that's what you said. Flat Earth data said there was a triangle, a spherical triangle with 540 degrees, and each of those, if you divide that by 3, you end up with 3 angles of 180 degrees. You said that.
I'll read again. The sum of an angle spherical triangle is between pi and 3 pi radians, 180 and 540. So it's not just a 540 limitation. It's anywhere from 180 to 540.
Yeah.
The amount which exceeds 180 degrees is called spherical excess.
Mm-hmm. So there's 360 degrees of spherical excess in that triangle of 540 degrees.
It's 3 pi radians. Think about that. 3 pi radians. Like, you take the radians of the fucking circle in reality. Why would you take the radians of 3 times the circle?
No, the circle is 2 pi, Bray. It's just an extra 180.
No, but he just said 3 pi. He just said 3 pi radians, though.
Yeah. A circle has 2 pi radians. Semicircle has pi radians.
The ball Earth has 4 pi radians, right? That's how they calculate the sphere is 4 pi.
Sorry?
So, for instance, if I'm going to calculate anything with sphericity, I would use a 4 pi radians calculation. So, for instance, calculating, let's say, little g, and I would want to calculate little g, I would use 4 pi radians to calculate in the process of calculating the little g.
Right, you get an extra.
Yeah, it is 2 pi radians, dude. It's fucking. I don't know what the fuck I was thinking.
Yeah.
The radians is the is just the fucking is basically just the ratio of the circle, man. When I think of that, I think of circles. I mean, I can't help but think about a unit circle when I think of fucking radians in my head. What are you talking about? You're talking about the area of the.
He's just trying to sound fancy, Bry, talking about.
Yeah, I know. That's what it seems like.
Yeah. Yeah, but he's talking about spherical geometry, which there is no radians, is there? Because you don't have a radius. Because it's 2D in spherical geometry. It's like full of contradictions everywhere. That's why I don't think when Data says that there is an argument, I don't think he understands what the argument is.
The argument is that you shouldn't pretend
you definitely
or
shouldn't
avoid
say that a triangle
spherical
has 3 180 degrees. That's a big mistake, Data. But well done. You're on a very exclusive list. PhD Tony, shout out PhD Tony. He's come back to Discord. Hope he comes for a chat. And Brenda.
Yeah, awesome.
But Brenda took hers back straight away. Realised it was ridiculous and shouldn't have said that.
There's nothing ridiculous I'm saying, is I'm just reading it off of.
You're sticking it. Yeah, I know. You've read it. So therefore.
Yeah.
Yep. Are you still sticking with the 3 180 degrees in the triangle?
So if I have a 540 degrees per vertices, then I would need 3 points of positions to enclose that 540 degrees.
Mm-hmm.
That's where the 3 pi radians comes in, right? With the 540 degrees.
Yeah, can you not think of any other way, or just go with it's up to you. Go with the 3 180s. I mean, that's great.
It seems contradicting, man, on its face.
Yeah, it sounds ridiculous because you just end up with a circle, and everybody knows a circle has 360 degrees. So it would be great if you could end up with a great circle, and it was great because it's actually a triangle with 540 degrees. Wouldn't that be a reason to call it a great circle? If it was
almighty circle.
Yeah.
Almighty circle.
If it was disguised as a triangle with 3 180 degrees, that would make it great. an actual circle with another 180 degrees in it.
We'd be triangle jerks.
That'd be impressive. Actually, if you knew anything about how ridiculous spherical geometry is and 540 degree triangles, you'd be amazed and go, no way is that a triangle. Don't be stupid.
So, Bev, here's the problem. The problem is that you need a solution for the problem. The problem is
the problem is that you need a solution for the problem. That seems a bit circular.
The problem is that there's a solution that's needed. The problem in this context is, how do we create an angle on a curved surface? Well, what angle, what proof do we create, or evidence do we need
Can't have
to
an
show
angle to a curve?
Well, that's not true. You can.
No,
we do it in modern days. Yes, we do. So
I think you find you need a tangent usually in order to do that. And a tangent is definitely a straight line.
Yes,
and here's another problem with spherical geometry. It's on a 2D surface, so there's no such thing as a tangent, because obviously a tangent is a straight line, and a 2D surface is also a plane. So a straight line, you can't have a tangent. It doesn't work.
And there goes your triangulation.
Yeah. You fuck data.
So the thing is that there obviously is problems here that they needed to create a solution for.
Yeah, obvious problems.
And the problem is that they don't want to be limited to Euclidean straight lines.
Who don't?
People like Bernard Riemann. That's why he created.
They want to call a sphere a 2D surface and keep you always oriented upright. They always keep converting back to a plane. There's no getting around it. They are always converting back to a plane.
They start off of a plane and then they go from there. It's not. They don't.
Yeah, but the gravity.
You keep saying they, data. Who's they?
The universal they, Bev, that you want to categorize.
The ones you're talking for. Like, can we class? That's how you can tell can we really class you, data? Can we put you in the they, because you're the ones talking about it, right?
Data's got an interesting way of learning shit, man. He likes discussing things, and he likes debating, and he likes math and shit, man. But deep down, when he says they, it's like, man, you could tell his vocabulary. He deep down don't really buy this shit. I don't think.
Deep down and buy what shit, Brian?
He's one of the they.
The reality of fucking of non-Euclidean geometry, man. Of freaking everything about it, man. It's reversed.
It's used in machinery. It's used in practicality.
Non-Euclidean geometry is.
How is it used in machinery?
Well, anytime you're dealing with
mechanics, that's Newton. That's Euclidean geometry.
It's all Euclidean, dude. You're talking about being oriented the same way. I mean, different ways, but the same way. You know, everything up is. I mean, it's only on a globe Earth that you need that shit to stay in a 2D orientation to have 2D and still try and use tangents for equations. And I don't know, 2D, 3D. It's a mind fuck kind of.
They have to live with contradictions. It's always the way that I think everybody has to live with contradictions. It's how many people live with contradictions and which contradictions they live with. It always ends up showing through the contradictions, through paralogisms. It's a good show of a person where they're at. Are you ready to take back your triangle with 3 180 degrees yet, data? Are you sticking with that still?
The 180 degrees in this particular case, when it's applied to non-Euclidean, non-straight lines, then you can have an angle greater than 180 when the lines are arced. That is what's demonstrated, and apparently there is mathematical proofs for it.
3 180s, though.
I don't know about 301. And if you want to stick to that, I'm not going to agree with that. What I'm saying to you is that...
I mean, 540. You're definitely going with 540, though, right?
Sure. If you had 3 points...
Yeah.
If you had 3 points, and in between those 3 points, the lines are arced, there is apparently mathematical proof that you can show that spherical triangles can be calculated accurately, and that would be a proof.
Did you say?
Well, sure.
Is that because you've never actually seen it?
The difference between drawing it on a piece of paper with arced curved, and then in reality proving that curved.
Do you think you could draw it on a piece of paper?
Yeah. No. What is part of it going to get darker, like as you overlap, or what?
Do you think you could draw it on a ball?
Well, that's what you would do to highlight your example, as you would draw it on a ball.
How would you draw that 540-degree triangle on a ball? Where would it look like? Where would the angles be? Have you not got a drawing package or anything that we could see it? Have you not got a ball there you could draw on?
Well, if you were to look at a protractor and have the 3 open protractors join vertices, you would get a 540-degree from that standpoint, but it would only be possible if you have curved lines.
Okay, just like round the outside then?
What do you mean round the outside?
If you were to make those 3 protractors that are obviously 180-degree protractors, right? You're not thinking of 360-degree protractors.
Oh, no, I'm not going on the outside of the protractor. I'm using the baseline of the protractor.
Yeah. That's what I'm saying. So you put those around the outside of a sphere. 3 of them.
Well, you would first of all be limited because of the surface you're working with on whether you have control over this straight arc.
Yeah, so you just draw a big circle all the way around it, like a semisphere, right? A hemisphere.
Why would I do that when I need vertices? I need angles.
You need 180 degrees. Where I was asking you, where would you measure the angles? You said you'd just put a protractor on the ball, right? So where would you measure the angle from?
Well, on the surface of the ball, Earth.
Right, so you draw a line on the ball, then you would put the protractor on it, and then you would draw another line. Right?
If you're looking at a model version, and that's what you're limited to, you are now drawing an arced straight line.
Round the surface of the ball, yes, like I said. The circumference of the ball. You would draw a line on the ball, then you put the protractor on it, and you draw another line 180 degrees from that. And then you put the protractor on it, and you draw another line, right? That's how you do triangles.
You wouldn't get an enclosed triangle if you just did it that way.
You would draw a circle around the circumference of the ball. That's what I've been saying to you all along.
You won't get a triangle right that way.
You've just said, though, your 540-degree triangle had 3 180 degrees. You said that. I asked you, do you know what that would look like on a ball? You apparently still don't seem to realize it, but it is just the circumference of the circle, the ball, right?
It would be enclosed, though. It wouldn't be a complete enclosed circle, no.
It would end. It would. As the circle.
180. Well, yeah, it would be enclosed at that point, but it would be
It would just be a circle. Except it would be a circle that you have turned a 540-degree triangle into a circle. Now, the ballers call that a great circle. Now, I give it to you. Is it a great circle because you've managed to make it have 540 degrees? You have just turned a 540-degree triangle into a great circle. Is it great because it's got an extra 180 degrees in it? Or
no.
Have you fucked up and made a mistake about your 540-degree triangle? Maybe it might be a little bit different and you've not actually researched into it, and it's beyond your comprehension of what a triangle would actually be.
No, I thought about it differently when you're laying out the protractor at 180 degrees, because when you're looking at 3 points at 180, you'd still have to converge those, make the vertices, which means you would be implying the angle regardless of whether you drew it out or not at 180 degrees, right? You'd still have to measure against something to get those 3 points. So in my head, I was thinking the 180 degree protractor is 3 points, but then I'm still enclosing the vertices, so I wasn't thinking about it properly. No.
So do you want to think again?
I'm going to come back and I'm going to show you mathematical proofs of spherical triangle. That's what I'll do for your show.
Right. Well, what about thinking about your 540-degree triangle can you think of a different combination of angles that might work?
You need arced lines to get that. It's the only way that I can see that happening is getting greater than 180 is to have your line arc.
No, you can only measure an angle between straight lines. So I'm sorry. You're right with your protractor, but you do definitely need straight lines in order to measure an angle. You can't get away from that. Like, there's no geometric way for you to get around needing a straight line in order to measure an angle. And unfortunately, on a ball, there are no straight lines on the surface. That's why you have to have a 2D surface of a sphere, right? So you can think it curves. It may be a bit advanced, but I mean, a lot of people, it's just easier for you to say, Bev doesn't understand geometry. That would be the easiest way. You just walk away from it.
It's not the easiest way. That's not. I've never ever said that to begin with. But for instance, the proof in spherical geometry would be spherical law of cosines. This would be a mathematical proof that you could use.
Spherical law of cosines.
Correct. Yeah. It's called the cosine rule of sides. So you can use this. It's a mathematical proof. Okay. So just so you know, there are mathematical proofs for spherical trigonometry, and one of the proofs are spherical laws of cosine.
I'm just here sort of using the triangle within the circle.
So they're using
the cosine is just a function of the sides within trigonometry, right?
Sure, it's all going to have the foundation. It's what
that's
and why.
That's a triangle within the semicircle, isn't it?
No, because you're using arced lines. This is the main difference. They're arced lines. So there is a separation between straight lines and lines that are straight with arcs. There is two separate approaches in understanding them mathematically.
What you're telling me now, there's two different approaches for straight lines or arc lines?
So you can have a straight line, and then you can have a line that is straight with an arc. In other words, it appears straight, but it has an arc to it. Then you can have a line that has no arc, but is straight as well. So they're both straight, and as far as a direction goes, but as far as the ratio for the arc versus the ratio for a straight path are going to be different.
Okay, so which bits is the straight line and which bit is the arc?
There's a first proof for spherical law of cosines. Do you want me to read this out, or do you want to still hold to the position there is no proofs?
There's no proofs of spherical geometry. Are you saying you saying right? The cosine?
There's proof for Euclidean, right? You have proofs, right?
Yeah.
Well, there's proofs for spherical law of cosines. There's proofs for it, mathematical proofs.
Right, but the cosine, you're saying?
I'm just going through the proofs here.
Is this a proof for spherical geometry, or is this just a thing within Euclidean spheres?
Well, that's a good question, because if you look at the proofs, it's going to give you Euclidean as the base structure.
So it's a Euclidean proof, right, within inside a Euclidean sphere. I mean, brilliant. That's not spherical geometry. Again,
it's a proof for spherical law of cosines, which is spherical trigonometry.
Yeah,
it's called
which isn't spherical geometry. Yeah, once again, you've got mixed up.
Spherical
It's unfortunate. I know.
Right, spherical spherical triangles are devised by the great circles, right? Connecting 3 points in the great circle. Right, that's what spherical triangle would be. Is defined by the great circle of connecting 3 points.
No, it's just the regular law of sine and cosine, but put within a sphere context, isn't it? It's just the usual Euclidean laws of like triangles within a semicircle or a quadrant, right? Depending on how you want to do it. It's all known Euclidean facts.
It all starts from correct. That's correct. Then they need to build upon it. That's the point. Why did they need to build
upon what? The circle?
People who weren't
dude, right, here we go. If a circle has 360 degrees and a triangle has 180, you can fit two triangles, one in the top half of a circle and one in the bottom half of a circle, right? Pi radians, 180 degrees in each triangle, because it's the triangles that we're actually talking about, and the function of the triangle scribing that angle within a semicircle being a right angle at the point of tangency means we can get a tangent point and a sine and a cosine rule, a law within that triangle. Now, each of those triangles having 180 degrees means there's a proof that triangles only have 180, because you can't have triangles having more and fit one in the top half of a circle and the other one in the bottom half of a circle. It's not allowed. It's what we call impossible. That's why there is a proof that triangles only have 180 degrees. And since everybody knows that triangles have straight lines, and that's how the function of straight lines and circles and the relationship between all of those things happen, then there is no spherical geometry.
Technically, I would agree with you, because
you'll argue about it anyway, right?
Underlying X, Y, Z coordinates are fundamental in all, in how to build upon.
Reality.
Yeah, to build upon it, right? You need the X, Y, Z.
Yeah.
Which.
In reality, X, Y, Z, and the fact that all right angles are equal, and in order to fit in any of those planes, the X, Y, and the Z, they all have right angles, and they're all perpendicular to each other, right? Again, right angles. Then there's no room for any other excessive angles. You can't squeeze them in anywhere. Can you? It's not possible.
Well, there's a thing called Diangles. Do you know what those are?
Go on. Go on.
Do you know what diangles are?
I know what an angle is, right?
You know what a diangle is?
No, go on, tell us.
Okay, so a diangle is a real thing. It's when you get a vertice, the both angles are equal at the vertices. It's usually bound by two great circles,
then, right?
Called a diangle. Okay,
like a where you split an angle.
No, it's called a diangle. So any two distinct great circles. Any two distinct great circles intersecting to 2 points, which are negatives of each other. The angle between two great circles and an intersection point is the angle between the respective planes.
Are you just reading that?
Yeah, the diangles, any two distinct great circles intersect 2 points. No, I've been going through this for a bit, bringing piece by piece with you guys.
Nice. With you guys?
Yeah, I'm going to go to another channel eventually.
No, hold on now.
Well, you're just reading it. A diangle.
Mm-hmm.
Impressive.
It's not impressive. It's just piece by piece with you guys, right? So when I'm trying to bring up proofs or an argument or understand either position, it's good to know the argument,
anytime you want to. Data anytime you want to. Bring us a proof.
You can't even prove the proofs, though, man. Not you, but anybody. The proofs for spherical geometry are not provable. In fact, they're proven to me.
So here's a proof, man. For you. Go look.
No parallel lines. So if you have a line and a point not on that line, if you have a line. Wait, if you have a line and a point on. All right, go ahead.
I'm going to give you a proof. Go study, since you're into navigation, you'll like this. Go study how they wanted to find the position of Earth by using the moon's position, right? Go figure out how they did that. Why is that a proof? It's because literally they couldn't use Euclidean to do it. They needed time. They needed a chronometer or chronometer. They needed that, they needed a location for Greenwich before they could start doing this. This is all start 1750 to 1820, whatever.
Can I just give you something?
For proof, for evidence that spherical trigonometry works is valid, is them using that application for the moon.
Okay, can I just interject, right? You say in this spherical geometry, they've had to get a ray, there was some sort of an argument that you thought that they ended up saying that there was no parallel lines, right? Yeah.
Parallel lines.
It goes like this, Kev. If you have a line, here's the proof for spherical geometry. If you have a line and a point not on that line, okay, any line drawn across that point, any line drawn across that point will intersect with the first line.
Yeah,
which
I
basically
know. Right. So they say there are no parallel lines, right, in spherical geometry. Not allowed. Right. Also, a consequence of that is that triangles have to have more than 180 degrees, right? But so could we say that in reality all horizontals are parallel? Provably so. Therefore, it can't be spherical geometry. Right? Isn't that a proof that spherical geometry that has no parallel lines, all you have to do is find parallel lines like a square and say that's obviously a disproof of spherical geometry, right?
There's a proof of a diangle on a spherical surface. It says the area of the diangle is proportional to its angle. Since the area of the sphere, which is a diangle of 2 pi, is 4 pi, the area of the diangle is 2 theta. So they're giving you mathematical proofs right here. You're giving a demonstration on a spherical surface, showing you that, again, a diangle of 2 pi is 4 pi, the area of the diangle that is 2 theta. So what does that exactly mean? For me, I'd have to show you this image.
You haven't got a clue what it means, have you? You're just reading it.
Because if you have a proportional angle,
2 pi is 360 degrees, right?
Sure.
So
if you have a proportional,
4 pi is 720 degrees. Where's that? What is it you think you're talking about?
So this is a proof when it comes to a diangle, right?
Proof
and
of
so
what?
Spherical trigonometry.
What, saying 720 degrees something in a sentence is a proof of something? Like a proof of what?
So I can give you the math so you're looking for proofs, right? So evidence is that spherical geometry works and is valid in reality. This is where I'm at. So
you can't just say it works 720 degrees.
The argument left, right, and center from this flat Earth channel.
It's not a proof. Which flat Earth channel?
Yeah, try and find a proof we can prove.
Which flat Earth channel data?
It's that there is mathematical proofs for it. Now,
which flat Earth channel have you brought this information from?
Whether that relies on reality we live in, that's not what I'm talking about. But there are
which is the flat Earth channel you just mentioned, then.
Geometry. And so when I hear
which is the flat Earth channel you were talking about, please?
Well, there's your channel. There's many other channels.
This isn't a flat Earth channel data.
Okay, if you say so.
Yeah, I definitely say so. This is logic and geometry in reality. Do you think that's flat Earth?
When you look at physical Earth curvature and the negation of physical Earth curvature for present reality, you will be labeled as a flat Earth channel because you're denying.
Who is doing that?
Anytime you bring up Euclidean geometry, you're going to be perceived as a flat Earth channel. That's it.
Euclidean geometry is flat Earth, is it?
Dude, get out of here. Start your own channel.
Well, nice.
That's what it is.
That's what it is. Is that a globe Earth argument now? No discussion of Euclidean geometry, otherwise you're a flat earther.
It's not a globe Earth position. It's going to be perceived that.
Why?
He's a glober.
Why is it going to be perceived as flat Earth? So surely Euclidean geometry is just geometry, right?
You're talking about straight lines and straight angles. Have you ever heard of this? Is a neat one.
Got to change subjects.
Have you heard of Girard's theorem?
Do you know what a straight line is? Right? Is that flat Earth? A straight line can't be flat Earth, surely.
The shortest distance between 2 points.
Yeah. Do you think that's flat Earth? Because that's definitely Euclidean geometry.
It has nothing to do with flat Earth whatsoever.
Okay. Well, why did you say that we would be considered a flat Earth channel if we talked about Euclidean geometry? Why would you think that?
You can't paint a picture for yourself there.
He's saying that Euclid is a flat Earth.
I can't. I can't think why anybody would associate Euclid with flat Earth.
I mean, it's bizarre.
So you don't know why people would associate Euclidean with flat Earth. Okay.
Well, a straight line?
Perpendicular. Is it perpendicular that scares the
straight lines on a ball? And so if people coming in with the notion that
there's no straight lines on a ball, so that makes it flat Earth.
No, if their rhetoric is there is no straight lines.
Who's there?
Your proponents that come to your show
no, dude, there's no proponents against Euclidean geometry, is there?
I'm not saying they're against Euclidean geometry. They're
logic. Is there any proponents against logic?
They're against being limited to Euclidean geometry.
Anybody can do whatever they want. Like, I'm not telling everybody they're not allowed to do anything that they want to do. I'm just saying we're a channel, simple channel, logic, geometry, and reality and testing. We're doing realizing Euclid, so we are trying to replicate Euclidean geometry in reality. Now, Are you one of those people that consider that flat Earth?
I consider a channel that emphasizes one particular argument relentlessly.
Which argument would that be?
Reality.
Logic.
That present reality,
geometry.
That present reality and our senses depict one type of philosophy.
A philosophy? And we don't really do philosophy. I mean, Aristotelian. Logic.
If you ignore that philosophy in your senses, that potentially
what philosophy?
Well, you're going to gather your interpretation of your reality from whatever beliefs you have about that reality. If that reality,
just talking about logic and geometry and reality, right?
Sure. And where does your logic and where does that logic and reality come from?
Aristotelian logic, right?
Sure, from
explosive logic.
Right, from studying the world around you, that's where it comes from, right? Without
the truth values, right? Trying to keep a hold of truth value through the logical statements.
Like Plumb bobs. I give you a vertical straight line.
Mm-hmm.
Anyway, there is enough mathematical there. I'm just trying to give you an easy formula.
And because you have that straight line, you can have perpendiculars from it. That's Euclidean. Is that what you think might be flat Earth?
So if you're on a localized level, and it's all about the localized level, and it's all about Euclidean, it's not going to be hard for people to assume that this is a flat Earth channel, regardless of whether or not.
Why would they assume? Is it because people like flat Earth data keeps coming round here talking about flat Earth and globe Earth, completely obsessed with it? People like that. Yeah, do you reckon? Should we stop people coming round talking about that? People might associate it flat Earth, this channel, talking about logic and geometry, because people like flat Earth data keep coming round here.
You shouldn't be afraid to.
Ain't nobody afraid here, chump.
You shouldn't be afraid to promote the flat Earth, but you're.
Wait a minute.
You're in here, aren't you? Promoting flat Earth. I'm not shutting you down.
I'm discussing spherical trigonometry or geometry and how the validity.
Go to gyms with that, can't you? I don't want to hear that. You can go to gyms with that.
You're saying, Data, what you're saying at the minute is that because we talk about Euclidean geometry, you think we will be flat earthers. You're trying to associate us with flat earthers because we talk about Euclidean geometry. So it's people like you, Data, that are doing that.
I come here with spherical conversations.
A spherical conversation.
Spherical geometry.
Yeah, you're obsessed with it, obviously.
And then I go to gym for Euclidean geometry. So yeah, I go to two different departments. Spherical, and then Gem Panda with the trig. I don't come here for the trig. I come here to test the spherical side.
You test
I already know you know Euclidean, but what do you know about spherical trigonometry? What you've stated over and over again.
What spherical trigonometry is, right? And I also know that you seem to keep getting confused between spherical trig and spherical geometry. You seem to be the one that keeps misunderstanding what it is you're talking about.
Spherical geometry is not the measurement of angles. Spherical trigonometry is measurement. So we're refining descriptions with measurements, sure. I'm trying to figure out why you want to denounce spherical trigonometry, or why you want to denounce.
You sound like Babs right now.
I want to know why you want to denounce it. So when I come in,
I want to know why you keep misrepresenting and swapping the words around. I hope everybody's listening in. Who's listening in? Who have you got listening in? How do they think you're doing? Is it like keep swapping between spherical geometry and spherical trigonometry as though it's not the same thing? Because they're not the same thing.
learn where your aptitude is, then I'm going to ask
you want to learn where my aptitude is.
Spherical. Your brain.
Yeah. You're teaching me loads.
You told me that spherical trigonometry is dumb. It's pointless. It's stupid.
It's two-dimensional. It doesn't exist. It's conceptual.
Exactly. That's why you can draw it on papers. But the point is that there's proofs mathematically for it.
You cannot draw it on paper.
You can draw a spherical...
There's only one geometry that makes it into 3D. Reality. Right? Now, you know what that geometry is. Just that you think people talking about it will be considered flat earthers. Is that why you want to talk about spherical geometry and spherical trigonometry? So you won't be associated with flat earth?
Again, why I'm discussing this is because the application is real, it exists, and it's true. Now, whether it's applied in your reality when it comes to measurement or localized flat.
Is it applied in your reality?
The argument is that it's real, it exists, and it's in the maths. And it's in calculations when it comes to navigation, calculations when it comes to, I suppose, things that we can't verify or validate, which are model-based. But like the Habersign formula or spherical trigonometry.
Habersign. He's with Bob. Watch out now.
There's no going and learning about that is nothing. There's nothing wrong with that. It's applied, but the problem is that you need a radius for the Habersign. So that radius comes back to where did you get the radius? So again, it exists. It's there. I'm not afraid to discuss it. Again, like I said, I come to this show with spherical triangle stuff, and I go to fucking what's this pickle show with Euclidean stuff because there's no point talking to flat Earth.
You play both sides, then, right?
Yeah, another percentage.
That's the whole point.
That's the whole point. To play about, fuck about, give people one argument, go over there, give them the other argument, fuck about with people, right?
It's not about that. It's about finding the truth, and that means you don't choose a side. You listen to both.
No, it's not a side chosen. That's what you don't understand. There's not a side chosen over here. If you keep on over talking me, there's not a side chosen over here. We just talk about reality.
Sure, and that's fine. I appreciate that, and I'm in agreement with the approach to the objective reality that you guys discuss, and the pragmatic use of Euclidean in that objective reality. I agree with you. However, there is still
I don't care about no howevers.
There's still a major problem with understanding that spherical trigonometry or spherical triangles exists, and they're used. To what level they're used at, or to what purpose they're used at? Well, they're used in celestial navigation. Why are they used in celestial navigation? Let's find that out.
Are you doing celestial navigation?
Let's just find it out. Let's find out why.
Off you go. Yeah. Go and get Brian. Brian will help you.
It's all good, guys. It's all good. It'll all come in time. I'll be back.
Yeah, what we do here, right? Data. I'll fill you in. We just do the basics, the fundamentals, right? We'll leave other people like you, Brian, Nathan Oakley, all that. You can do all of the good stuff. We just stay right at the basics, first principles. We're at the straight line at the minute, and we're going to go backwards again to learn more about the fundamentals of grammar, rhetoric, and logic. Because going backwards to find a firm footing is where we're at. Now, you guys can do whatever you want. We're not talking about the Earth. It's a ridiculous argument. We all live in reality. Whether you decide you want to argue about whatever type models that you want to think or you live in, and whether you think geometry can change on different surfaces, or whether you can make up different geometries, whether you make up how many angles a triangle's got. Is there a shape where you can have more than 540 degrees in a triangle? Let's work that one out for a bit.
Apparently you can have 4 pi.
Yeah, you read that, did you?
The point is, Bev, is that there's a reason why they created.
I didn't want to answer that question.
Right, and when you.
Yeah, right. Yeah, right.
When
you didn't want to answer that question.
There's also a reason people keep proliferating it, keep talking about it, right?
Well,
there's a reason people made some shit up, and there's a reason other people keep talking about it.
It's better than watching 90 Day Fiance, Bev. It's better than watching, people play video games. It's better than watching fucking UFC shit. It's an intellectual debate. Philosophy.
Yeah,
there's no debate, bro. That's what you don't understand here. There's no debate. I mean, if you start your own show, you can start your own debate. Maybe we might come watch it a little bit. Then I'd be like, hold up. I don't know about that.
It's a good point, though, right? What would you debate first off? What would be your best debate thing, Data?
I think it would be an awesome endless podcast.
Yeah, well, that's the whole point. You need to be able to talk about anything and everything, right? Or else,
What would be your best debate, Data? What would your best debate be?
If I was to start a show, I would start out on how do we get to this? How do we get to the point of why the rotation of the Earth matters? What's the point of it? Or whether it's flat? What's the point of
the Earth or flat? It's not flat.
What's the point of it? The point of it is to what? To discover where we live, right? Well, you had philosophy.
Rotation of the Earth.
I'm in my house now.
So the point is to figure. I don't give a fuck where we live. I don't care what shape it is. I don't give a shit. It doesn't matter to me. There's other people that. Yeah, there's other people that need to know the shape.
I don't know. Now, is there anybody in the chat right now that needs to know where they live? I know. I already know where I live. Is there anybody that needs to know and really need to? Because Data apparently has all of the information for anybody that needs to know. DM Data, Flat Earth Data.
Oh, sorry.
Bev.
Don't
Bev,
be saying.
He said he don't care, but yet I'm trying to inform you where you're at.
Yeah.
Yeah.
Is
So
that a
teaching you have to be lost to not know where you're at, right?
Yeah.
Yeah.
Data's lost.
By teaching anybody Euclidean geometry, the purpose of it is for what? To know where you live? No, you know where you live without knowing Euclidean geometry. Euclidean geometry just gives you a evidence.
What we do is we use it as a tool to teach people logic, which is a new, different way of thinking, right?
Sure, yeah.
It's been
a different
lost.
perspective.
Mm-hmm. Yeah.
Yes, absolutely. There is no critical thinking anymore, Bev. 100%. Yeah. So I would want to have my show start out with a form of the ontologicals, whether it's evolution, cosmology, religion, whatever it is why are we at this point?
Well, yeah, we don't do that. But are you touting for it now?
What's that?
Are you touting for your new show?
No. I'm just saying that's what I would do if I had a channel. It would be.
You do have a channel.
Not a real channel, dude. I got rid of my other channel.
Doesn't matter.
You have a YouTube channel though, right?
No, I got rid of it. I had a Flat Earth Data channel. I deleted it. Oh. Actually, the first one I deleted. The second one I got 3 strikes. So.
All right. What for?
Well, fuck! I'm not building up. I had 800 subscribers. Fuck all. It took me
why
did
you get strikes? It wasn't Globe Earth Science people.
Because I posted stuff. I posted the stuff against the COVID narrative.
Oh, right. So it wasn't Globe Earth scientists copyright striking your material.
I posted a doctor here that was interviewed in front of hundreds of people regarding the gene editing technology that they have in the vaccine, and that was the last. I think that was the last video.
All right. Yeah,
and then I got deleted.
Yeah, we don't need to know.
Yeah, we don't do that here, mate.
So just start over fresh. You can redo it again. Don't be afraid.
There's no point to it, right? I mean, there's so many. I need to get this one thing.
Isn't there a lot of people that need to know where they live? And aren't you the one to help people find that?
There's literally 1,000 people that do this debate, 500 to 1,000 people that localize this debate. It's a fucking small ass crowd, Bev.
Yeah.
What debate?
Yeah. So it's not a lot of people interested.
We're even smaller, right? Because we just do logic and geometry.
Yeah, but you're part of the train, right? You're part of the
feature. We are the smallest of the small crowd. Don't worry about us, right? If you want to sell to people where they live, then you should start your channel up. You can like, we're only small. You could be as big as us. Like you say, there's loads of people that want to know where they live.
This is fundamentally where it comes down. For anybody that got into this debate started from a video, started from somebody introducing them to something. Where I started was the same way, but then I caught on earlier. I caught on earlier to go to the sources which would be the earliest content, written content from Robotham, Gleason, Hickson.
We sat in a dinghy. We actually did it practically.
Sure.
Robotham, yeah.
You went and falsified it, and you were given an observation that you can falsify. That is part of the process of falsification, is being able to give something that's testable. Robotham gave you something testable.
Yeah, we just actually practically did it. We didn't go and research it. We went and did it practically.
You falsified it, right?
No, we just practically went. I didn't falsify anything. We went there and did it. Like what do you think we falsified?
You falsified that there is no an inch per mile squared drop.
No.
Well, that's what that's the only way to do it. You couldn't unfalsify that. You falsified it by.
No, we put the camera in the thing and went, Robotham, there is no way Robotham did what he said he did. Standing in the middle of a canal going, yep, I can see it. No, he didn't.
Okay, so what are you saying with the I didn't see your observation. No. So no, I didn't. So you practiced, you attempted to repeat Robotham's because he was standing in the telescope 6 inches above the canal?
8 inches.
Is it 8 inches? So it was 8 inches above the canal while he was in waders, right?
Mm-hmm.
Is that correct? So he couldn't stand in the canal with waders on because the canal is too deep?
Yeah, we were in a dinghy.
Okay, so what did he do? He had flags along the side of the canal.
Yeah.
And I have to take this call, sorry.
Oh dear, he doesn't know what Robotham did. I thought he said he was researching Robotham. Isn't this weird? People don't seem to understand and know that what we've done. Yes, that's right, people. We have actually, my son, has actually filmed Robotham, what Robotham did. As a guy went away in a dinghy.
So I read that he had flags along the side of the canal. And this is, mind you, years ago that I read this observation. So he didn't have flags along the side. There was also one flag at the bottom of the...
I don't know what Robotham did.
Well, there's some guy that did the same thing, a repeat of it or something, and he had flags, and it showed that the flags along the canal were doing something. I have to go back and read it. But point is that the Earth was supposed to be curving 8 inches per mile square, and along this canal, he still saw the flag, which would be falsifying the curve of the Earth. Right? That's his whole claim.
What?
And then, your claim is that Robotham. And your claim is that Robotham didn't do the observation because he couldn't stand in the middle of the canal and took the observation at 8 inches above the surface of the Earth, or the surface of the water, right?
Oh, you don't half make up a load of shit, don't you? Is that what you heard?
I heard this. Correct me if I'm wrong. Robotham didn't do what he did. He did not stand in the canal with a telescope 8 inches above the surface of the water. Is that correct?
No, that's not what I said.
Oh, what did you say? Correct me then. I must have heard it because that's what I just repeated to you. So just correct me.
Right. We have been there. Put the camera above 8 inches above as a guy went away in a boat. Right. Now, we have seen what happens when the camera is so close to the water. And we've filmed it. Now, Robotham said he saw it. The boat. Right? Over a distance. Didn't he?
Okay. Well, that's what his claim was. Yeah, he said that it wasn't obstructed by the Earth curve. Yeah.
Well, it wasn't obstructed by the Earth curve, but the actual refraction or whatever stops you from being able to see it. There's a mirroring that raises up. Yeah.
You did this video? It's on your channel? Because I'd like to see the results of it.
It was like 3 years ago.
Okay, so it's buried in your video somewhere.
Yeah, I think so.
Do it again.
I gave it to the guys.
You should do it again, and you should try it at first thing in the morning.
Why can't you do it? Why can't you go out there?
Well, we went down there as well and did the Wallace one at the bridge with the auto level.
I've done
taking
lots
a picture through the thing right from the bridge, and because Rumpus is going to do it, you heard about Rumpus doing the drop. Rumpus is going for the big nutsack drop.
I stopped listening to Rumpus,
rather than the hump. Yeah, but I mean, if you're into research and you've done Robotham, did you do Wallace and see how Wallace is differed? Because we've been there and done Wallace as well. And hopefully we're going to go there and see the Rumpus, right? Because you're going to be able to say Robotham, Wallace, and Rumpus coming very soon. Rumpus and George, no doubt.
Which one did Wallace do again?
Bedford. I thought you said Wallace you'd researched it.
Maybe Wallace did the repeat with the flags then. Maybe Wallace is the one who added the flags.
Maybe.
Because Robotham didn't add the flags on the side of the canal. I think Wallace did. I'd have to go back.
This is didn't he? One of them did it from the bridge, and the other one did it from the water.
Yeah, and there's some issue with the flags, and then Wallace. I don't know.
They both went for the hump.
Yeah, deceptive on both parts, I think.
Yeah, and whereas Rumpus, he's going for the full nutsack drop. He's going the full quad. He's taking use of majoring on the quadratic function, right? Those Robotham and Wallace went for the hump, whereas Rumpus is going for the full quadratic nutsack drop. 4 times it, 20 odd feet. Rumpus is looking for drop of. It's impressive, right?
If you're going to grow the horse to fit the saddle, then you can make the horse fit whatever saddle you've made, right? Because you can change the size of the saddle to fit the horse. So, if you have an error, if you have a measurement, but the error, there's an error here of, 5 arc minutes, and that 5 arc minutes just happens to be the, the refract.
No, Rumpus isn't measuring angles. No. Rumpus is erecting flags.
Oh, he's doing the flags ones too. So he's doing Wallace's again then. He's doing the flags. Okay.
But he's going for the full drop. He's going for the full 20 odd feet drop over the total distance. He's not humping it.
We know that's already been, already know that you can take lines of water, right? Like you can take, let's say, 50 bottles of water, line them up in a straight path, and fill them all with the same level of water, and you will actually appear that water level will appear to curve down, right? Like you guys know that observation. You've seen that one, right?
Bottles of water up.
So if I took 50 bottles of water, lined them in a line, and then put the camera down to the ground, and then looked at that water, all those water along that bottle, all that level, even if it's all level, it'll appear to dip down, right? With no refraction.
What, bottles of water? Like 50 bottles of water?
So if you take 50 bottles of water, you all fill them up to the same level, and you lay them out in a straight line, and you put a camera down on the ground, that water along the line, the sight that you see, will actually appear to curve downward.
But 50 bottles of water are just 50 bottles of water.
An optical illusion.
Depends on if you fill them up to the same level, doesn't it? If you fill them up to the same level, they'll be level.
50 bottles.
You're correct. I'm just giving an example to show you that the curve is exponential, even at a small scale like that.
Yeah. I mean, it's like the lens itself. Wow. On the outskirts of the lens, it curves to the point. On the outsides, it curves a lot. Okay, so what?
That's all I'm saying. It's an optical illusion. So if he's going to go lay out flags, it's no different than having those. If the elevation profile information is horizontal, truly, and there's no elevation changes, then those flags are going to operate the same way as those bottles of water all laid out horizontal. You'll have an apparent dip, and that has nothing to do with the Earth.
Who's even worried about that?
It's the argument, right? It's like people who don't understand the argument or know the argument that knows that they're like people like maybe.
I don't think you understand the argument, mate. Do you know what water level is? Do you know what the water level is? The tool. I know you've been I've been away for a while, so. I mean, you are familiar with the water level, the tool. You earlier on you used fish tanks, and
I was
you want to start looking at using the actual tool for measuring. Level.
I didn't hear that. What? I didn't hear what you said there, bud.
Yeah, because Dad, I was talking all over you. Go ahead, spot on.
I wasn't talking over him at all.
Go ahead.
Right. Can I just get a clarifier here? Because Data, you're fucking all over the place, mate. Like, what is your position on this shit?
The position on what shit?
Well, we're just trying to come from reality, right? Let's keep it basic, simple, logic. In reality, are you fighting for the case of angle to a curve?
In reality, we use straight lines and angles. The Earth is horizontal at all points of position. That horizontal is parallel to the plane at all points of position.
Parallel to what plane?
Your horizon.
The horizontal points.
Yep. That's all parallel to the plane. Now, depending on your elevation, you won't have equal points of... You won't have
parallel straight lines. Not points.
What's that?
Parallel, right? The definition of parallel is straight lines. Now, you said all points are horizontal, right? Now, a point isn't a straight line.
All points of position on are horizontal. So if I have one point of position to another point of position, it's horizontal.
No, Data.
If
you have one horizontal point that's on a different horizontal point, then if you join those 2 points up, that line will not be horizontal.
Yeah, can I just say that just a minute ago? Sorry, I was just saying that why earlier on you're using fish tanks, as a demonstration example, and then you were using your water bottles. But I'm sure I've been away for a bit. I haven't been around for a couple of hours, but you're aware of the water level, yeah? What I can't understand is why you keep using these other things that aren't not designed, but used as tools to establish levels. Yeah, well, maybe use the water level. That's what it's for.
In the same, that's why you exaggerated with the fish tank, is because if I had a large fish tank and I filled it was, let's say, 5 feet deep, 1 foot wide, 50 feet long, I could fill that up.
What are you going back to the fish tanks for?
I could fill that up. I could fill that up, move 50 feet away with another one, fill that one up, move 50 feet away, move that one up, and provided that the elevation...
water level, the tool, mate. Just get the tool, the water level, yeah? Do it.
Sure. And
you're trying to establish a water level, then that's what you'll use. You don't go and get a load of fish tanks. Sorry, mate.
I'm using it as an exaggeration, my friend. I don't know if you caught on to that yet. You know, it's an exaggeration.
Don't exaggerate it. Let's talk about what is, rather than exaggerating it.
Well, because it would work the same way. Right?
Well, no, not really, because you just got one water pipe, and you're talking about numerous fish tanks.
Depends on what the conclusion of the statement was. My conclusion to my statement was that if I have all of these points of position that are horizontal, they will be parallel to one another. Now, are they equal points of elevation? That's not what I'm saying, but they will be parallel to each other. And in other words, if I have changing elevation profiles...
Dude, the points will be parallel, or the lines will be parallel. If they're all on the same horizontal, they will not be parallel because they will be the same horizontal. Now, if they're lines, then they can be parallel, but if they're points, they cannot be parallel.
If you have one point that's horizontal, and how do you get a horizontal? You need
2 points to make a horizontal.
For horizontal, you need 2. Well, you need a perpendicular to know that it's horizontal, and you need a distance between those 2 points. Right? The point is that
we're going to go back to the plumb bob in a minute, aren't we?
No.
Plumb bob on a water level. There you go. You got perpendicular. There you go. Simple.
Sure. The point is
one doesn't. One can be established without the other. You were claiming earlier that you couldn't get the plumb bob to be straight unless you had a horizontal.
He just said it again. He said you need a perpendicular in order to establish a horizontal. Yeah, exactly, well, you don't.
How do you get the information? You need one with...
You need a level to establish a horizontal, and you need a plumb to establish vertical data.
Yes, but you can't have a vertical without a horizontal, and you can't have a horizontal without a vertical.
Of course you can.
How do you get a vertical without a horizontal?
Got 2 different tools, mate. One's designed, for one thing, and the other one for the other. Yeah.
How do I know it's reaching a certain height of elevation?
Because it's level.
Okay, so when I'm measuring a vertical, I know that level, therefore I'd be able to get the elevation. Is that correct?
Data, do you know the difference between level and plumb?
Level and plumb. Well, there are 2 different plumb would be an orientation.
Reference frames?
Reference frame. Right, yeah. I'm not Googling nothing. Sitting here trying to make myself some boiled eggs.
Flat Earth genius, Data. I don't know. You should definitely do the rounds again. You deserve to go on all of the other channels. I've been on them, but deserve to do that.
That's the only channel that I go on, right? I go on other channels as well.
I know, yeah, saying like you should definitely do it.
There's no definite do it, dude. I'm almost done my shit. I'm at the crescendo of my storytelling, and there's not going to be an answer. There's not going to be a direct answer because it just comes down to philosophy. It comes down to...
No, it's because you don't think a plumb bob is straight and can be established without a horizontal. That's one of the problems there. You understand?
No. I'm saying that a plumb bob is useless without a horizontal,
Wow. Wow. Like, seriously, mate, think about that. What you're saying.
A plumb bob is useless unless I have something to measure it for or against. What am I going to use a plumb bob without a horizontal? What?
I'll establish, if I want to know a point, no, I'm not going down that route. I mean, if you want to establish a vertical,
give me an example.
Yeah, if you want to draw a line on a wall and you just put a nail in the wall with a hammer, a bit of string hanging down with a weight on it, and then you mark the point along the line of the actual plumb bob. You know it's vertical.
You know it's vertical.
You don't need a horizontal. No, nothing to do with the horizontal.
Because the horizontal already exists. Without you knowing the horizontal exists, you wouldn't know that it's vertical.
Oh, Data.
It would just hang down.
Have you ever done anything practical, ever?
Limited, but I have done stuff. I've done renovations and all that shit, for sure. I've cut, built, sawed.
And do you think this is some sort of an argument?
What's some sort of an argument?
Right, by saying, in order to have one, you need two. Oh, sorry. In order for you to have two, you need one.
In order to have one indicator, you need another indicator first, yes.
Okay. So that's an argument, right?
Nope, it's a statement.
Yeah. Okay. So you make a statement in order for you to need horizontal, you have to have vertical.
To have a vertical indicator, you would need a horizontal indicator.
Right.
Yep.
And what about a horizontal? Do you need a vertical for that?
Well, that's the default. Is the horizontal is the default.
Okay. So what do you need in order to have a horizontal then, or can you have a horizontal on its own?
What do I need? What?
Wait, can we have a horizontal on its own if that's the default?
Well, that's what it is, right? That's the before.
Okay, so we don't need a vertical then for a horizontal.
In this particular case, if I want to create a vertical, I would need the horizontal. Yeah.
Yeah, but if we just need the horizontal, we don't need the vertical.
If you were going to make a measurement off of the horizontal, you would need another way to measure off the horizontal. In this case,
for elevation, yes, because that's on the vertical. We know that, right? But in order to establish a horizontal, we don't need a vertical, do we?
To establish a horizontal, you do not need a vertical, no.
Brilliant. Why did you say we did? Why did you just tell spot on we did?
You wouldn't be able to
because you're an annoying, argumentative twat that forgets what he's arguing about. He just wants to be an argumentative twat, right?
How do you determine it's horizontal?
You just get a tool that's called a level. It establishes horizontals.
It has a vertical point in the middle of it, right?
It has a horizontal. All the way along it. It is a tool for establishing horizontals.
You have a vertical point within that level that shows you that...
A vertical point? What the fuck are you talking about now?
It's a point in the middle.
It's a point what is a point, Data?
Let's say it's a line then. Let's use
that
a
of
line.
Which has no parts, right?
My level.
So you can't have a vertical that has which of no parts. It doesn't exist.
If I look at my level...
The tool that establishes a horizontal...
There's a bubble in the middle that has lines on it.
No, there isn't. It's a tool that establishes a horizontal.
That bubble in the middle has
There's no bubble in the middle.
Okay, so if we're looking at a water level, there's a little bit of an alcohol bubble there, right?
No.
So,
Data, seriously, you can't have gone this long without knowing what a fucking water level is.
Not a water level. I mean, sorry, not a water level. I meant a... not your fucking water level that you have on your show all the time. The fuck is it called now?
I don't know. You don't even know. Like, what the fuck are you doing, Data? It's so obvious. You're one of these people that just wants to argue bullshit. You don't even know what the argument is.
The middle.
It's embarrassing.
Need a perpendicular to the horizontal to get an angular measurement, whether or not it's horizontal. So how do you know it's horizontal? You have an indicator.
We have a tool that establishes it, yes.
And that tool has indicators on it. Now, how do you know that?
Water level, yeah, you find out each end of a water level and say it's a tool that establishes a horizontal plane of reference. It needs no vertical.
In a water level, you have two open ends and a tube that connects them.
Yes.
So in your water level that you're using, you don't have a way. You can get, I suppose, a universal horizontal which means that both ends will equalize, and you'll get tube filled up, and then you will have a horizontal point. But the indicator...
No, you will have a horizontal plane or line, not between a point. Those two.
You have a line between those 2 points and give you the horizontal.
That's what a straight line is, right? The shortest distance between those 2 points would be a straight line. We will call that a horizontal, wouldn't we?
In a bubble level, you have a middle point position.
A bubble level, a water level.
Let's go to a bubble level now.
Why?
A bubble, because in my example is where you need the vertical.
Right. No, well, let's make that bubble level, right?
It's
as long as the water level, and let's put the water level so it's at each end of the bubble level, right? So we can ignore the bubble, or we could use the bubble as a check after we've set each end of the level to the horizontal of the water level, right? And then we'll check the bubble and go, oh, hey, look at that. That's in the middle too.
You don't have an indicator on your water level to show that the center position between the 2 points of the measurement.
If we put a massive spirit level there, though, right? Then we would have that middle bit, right?
Which is the vertical.
No, it would be the horizontal. The spirit level would be the horizontal that goes all the way, straight line from one end of the water level, all the way to the other.
In that spirit level, the indicator would be the vertical. In other words, that's how you know your indicator. So if I have a spirit level and it's off to the left a little bit, the bubble is going to go to the right. It's going to indicate that my vertical isn't perpendicular to the horizontal. That's why my bubble has moved to the right.
Yeah, but
do you understand?
Yeah, but if you had a water level and the spirit level over the two ends, right? Then the two ends would be set by the water level.
Without the vertical indicator on the spirit level.
What vertical indicator? The horizontal. Bubble.
So how I know it's horizontal?
Why do you think it's vertical? Why are you getting confused about a spirit level having a vertical indicator? It's not doing a vertical.
If you look at the bubble
spirit
indicator,
level, it does a horizontal, right?
Those two lines are not horizontal. On the vertical, on the bubble
two lines aren't horizontal?
The two lines inside the indicator are not vertical. They are, they're not horizontal. They are vertical. Okay.
Which two lines?
Are you fucking dumb or something, Bev? Your spirit level bubble indicator has two vertical lines on it.
Holy shit! Are you talking about the lines on the bubble?
Yeah, they're vertical. They go up and down. They don't go horizontal.
The ones that you judge where the bubble is.
That's correct. It's between two vertical points. And if you have it, if it's not horizontal, it will be off. Those are vertical lines on that bubble indicator. They're vertical. They're not horizontal lines. They're vertical. That's the vertex. That is the point where the vertical comes down to a 90, creating a horizontal, or creating a perpendicular to the horizontal.
Oh God!
Wow. Without those two indicators, you wouldn't know that your bubble level is horizontal. And they're highlighted by two vertical lines.
They're highlighted by two parallel lines, dude.
Two vertical parallel lines. You got it.
They're not vertical until it's okay. Whatever. You love going around in circles.
You can't get a fucking horizontal without the vertical. In the spirit level proves it.
Are you all right, Data? You coping well?
Coping. I'm just debating whether or not to smoke a joint today. I quit for a very long time. But I like sometimes smoking a joint and doing a debate. But I've been trying to I'm trying to be clear-headed and a better person. And I don't want to make you a bad person. You can fall into some bad habits.
Yeah, you sound like you need one. You chill out a bit.
I'm debating to get one, but what happens, Bev, is the opposite. I become more talkative. I become more interested in conversing, not the other way around.
Oh dear.
Well, which way is it that you're more full of shit?
Well, talking to you guys, it wouldn't help either way, I'd imagine, because you're just going to have your opinion regardless. So it really doesn't.
You mean those two lines there in the middle of a?
They're vertical, Bev. Yep.
Are they?
They're vertical in its orientation. Yep.
Are you sure? Well, they're just circles.
Yeah, they're right. They're vertical, right? They're up and up, right. They're not horizontal.
If I look down at it,
there are vertical circles.
I'll take another picture. Looking down on it. So you tell me which way these are orientated. This way.
That's it. You need them both. In conjunction, you don't have anything.
Hang on. Here you go. Just in case it's on my table, right? Next to me, Rizzlers. In case you were planning on making a smoke. There you go, look.
No, what are you smoking a doobie yourself?
No, just the licorice, Rizzlers, don't worry. But see, are those lines, are they vertical?
Yes, Bev, they're vertical.
I'm looking down on it. I'm looking down on that, right? I mean, I know it's on the screen. They may look vertical. But I'm looking down on those. They're just like circles.
Sure. How do you know your spirit level is horizontal? Does that water bubble have to be in between those two lines to be horizontal? I think so, right? I think they're smart enough to realize to give you a vertical indicator to know that you're horizontal. It would only make sense making a tool. You'd need a vertical indicator to know that it's horizontal, or a horizontal indicator to know that it's vertical, right? It would just make sense that that's how you would measure shit.
Do you think those are vertical because you're looking at it on a screen?
They are vertical because they go against the horizontal nature of the ball.
Look at that. You bet you thought it was a big one, that. It's the world's smallest spirit level. It's a little dinky. It's a pocket one. Look at it. It's a beauty, isn't it?
Yeah, Bev, you're right. They are circles around that glass in there, right?
Yeah.
They're not lines.
Yeah.
They're not circles. You're right. I mean, they're not lines. You're right.
Yeah, do you think, you don't think they're vertical, do you? I mean...
They're orientated upright, which means the bubble sits in between.
They're circles.
Yes, they're two circles that are vertical to the horizontal. Yep. They are not horizontal circles. They're vertical circles.
But they're only vertical unless the level's level, right?
I didn't hear that. What? Say that again.
Those things you're calling verticals will only be vertical if the level is level.
If the spirit level is horizontal, then the indicator would show the bubbles between the two. The bubble is in between those two vertical lines. Yeah.
But could you establish the two lines without the level? If you just had those two lines, could you actually get them, vertical?
Without actively needing to know that it's 100% vertical, no, I could just drop something and I would get a vertical.
Are they vertical now?
Two lines.
Know that it's true, but to know that it's truly at a 90 or truly perpendicular to the horizontal, I would need a reference frame, or I would need something to measure against it.
Yeah.
Do you have it? It's all in.
Sandy, it's on a level, isn't it? What about that? What are the chances?
Look at that last picture, Beth put. Now, are those things vertical?
On the spirit level, anybody can see as plain as day. Those lines that indicate whether it's horizontal or not will show.
They're not vertical at the time, are they?
Yeah.
They're not horizontal. They're up. They're not. They're not a direction of the level. They're
not vertical
the
either. They're not. They're neither.
They're definitely not vertical. They can't be vertical.
Can you have horizontal circles and vertical circles, boys?
Yeah, what is it in the picture? The last picture. What do you think? What are you saying that is?
I've seen many spirit levels. The two lines. Those two lines are vertical, boys. That's a fact.
No,
are they vertical right now? Are they?
to draw this out on a two-dimensional.
If the bubble is at one end, would you say that they were vertical, those lines? Circle?
I'm not looking at your picture. I'm just saying that every spirit level that I've ever...
if the bubble is at one end, you know what that means, don't you?
At one end, that if it's, let's say it's tilted down to the left, the bubble will be up to the right. So no, it wouldn't be horizontal, right?
Right. Okay. So there you go. You just answered your own question, mate. That is it. That's it.
How do you know it's not horizontal, right? It's the indicators that are telling you, right? Other than, obviously, at some practical application what horizontal is relatively, because we're obviously aware of it.
Level, because the bubble's in the middle, like in where it, correct position, calibrated. If it's calibrated, obviously. Then if you have a 90 degree off of that horizontal, you'll get a vertical. But you have to have the horizontal to get the vertical. That's what I don't think you're getting.
You need one of the other to get a reference where you're at. So you're saying that
only if you're using you're using those lines that are on that tool.
Okay, so you're just saying that because I hang something, it's 100% perpendicular to the horizontal. We just know that from practical application, which we agree upon. But how do we confirm, for instance, that it's perpendicular to the horizontal? How do we confirm that?
Because it's a plumb. It's plumb, right?
I get the picture. We already know this, but how do we confirm? Not just assume. How do we confirm? What do we do next?
It's a fucking plumb bob, right? Are you doubting a plumb bob is plumb vertical? Like you're doubting it. Flat Earth Data is doubting plumb bobs, right? We'll ask him. We'll have to ask more people.
Well, he's been doing it for hours.
It's genius.
I thought you might have got the grip with this.
Yeah.
To be honest, I thought you'd have had this, but Flat Earth Data.
Keep trying, guys. I get that the
No,
vertical...
seriously, mate. I thought you would have figured this out.
No, if
plumb
you guys...
is always...
I agree with you.
Never unless it's windy or, whatever. But as long as it's left to do its thing, and you got a heavy weight on the bottom, so it was... but obviously it have to be precise.
It's like a water level as well, right? You can't stop a water level from being horizontal. And you can't stop a plumb bob from being plumb, vertical. Unless you're moving it or physically acting with it. But a water level at rest and a plumb bob at rest will both be horizontal and vertical. You can't get away from that, right? Now, they don't need each other ever.
How do you measure to know what you if you want a proof?
You establish.
Okay, if you want a proof, run through a proof with me that a plumb bob is perpendicular to horizontal. How would you confirm that?
You would confirm it by establishing a horizontal.
There we go. That's all I'm saying.
But you said no. Wait a minute. You said perpendicular. Right. So in order to establish a proof for perpendicular, you need two straight lines that are perpendicular. Now, just to establish a horizontal, you only need a level.
Right, which has a vertical in it.
No, it doesn't. It's just a level.
Right. I'm thinking about a spirit level, boys. Sorry. So we keep going from water level to spirit level. In a spirit level, you need a horizontal. You need a vertical. In a water level,
you can draw lines all over the place, right? Wherever you want. You can have a level that has verticals on it. Right? Now, just because you put the level in the horizontal position doesn't mean that you need the vertical lines on it. A tool that establishes a level will establish a level without a vertical. And a plumb bob will establish plumb without a level. They're independent.
A water level, yeah, but a spirit level has vertical markings in the bubble part that show that spirit level is horizontal or not.
That's one of the weakest arguments I think I've ever heard, Data. And I'd be embarrassed that please don't try that with anybody else, right? If you're practicing your arguments.
We've been at it for 3 hours, I think now. I'm going to step aside and
7.
Fuck that! I haven't been that long. Maybe you guys, a couple hours for me, and maybe I'll we'll partake
Data,
and come
you
back.
were the one that came here 7 hours ago, Data. That was you.
I've never been here 7 hours ago. Get out of here, dude.
Here you have. 6:59, 05, 06.
No, dude, I've only been here for maybe 3 hours. That's it.
Dude. Time warp. Did you have that smoke? Just lost 4 hours. I can take a picture of me record. Yeah, it was you, Flat Earth Data, that came in earlier that made me start recording, wasn't it? Before we started with the live show.
So apparently I was there for 2 hours before you...
me tea.
Apparently I was there 2 hours before you started the live show, so I don't know.
Yeah. Were you? I think you were.
That's what I was told. I didn't verify that. That's what I was told, though.
Uh-huh.
No, he was here way before. We are live. Yeah. You know, I can't do it like Beth.
I've got 7 hours on a record and 5 hours live, so.
We've been recording for 5 hours live? No fucking way. Here, I reached out to Emma because I was.
What time is it? I start at 8 o'clock and I started at 8, so UK time. Oh, look, it's 1:15 a.m. So, yeah, we have been going live 5 hours. Time flies when you're bullshitting, going around in circular arguments, I guess, Data.
9:23 my time, I reached out to Emma. I said, hey, why can't I join your show? The channel is blocked. And then shortly after that, I was accepted into the show. So it's fucking that long. You're correct. Wow.
Yeah, time flies when you're obfuscating like a motherfucker.
How about debating and understanding, the argument between people who object?
You keep saying argument, dude. Like, you've never come up with an argument yet.
My point of contention would be my position, my argument.
Which argument is?
Which is spherical trigonometry is a real thing and it's applicable to reality. Is it used in building and construction? Not that I'm aware of. Is it used in parts of celestial navigation? Yes, it is. Does it work? Yes, it does. That is the reality and a proof that spherical trigonometry does work. Now,
you keep talking about spherical trigonometry. I would definitely agree with you, right?
Okay, because it's about measurements. Spherical geometry is a different category. We're talking about measuring angles.
Yeah, spherical trigonometry is the trigonometry using the planes on a sphere, right?
I was misappropriating the difference between geometry and trigonometry. We're not discussing shapes. We're discussing the angles upon sphericity using a triangle with arced lines, which is the difference between Euclidean and non-Euclidean. Euclidean doesn't have these.
You're talking about spherical geometry then, not spherical trig, right? Please, Data, fix what you're talking about. You'll confuse people.
I'm talking about spherical trig and the application
of spherical.
You're talking
about spherical geometry.
I'm talking about trigonometry.
Spherical trig is Euclidean.
It is Euclid. It's all Euclidean at its base.
Spherical
for sure.
Geometry isn't Euclidean.
I'm talking about
non-Euclidean.
And I'm talking about.
That's why there's a difference between spherical trig and spherical geometry. And it seems like you need to learn the difference between the two.
Well, I'm always up for learning more stuff for sure. It's an endless pool of information here.
Well, I think spherical trig got done about 300 AD, something like that. And obviously, non-Euclidean geometry was invented a lot later, a lot later. So spherical trig can't be part of spherical geometry because non-Euclidean geometry wasn't invented until the late 1800s, was it? You've researched it more than me. I just did the Euclidean stuff. We stick with the simple stuff. It's been interesting. It's been a good Friday night, I think. Not too sure. But everybody's pissed off. I would be. If I tuned in to the usual Friday night free-for-all and like, oh, fucking hell, it's data. Shit, I thought he'd gone. Sorry, people. It is free for all, and it has been good. We get a chance to go over. I don't know. Did anybody else learn anything? Or does it just seem like we talk to people with endless arguments that go round and round in circles, going nowhere?
We're talking about proofs, right? Experiences, proofs. We're talking about objective reality using Euclidean, but if the Earth is much bigger and they conclude that the Earth is massive, we all know it is. What two? Mainstream, yeah. So when I say they, I'm talking about mainstream academia, mainstream. Let's just say, when I say they, let's say pop culture, right? Pop culture media, pop culture science, pop culture education, whatever you want to call it. They have a narrative or a philosophy or a belief system about where we live.
You think they have a perceived thing?
I'm only regurgitating what they have portrayed for themselves, right?
Within this argument, the people you've been talking to, those people have made you believe that they are the consensus, right? They are the people that give you the received opinion. So therefore, you think, because they've told you there are billions of people that have that opinion. But what is that opinion that you think everybody has? Do you think everybody out there has the same opinion as you, that if you think Euclidean geometry, if you use Euclidean geometry, or, you know, apply Pythagoras or pi, obviously, then you're a flat earther? Is that the received opinion of everybody out there that you think?
If you're going to discuss one branch or one area, and you consider it to be because you need to teach logic or reason or whatever it is, then you should be teaching logic and reason into both explanations to find out the logic and reason behind both philosophies.
Both what philosophies?
Well, the philosophies that the Earth's a ball or it's flat.
No.
And how do we, right? Unless the show is not about that. Your show is about proving.
That.
If it's just about
talking
Euclidean,
to people.
Sure. If it's just about talking to people, sure, have fun at her. Mm-hmm. But if you're going to localize it to one context, in the context that favors straight lines and angles, objective reality, Well, unfortunately, you have leaders like Ronald Reagan telling people, "Hey, if you obey your
Ronald Reagan, what is he?
If you
is
have,
he even alive?
If you have in his speeches,
he
says,
is he?
In his speeches, he's told thousands, hundreds of thousands of people that if you obey your senses,
when did he do his last speech?
Oh, this is probably in the 80s somewhere.
In the 80s,
but he did. Yeah, in his speech somewhere, he said, or wherever he's doing his speech, he just said, you obey your senses. The earth is going to appear flat if you obey your senses, right? Well, your senses, my senses, your senses, everybody's senses who come to your channel agree with objective reality and their senses. So if you're going to agree with objective reality and your senses, you will be pigeonholed towards the flat earth group siding of it. But the simple fact is that
you have to ignore if we're talking about Euclidean geometry.
That's just going to be the labeling. You're just going to get labeled that way because it's objective reality and it's about obeying your senses. Well, wait
a minute. Flat Earth data, right, says that we are going to get pigeonholed with flat Earth because we were talking about Euclidean geometry, and state quite categorically that it's dead easy to prove it's not flat.
Sure, it's not flat. We have hills and valleys.
Okay,
but
why would anybody who can prove it's not flat get labeled with flat Earth for talking about Euclidean geometry and basic logic? What's up with that sort of thinking? What sort of a muppet would think that?
Because you are agreeing with objective reality and you are obeying your senses. With the globe model, you have to ignore your senses and you have to look at reality as something else that's not being represented. Where Euclidean geometry is saying, hey...
Do you like talking about fantasy?
Not really, no.
Well, where does logic and senses combine?
I say again?
Where does logic and your senses combine?
I'm just saying that when you look at something and you're measuring something, the difference between looking and measuring will give you a definitive answer. You could look at something, but if you measure it, you can measure it off. But if you measure something, you know that you can look at it and have the correct measurement because you measured it, not just looked at it. So when you have the difference between a phenomenon where you can measure it and a phenomenon where you just look at it, well, then you're going to have logic come into one area and philosophy come into another area. And the logic that comes in is the applied, the physical, objective reality. Unfortunately, anybody who wants to be associated with physical, objective reality is associated with denying the sphericity of Earth. It just seems to be a correlation between denying your senses and fall Earth to as obeying your senses and accepting objective reality for what it is, and therefore
correlation between calling yourself flat Earth something.
Again, there is no book written, there's no conversation written with the data put into place. There's nothing. I don't see anything where it shows the conversation. I don't see anything. All it is some historical things that happen between some guys, a handful of guys, just like nowadays, really. I think it's a little bit bigger than back then, obviously, because of the internet. But there's no content that I can find in any of those books, whether it be Gleason's, whether it be Wallace, whether it be Gerard, whether it be DCS Lewis, or Cecil, DS Cecil, whatever his name is. Whatever those books are, they are not encompassing what's going on now. And when I started that name, that is the most, because it bugs two sets of people. It bugs the Globers and it bugs Flat Earthers.
So you want to bug everyone?
Not bug everybody. It's not about bugging everybody. That's not the case. The case is that if you're going to take on a role or a position, what's the best way to get the information from both sides? Well, you have to know the argument from both sides, right? And then when you're going to
you play both sides.
Well, you need to know it. If you're going to be truthful about anything, that you have to know, you'd have to know the extent of where both sides are willing to go. Now, both sides are guilty of lying. Both sides are guilty of making bullshit up. Both sides they're all guilty. Now, the question is why? And it's because it all comes down to philosophy. There is fuck all that you and I can do to prove where we live, but we can use basic tools that don't care where we live. It has no indication of the environment, it's pointless. So you, by teaching logic and reason in this show and getting people to look at geometry for what it is at an ontological principle, basic, that's a good thing. That is great, but unfortunately that will be labeled as flat earther, right? Because it's going against
because people like you say it's okay, right?
No, anytime you go against logic or reason, or you have something that's falsifiable, you already now are outside of a realm of you're now not inside the realm of philosophy when things can be falsifiable. When things are unfalsifiable, now you're always going to be maintained. You're always going to be in a realm of philosophy when it's unfalsifiable, and that's the particular globe model. It's unfalsifiable, so you're always going to maintain a philosophical point. Now,
you think the globe model is unfalsifiable?
I believe a majority of the claims are unfalsifiable. Yeah, for sure.
Interesting.
That's why it's based in. It's the same thing about the shape of the Earth. Whether
I guess that would be going along with the tag that you have no proofs, right? You just have evidences.
Well, evidence would be a body of evidence would be building proof, right? That's why you would build evidence, so you could present it as proof, right?
Yeah, but yet you still say unfalsifiable.
There's a lot of the model that I can't falsify. That's correct. I cannot falsify if there's a center of the Earth. I cannot falsify the actual size of it. I can't falsify, if it's people living upside down. I can't falsify if it's traveling around the sun. I can't falsify any of that. Now, what I can look for.
What about Mike's put in the chat there? What about a 2D sphere? Do you think that's unfalsifiable?
If you have a model in your hands, no, you can. It's not unfalsifiable. You can falsify it. Yeah.
Okay.
And so, for instance, one way you can falsify the ball model, in this case, I know I said the heliocentric model is unfalsifiable at a grand scale, like, traveling around the sun and so forth, and what dip and drop it has. What you can do is you can falsify an actual model ball by taking a real replica of the model Earth and having 2 points on that one longitude line, and you can falsify that. The toy models don't work for sure. You can do that by practical demonstration with light, shadows, and angles. And I took that off of a science channel, actually, where they falsified the toy model.
Do you know the difference between a paralogism and sophistry?
Well, sophistry is, what I understand it to be, is a way to make up ad hoc examples or stories to strengthen your position, but there's actually no way to test the claims. A paralogism is like a reasoning or logic built on facts or evidence. I can't remember now, actually. But that's
fallacious
what I would say.
Reasoning, paralogism, but because it's built on faulty logic. And sophistry would be with the intent to deceive. So sophistry knows the truth value behind the claim, yet tries to deceive. And
that's what the Greeks were, buddy. All the Greeks were sophists.
And
it's well known. In fact,
is somebody that builds it on faulty reasoning, right? So the sophist has an intent to deceive, and the paralogist is just like a fallacious reasoning. Now, we've been going over that just recently, Now, obviously, nobody ever wants to admit to being a sophist, because even a sophist would try and get out of that, because they'd obviously be clever and know the truth value. Whereas a paralogist or paralogism is built on faulty reasoning, but they've come to a conclusion because they think it's proper logic. So they can't really see the fault in their reasoning. And that's what we're studying at the minute.
Well, like that's good.
Is that a philosophy, like you say? Would there be a philosophy based around that?
Of course there would be, for sure, yeah.
Right. Sweet. What would you call that philosophy then?
Well, if you're into deceiving people... I mean,
that's sophistry. No, I mean, we're talking about the difference between the two, and how do you tell the difference between the two?
Well, you'd have to, if you're looking at falsifiable claims, I would look at something that would be testable, demonstratable, and that's why I look at...
what we're saying is the difference between the sophistry, obviously, somebody knows the truth value but leads you astray, tries to show you faulty reasoning. They try and push...
It would come down to the falsifiability of their claim,
fallacy,
and
right? Whereas the other one comes to faulty reasoning through a fallacy, right? Now, it's at the point where somebody points out a fallacy that could be a sophist, right? That's genuinely trying to push a fallacy on you. Or it could be a paralogist, right? That's just come to faulty reasoning. But it's at the point where you point out and say, that isn't that fallacious, that at the end. It's at that point that people sort of realise, is this sophistry? Or is it just faulty reasoning? Now, how are you meant to know which one of those it is? And...
them in lies. I imagine this comes from a duration of interaction from them or with the individual, and like for something like Rumpus, I think he's a sophist. He's not somebody who's under false reason. He has faulty reasoning. They're all fallacious to a degree, but Rumpus goes out of his way to mask the fallaciousness with consensus or with humiliation tactics or appealing to authority, whatever strategies he uses. It's usually appealing to humiliation to get you to believe his sophistry. I don't think he's at the point where he's just under faulty thinking. I think he's intentionally going out of his way to be deceptive. And so I think that judgment comes from multiple interactions with the individual, as opposed to somebody having faulty reasoning that the Earth's a ball because you've been told it's a ball, and that's your reasoning for it, right?
Yeah, I think I'm getting a picture of it.
Now, what do you think about all the Greeks, the majority of them being sophists?
I think it meant something different back then.
Well, they took pride in it. They took pride in it, number one. From what I remember, they took pride in being sophists because it was a way of winning a debate and an argument with colorful, language skills, right? So I think they're
fooling people.
Well, that's what I think they took pride in. I mean, when I read about the Greeks when they debated, they would drink wine and slit their wrists and sit in warm baths of pools and debate. So they probably took a lot of joy in debating, in different manners. So whether you debate as a sophist or you're going to come with a whole bunch of fallacious arguments, I think it was probably exciting to have a whole bunch of fallacious arguments and try to win an argument with those fallacious reasonings. I think that's
You think somebody took pride in knowing the truth but fooling somebody?
You got it, buddy. You 100%.
I'm asking you.
You got it, of course. What do you think with the world we live in? It's built on that.
Yeah, I think that's paralogism itself.
Do you mean because it's been handed down, therefore, because it's handed down, there's no critical thought by it, and therefore it's not fallacious because it's just my uncle thought it, my uncle's uncle thought it, my uncle's uncle's thought it, so therefore it must be true?
I think you can be taught paralogisms, yeah, easily.
Yeah, but
it depends how much the will to have the conclusion, right? It's all based on that.
Hey, is this live?
Yeah. Oh, we are going to end it though, pretty soon.
All right.
Yeah. Cool. Okie dokie. I'm going to end it. But finish off with the Buster song. What time is it? Anyone want to go and do that? Anybody want to come into the Discord? It's going to carry on probably. I hope not too long. But it is the weekend. Friday night. And I don't know when we'll be back. Buster. Anyone? Can't have a big long one. Okay, Logos. Thank you very much for watching. Come back Monday, whenever. See you later, Buster. World famous Buster, Logos.
It's the echo in your brain. You know you can't sustain the misconceptions in your mind. One day you'll see for sure what all of this was for. Then you can leave it all behind. The journey begins. I am the one, yeah, that will show the proof. I am the one, yeah, that is searching for the truth. I am the whispers of the logic in your mind. I am an agent of the Logos. In the beginning was found this thing that cannot speak. It's how we all truly learn. It's only ever attained when one lets go of fear. So don't let wisdom pass you by. The journey begins. I am the one, yeah, that will show the proof. I am the one, yeah, that is searching for the truth. I am the whispers of the logic in your mind. I am an agent of the Logos. It was there all along. How could I never have seen this thing that's danced all around? It wasn't until I left behind the things I believed that I could see things so clear. The journey begins. Become the one, yeah, that will show the proof. Become the one, yeah, that is searching for the truth. Become the whispers of the logic in their mind. Become an agent of the Logos. Become an agent of the Logos. We are the agents of the Logos.